and dozens of people on GitHub and contributors. There have been 3 major conferences this year only about React, and this is the 4th one. We're actually one of the biggest one in the world dedicated for React only. And there are like 35 or more user groups only in Europe that are interested in React. And these wonderful companies and more are using React every single day in their products. And I'm very happy to say that some of the companies you see here, we're going to have speakers from there, from Silicon Valley, from Berlin, London, Sydney actually, Melbourne, flying in and giving talks. So that's why today we're here for Reactive. More than 500 attendees of the conference from all around the world. We actually have some people flying in also from the States just to listen as an audience, so great shout out to you guys that you managed to come here. We have people from Finland, Germany, like all around the world basically, and Europe especially. We have 25 speakers that came here. We're gonna have 2 full days of content. And as I wanted to say, we have amazing partners that we managed to do this only thanks to their help to build this conference and to create it. First of all, the event is organized by Vacuum Labs as a company, and the main partners of the conference are STRV, and we thank them so much. It's a software company from Prague, and they've been here yesterday as well on the workshop days and providing great content. We have silver partners as Microsoft, Avocode, Formidable Labs, Erster Group. We have the main media partners of Živě Startup, the bronze partners of SmartBase, Futurist, the Time for Slovakia, Tatrati, Soundset, and Slido. And we have a transport partner that is very important to mention, that you have it here on your badges, on all of your badges. You can look for a coupon or a discount code for Uber, and it's Reactive 2015. So if you're gonna use Uber in Slovakia, and yes, we have Uber here, you can just add the code, and you're gonna have 30% off from all your rides during the conference. So don't forget to use the code to have cheaper rides in Slovakia. But right now, what I'd love to do is to invite the CEO of Vacuum Labs on stage to give a couple of minutes, an opening speech for the conference. So please welcome Samo Hapag on stage.
Hi everybody, thank you for coming. It's really amazing that 500 amazing people are meeting here to talk together, to talk about JavaScript, about React, about future web technologies. I'm really glad to have opportunity to hang out with you guys, and I believe that we are starting something amazing. This is third main React conference, and I hope there will be more. Thank you.
I have to say, Samo is an amazing guy. He's been working like nonstop for the last 3 months to make this happen with his team. So it's like a great thank you for Samo and his team to manage this. Now I'd like to invite Lubo Smith on stage to give a little bit an introduction as well to all of you and to open the day with you.
Good morning. Yeah, it's glad for us. I'm really glad to be here and represent STRV as the main partner of the conference. We do mobile and web development. We have been doing it for quite a while. We work with Silicon Valley startups, and we see React and React Native as a huge thing. And that's why we thought that we would partner up on this conference and help bring it to you guys, because I see that the room is packed and you are all really excited about this new technology coming up. And we bet big on React and React Native, so that's why we basically decided to support Matěj and his team to organize this. So I hope you will enjoy it, and if you'd like to learn more about STRV and what we do, we'll be around. We all have these t-shirts, so you will easily find us. So enjoy the conference.
Great. For a long time, we've been good friends with the American Embassy in Slovakia, and I'm very happy to invite a great friend of mine, Dominic, on stage to also give a short few words on opening the conference. So please welcome Dominic on stage.
Thanks, Mate. You know, I'm an American diplomat, but one of the toughest acts to follow in Bratislava is Mate Fajnik. He has a poise and confidence that it's hard to match, but I'll do my best. Good morning. As Mate introduced me, I'm Dominic Wynn. I'm Political Economic Officer at U.S. Embassy Bratislava, responsible for entrepreneurship and technology issues. On behalf of the U.S. Embassy, I just wanted to extend a warm welcome to you all. Welcome you to Bratislava, particularly to all the participants who traveled far to be a part of Reactive 2015. I want to thank our good friends, Mate Fajnik and Samuel, for this opportunity to come here today and meet you all. So why am I here? Well, our U.S. Embassy has been committed to supporting and growing this innovation ecosystem here in Slovakia. We want to support people like Mate and Samuel because they've been there from the beginning to help nurture and grow this ecosystem. And we just wanted to say that we're incredibly fortunate to have here an amazing roster of talented developers, speakers, and founders for some of the leading U.S. technology companies. Companies like Mozilla and Facebook and Netflix, companies I actually use myself as well. We're also pleased to welcome members of the React.js community from all over Europe, and to have leaders in the field in deploying and using React JavaScript come here to Bratislava is a tremendous mark of how much this ecosystem has grown. And I'm sure it hasn't escaped many of the participants, particularly if you went out last night, that Bratislava has a very thriving social scene, incredible networking opportunities with the tech community here. Slovakia, for those people who don't know, has a dynamic and visionary entrepreneurs. They're committed to building innovative businesses. And for the people who are engaged in Slovakia's startup scene, their passion, their energy, it's inspiring, if not contagious. I know from your program that yesterday you had a few workshops on how to use your first React Native application, how to design your own React tools. And I thought for a moment that this is my opportunity. This is my gateway if I want to change careers. But Mate said I can only come for the second day. So I'm hoping that this is the first of many React conferences. Maybe next year I'll get my chance. And when you get back from wherever you hail, get back to the US, please spread the word about Bratislava, this hidden gem of entrepreneurial, programming, development talent here in the heart of Central Europe. Let them know about Bratislava. And I wish you a very successful conference. Thanks.
Thank you. Thank you, Dominic. Cool. I see people coming in, and don't be scared. There's still space, so just come in and sit down anywhere you like. Or you can go for the first floor lobby from which you have a very nice view of the conference as well. So feel free to grab a chair. Now for the important things, internet and Wi-Fi. So log in. You have the Wi-Fi password on your badges. So if you look at it, it's Reactive 2015 is the name of the Wi-Fi, and I am Reactive is the password. So be sure to log in, and this is going to be a stress test for this room. So hopefully we're not going to destroy it. So if you have your tablets, computers, iPads, and laptops ready, just connect all of them just to make it crash so easily. But otherwise, just minimize it to 1 or 2 devices, please. And they said we should be fine. The official Twitter hashtag is GoReactive. And be sure to tweet. We have a live tweeting wall right here, so you can see your tweets and see what other people are sharing and talking about. And then we have a innovation from Slovakia called Slido. And Slido is a pretty cool conference tool. That Slido is also used on South by Southwest, on the Next Web, on Dublin Web Summit, on all different huge conferences, and also here in lovely Bratislava, to engage you guys with the, fantastic. Yes, that is exactly what's supposed to happen, yeah. Yes. We're back. Engage you guys with the speakers. So the last 5 to 10 minutes of every speech of a speaker is going to be dedicated for a Q&A. And to make it simpler and easier for all of you to ask questions, you can use Slido, where you're going to just log in, ask the question, and we're going to show it upstage in the big screen so you can easily read it out and use it. So be sure to use Slido, as we're going to be using it during the course of the next 3 or 2 days, actually, because we had the workshop day yesterday. So right now I have the great chance just to welcome you here and you know, invite you to a great 2 days of a conference, and I'm going to leave the stage for the first speaker out of Mozilla, James Long. Thank you so much.
Good morning, everyone. All right, thanks for getting up early for my talk. I know it's hard. I am James Long, not the fashion designer in London, which is what Google will try to tell you I am. I work for Mozilla on the Firefox DevTools, and we've done a lot in the last few years. We've been moving really, really fast, but the problem is when you do that, you usually accumulate a lot of technical debt. Especially on our front end. We pretty much just haven't had a whole lot of time to think about more innovative and cool ways that we can do our UI. And not really just cool, but things that actually solve very big problems. So right now, we're doing a lot of things that just make things harder. So we've been talking a lot about what we can do about this. And specifically, of course, I've been thinking about how we can use React. So I've been talking to my team about that. But it's really, really hard when you already have this big project because refactoring sucks. It's a lot of work for very little short-term gain. You're having to replace a lot of code without adding anything new. And if some people don't believe in what you're trying to do or don't actually see a whole lot of value in the things that you're adding, you're just wasting time. And you know, you may actually just do the wrong thing until you are just wasting time. I mean, just imagining updating all of your tests, it's just a very hard problem. Additionally, you still need to be shipping features while you're refactoring. That's probably the hardest thing about refactoring, is that you can't just pause the world and stop development for 6 months. So in that way, it's kind of like changing a wheel of a moving car. And actually, this GIF makes it look awesome. If only refactoring were this awesome, because that is ridiculous. They're actually replacing 2 wheels at the same time. You know, it's actually more like this. It feels good at first. You're cleaning things up, and you're like, oh, this is cool. I'm going to solve all these requirements. And then it just goes to shit. Yeah. And it's also hard because it's tempting to look at something like this and think, wow, this looks really bad. We need to clean this up. But what you actually forgot is that this is actually an elegant solution given the actual requirements. The requirements were naturally complex in this case. This highway needed to connect all of these roads, and this is actually very well designed if you understand the problem. And so it's easy to look at code and think that looks bad, but sometimes it naturally is just complex. So refactoring is really hard because you have to figure out which wheel to replace, and additionally what to even replace it with, because you need to come out better on the other end after you've been refactoring. So you'll lose all of these nuances and edge cases that you've already solved. So we can't lose those. So we have to figure out a way, how can we get rid of all these problems that we have and use something like React, but still kind of keep the essence of what we have. So there's this idea of inherent versus incidental complexity. I'm sure all of you all have heard this, but you need to kind of sort of learn, again, which parts of your code base is just built up incidental complexity. Either it's things that we're solving requirements that aren't actually requirements anymore, or it's just bad code, and try to remove those as much as possible. So think hard about what you really need, because every abstraction has a cost. So I think you should be very ruthless about only adopting abstractions that you actually get benefits from, because otherwise you'll still pay the cost of the abstraction. But if you're only getting little benefit from it, then it's probably a net negative of the complexity that is adding to the system. And this is, over time, your requirements change, and so maybe an abstraction that you actually were getting benefits from, you're not getting it anymore, and you just sort of have to put up with it. I mean, for example, some people may like promises. Promises, for example, it's an abstraction. It's an abstraction over async work, and it's a good way to do async values. And it has things like error propagation, which is nice. But it also tends to make errors silent, because they just eat errors. It just eats all your errors, because it has to, because of the way that it's meant to work. But if you forget to attach an error handler, or your tool chain isn't connected the right way, your test may be failing and you have no idea. This actually happens to us. And additionally, the semantics are just sort of confusing. So there is a high cost to promises. There's also high value if you actually need them, but you may not actually need them as much as you think. So when trying to migrate existing code especially, only add as little new abstraction as possible. Don't just jump to this whole entire new stack or this new framework. I think you should leave room to grow in the future, and that's why I tend to prefer things like libraries over frameworks, because you can sort of incrementally adopt what you need, and in the end, you only, after you've migrated, maybe it takes 6 months, maybe it takes 2 years, what you are left with are just the things that you need, and I think that's super valuable. Because you really want to come out better on the other end after you have been doing the refactoring. So, bad abstractions sort of can feel like this. I mean, that may be some really nice wood that those balls are rolling down, but you just want to turn on the light. That's all you want to do. You don't need the whole framework. You just want to turn on the light. So what we want to get to is this, where it's a very, it's a well-oiled machine. Every single piece has a purpose. So how do we do that? If you're already stuck with the Rube Goldberg machine, how do you get to this? And I think you just start simple. You can start migrating pieces of your app, pieces of your code slowly into a new architecture, which is ideally sort of simple at first. And as you do that, you relearn your requirements. And so as you're migrating things over, you can see things that are like, I don't even need that anymore. I'm just going to, which is another reason why it's important to start simple, because as you start simple, you can add things back to it. So again, you can build it back up slowly as you're migrating pieces and pieces over. So this is a very long process, right? I mean, because we can't just do a total rewrite. We can't just ditch a lot of our code because we've already built up business logic, which actually is solving some complex cases, which is naturally complex. Okay, so when I'm looking for abstractions, when I'm looking at different libraries and frameworks, I have a couple core principles that I like to think about. I think that it must be composable. Is it easy to reuse? Can I use it wherever I want? It must be testable. Can I load a single module and test it independently outside of the system? Can I replay what happened? Can I send it off to somebody else? It must be debuggable. Like, can I actually do the replaying functionality? And it must be live reloadable. Can I change code and it just magically appears in the app? Now, this seems just like a fun feature, but this is actually what I think should be core to development. And I come from a deep Lisp background, so this is very embedded into me. I think live reloading is a super important feature for development. I mean, when I see developers doing code that is in an architecture where live reloading works really well, it's a huge, huge boost to our productivity. Now, all of these things actually have one thing in common, and it really could come down to just this one question. Is it stateful? Because if it is internally managing its own state, then it sort of violates all of those principles. It's hard to test it. We can't get to that state if we want to. We can't live reload it because you want state to persist across live reloads. You can't debug it because you can't look at the state. So for example, this is a typical JavaScript pattern. This is sort of how we use the classes, and of course there's now ES6 classes, which isn't a whole lot different. We construct a user. We have a method on the user, is scary, and we construct a user. I'm not scary because I have 2 eyes. What is the first thing that we do here? We mutate the object. We mutate ourselves. So this pattern encourages mutation, which is just really, really bad. Because it's very hard to track what is going on in the entire system when you have a big complex app and you have things mutating themselves in internal state everywhere. It's very, very hard to grasp what's going on. It's a lot simpler if we just do something like this. We just have a function is scary. It takes some data, and then it does some work on the data. And then it just constructs an object, which represents the user. Now, you may want to have something like a constructor, like make user, so that, probably is going to do some more complex things. But here, we don't need that, right? Again, just keep it simple if it should be simple. And what's nice about this is now that the data is extracted from the function, they're just 2 separate things. You can do simple things like, hey, let's wrap it into an immutable object. Let's use a completely different implementation of the data structure. And there are sort of ways to use sort of like a protocol so that it's exposing the data in a similar manner, using like getters and things like that. But you can use an entirely different data implementation if you have more explicit data in your throughout your app. And this is just a method, right? We can just live reload this method. We can just switch it out for a different implementation because it's just a method. We can just redefine it. These sorts of things get a whole lot more complex when you start doing a lot of like classes and wrapping things into themselves. Okay, so is this actually possible though? Is it possible to build a real-world complex apps with just pure functions and data? It seems like that's going to break down at some point. But the thing that I love about React and the React community is that they've really proven that you could do this. You can do this for a lot of your app. And I'm not saying that you shouldn't ever use classes. You can use them in certain cases at certain points in your app. But for the general architecture of your app, you shouldn't require that. It shouldn't be the API that you need. So let's just run with this. Let's see how far we can take this. Let's see what we can do with this. So let's talk about front-end development. What we need, what comes to my mind when I think of what I need for front-end development, is we need to render the UI. We need to manage state. We need to do asynchronous work. And we need to test it. And so where we are with the dev tools is we do manual DOM mutations for the UI, which is really hard to just keep track of. It's especially hard to create new things because it's hard to compose these sort of mutations. We have state in the DOM. We have custom JS classes, which maintain their state. So state is sort of spread out everywhere, and it's especially bad that there is state in the DOM because you're now dependent on the DOM for stuff. So it's very hard to rationalize about where state is. There's promises and events everywhere, like all throughout the UI, and it feels like a good idea, but I think it, again, just kind of makes some things harder. And there are very few unit tests for our UI, and that's a sad thing. So it sort of feels like this once you have this kind of architecture. You can lay this out as cleanly and nicely as you want, and everything is nicely exposing a promise interface and internally managing its own state so that you don't have to care about it. But you still, at an overview, you have no idea what's really going on in the system. To do anything here, you have to be intricately aware of actually every single little piece in the system. So where we want to go is we want to have a declarative UI, central app state, do async work in an explicit manner where there's atomic UI updates, and have a lot more unit testing. So if only there was a library that would allow us to do declarative UI work. Yeah, of course that's React. So that gives us components and declarative UI, and there's not even any DOM needed. We can do unit testing with like React components. I don't think I need to explain React at all if you're at this conference. So there's a complementary library called Redux, which I'm sure a lot of you are aware of, and it provides a way to manage the state. It's things that sort of are outside React's role. And Redux provides a central app state and Flux-style actions and these things called action creators. So Redux is a great way to sort of, that complements React by encouraging the concepts like a central app state. So if you think back to that diagram of that board, think about now, React and Redux are sort of the CPU and the GPU. It's a lot more bigger. There's much more of a coarse architecture where you have the central app state and a declarative UI, and it's easier to see how things pump through the system. Okay, so let's start very simple with this. We have our declarative UI, right? So think of this UI, this very simple green box, as a very complex React component tree. We don't really care how it's implemented. Data comes in, and it renders the UI, and then the UI can fire events. So, for example, this would be our declarative UI. It's just a function. It's just a function that takes some properties. We get the items off the properties, and we return a list of all of the items. It's just a pure function. It's great. Okay, so what about data, though? So for the data, what Redux encourages you to do, which comes from ClojureScript and some from Elm as well, is to have just a single JavaScript object. So this state object is just a single JavaScript object. This has some items of some names. And of course, in a real-world app, this would be far more complex and a deeply nested data structure. But the core thing is that it's just a single object. So that's cool. So what about events, though? What is that going to do? How do we do events? So Redux defines these things called action creators, and this actually sort of comes from the Flux world. This is the core idea of Flux, which was a good idea. And action creators are just functions. So they're just functions. This is an action creator, function add item, and they create actions, and they dispatch actions to the state. So dispatches this action. The action is just a dumb JavaScript object with a type field. So the action creators are just methods that create actions that are dispatched to the state. And then we define update functions, which take state and take an action and return new state. So that's another core idea here as well, is you never actually mutate your state. You always return new state. And that allows a lot of fantastic things. Okay, so that's pretty much it. That is the core idea of Redux and React and the combination of the two. So you have this very simple flow where you have state, the state changes. Whenever the state changes, the UI is re-rendered, and then the UI can call methods, which are action creators, which dispatch actions to the state. So this is very circular flow. But even just with this simple architecture, by organizing it in this way, we're able to do very cool things, like state snapshotting. So this is my blog, which I wrote in React and Redux. I have a bunch of state, I have some fields, and I'm going to be changing those fields. I'm just going to change some of them. And then I'm going to press a keystroke and get the entire app state serialized and just copy it, go somewhere else to a totally different URL, pull up that prompt again, and just paste in that serialized app state, and it's just going to load up what represented that app state. So this didn't change the URL or go to a different page at all. This is literally just pulling up what represented that app state. So just by organizing it in that way where there's a central app state, we can easily just snapshot the app, which is great for debugging. We can additionally do things like log and replay actions. So remember, action creators will fire these actions which update the state. That is the only way to update the state. What that means is that we can just log the actions, which describe everything that has happened in the system. So this is the debugger using Redux. I'm making some changes in the UI, and Redux actually has this great project called the Redux DevTools. So I'm going to pull open the DevTools, and these are all of the actions. These are all of the state changes that have happened in the UI that represent every single change. I can even inspect the action, what parameters did it have, and I can inspect the state at that point in time, which is very cool. It's very enlightening. And not only that, but I can replay all of the actions. So I loaded up the initial state, and I'm replaying all of the actions, so I can actually watch how the UI changed over time. And I could do this from anywhere. I could have a user just send me their state and their actions and just replay what happened. Now, these are somewhat gimmicky. Yes, you always see these things at conferences, and you hardly ever use them in real life, right? It's helpful every now and then. It's helpful, when you have a really hard bug. But the action logging is super critical because it allows you to have insights into what is going on in your app. It's just like you always have to go in and add console.logs whenever you want to actually see what's going on, right? I mean, hopefully you use the debugger as well. But console.logging is actually a very powerful way of debugging. But this, now that we have made everything into first-class actions to represent changes in the system, we can build that in naturally and just always log the actions when you're in debug mode. And that way you can always see what's going on. And I use that almost every single day. Okay, so we have that simple system. What about asynchronous work? This is something very important that I want to talk about, because this is where everything tends to get really complex. So this is where simple architectures tend to just either fall and fail, or just get super complex. So how do we do that? We have a simple system, but what if you wanted to fetch something from the server? Where does that fit into this? So if you remember those action creators, they're functions, right, that create actions. So it dispatches an action at some point in time. Action creators can actually dispatch multiple actions. So you can dispatch an action that represents the start of the request, and then you can later in the time when the response is received from the server, you can dispatch another action that represents the finished state of the whole request. So this start and finish, if you always do this in an action creator, you can do async work. So the finishing action will have the actual response, will actually have the thing that was returned from the server. But this allows you to do things like optimistic updating, or if you just wanted to show like a loading screen, you could respond to the start state. And so, you could have any number of async work things going on, firing actions into the system, but it all happens sequentially throughout the UI. So everybody says that UIs are inherently asynchronous. And I actually sort of disagree with that, or at least I disagree with the general, how a lot of people receive that. Because, this entire box right here is totally synchronous, as it should be. When you update the state, or when you fire an action, the updating the state and updating the UI happens exactly in that same function stack. It happens in that same tick. So the UI itself is actually synchronous, but we have this async work sort of going on outside this box. How we interact with UIs is asynchronous. So everything outside of this box is sort of the land of Mordor, which is all this stateful stuff going on. Within this box, it's nice and little pretty pure functions. If you know Elm, you know this probably is resonating with you very much. I actually, in some twisted way, like to think about this is like this is the pure benefits of Elm inside the box. This is where we can say pure functions. What Elm does is you actually will pass side effects up, because all functions are pure in Elm. You pass it up to the runtime, and the runtime will actually do the async work for you. So I sort of like to think of this as a dumb way of getting some of those benefits, where we force everything async into action creators, and they live just at a specific layer that's outside of our box. And so that's how you do asynchronous work in Redux. Is async action creators can just fire multiple actions, and they could be anything. You could use promises here. You could use observables or channels. You could use any async abstraction you want in the action creator if you want to do some complex sort of coordination. And that to me is really nice, because these have benefits. I'm not against promises entirely. I'm not against observables entirely. I think that they do have a lot of costs. And it's only worth using if you're actually needing the benefits that they provide. But here we can use them when we need them, but when you need to actually interact with the UI and the whole system, you don't need observables throughout your UI. And so it's nice to have just this simple system of pure functions. And we could even think about replacing that entire UI layer with Relay or Falcor. These are fantastic technologies. And it feels nice to sort of force everything async to be at this specific layer and model it a certain way, because maybe at some point down the road, if we're able to do this, we could just look at Falcor or something like that, which is super cool, and just get rid of this. Because this is all just plumbing, right? Async work is entirely just plumbing. You're just getting stuff from the server, and you're wanting to update that central state object. But really, in Falcor, could just automatically update that central state object, and then you just still work on your UI that automatically renders it. OK, so let's look at a little bit of code. So this is how you dispatch an action. This is what would be in an action creator. We just call dispatch, and then we create the action. An action is just a JavaScript object with a type field and then some parameters. What's nice about this, again, just to reinforce this, is that this is entirely synchronous. The UI is updated once this function is done executing. On the next line, the state has changed and the UI has re-rendered. So it's a completely synchronous way of working. So this is a more complex action creator. This would be an async action creator. We actually return a function that takes a dispatch function. This is actually done through middleware. Middleware allows you to take anything returned from action creators and transform it into something else. So there's a thunk middleware, which allows you to return a function, and it allows you to hook into the dispatch system. So we're not dependent on some global dispatcher or some global dispatch crazy thing that we're trying to hook into. We just return a function that accepts a dispatch function, and then within that function, we can call dispatch now. And that means that we can call dispatch multiple times. So we call dispatch, let's add the item with a status of start, which is the start of the request. And then I do a set timeout to represent an async request. And then later on, we do a finish. And so we dispatch a finish. So there's multiple things going throughout the system. And you don't want to do that for everything, because I didn't even talk about errors. You would want to actually have to check the error status of the response and make sure to dispatch in a status of error of the async action. So again, with the middleware, we can actually wrap this up into something nice. We've written something called a promise middleware. This allows you to return an action which has it defines the type, and then it defines the parameters. But it has a special promise field on it. And what the promise middleware does is it takes this and it transforms it into multiple actions automatically. So a start action, a finish action, and an error action will all fire at the right time. So now we have this really nice system to sort of take those async abstractions and splice them onto our synchronous action dispatching system. It might feel a little weird, like why don't we just take promises and just use them? But it's the whole concept of let's just use pure functions as much as we can. And doing this, I found, is really nice because it also allows us to use any async abstraction as we want. If we only accepted promises or only use promises as our interface, we could never use observables. You don't want to just depend on a single abstraction throughout your entire app, because otherwise you can't mix and match them as you need. So you might not need promises and observables or other async abstractions or channels, because they all incur pretty big costs. Again, promises, they eat your errors. I mean, that to me is the biggest fail of promises. They also tend to, promises will run your code over several ticks, and so promises tend to be, if you're using promises throughout your UI, it tends to introduce race conditions, and that's something that we've had a problem with. I think at the core of your UI, that's the brilliant thing about React is that they have just a synchronous render function. So you might not need some of these things. Only need them if you're actually needing to do some special coordination of async work. Okay, so I talked about needing rendering the UI, managing state, and doing asynchronous work when we're doing front-end stuff. The last thing that I've thought about is that we need is testing, right? A lot of things also comes out of this architecture of just using pure functions and data. It becomes a lot simpler to test. State updates, the update functions which take state, take an action, return a new state, they're just functions, right? So you can just call them with any state that you want to and an action that you want to, and just check that the return state is what you would expect. It's just a function. I mean, you don't need to do anything else. React components are basically just simple functions as well. They might have some other special lifecycle methods, but in general, you can just pass some properties to a React component, make sure that the JSON structure that it rendered to is correct. You don't even need the DOM. You can just unit test every single React component in the way that you want to. It's super simple. Using pure functions is just awesome. Action creators are a little more complex. There's still generally simple functions that are generally pure. in the fact that they don't depend on some global state in your app, but they're still stateful because they're async. They tend to be async, so they're a little harder. But if you know how to test async work, then you can still do this. And action creators might need a little bit more weird things like needing to mock some APIs. So action creators are a little hard, but it's a lot better than your whole app being really hard. So there are some other interesting ideas now that we have this architecture, now that we have this kind of observable changes in the system through actions. Like we could record a workflow. I could start recording, I could like make some changes in the UI and say, make sure that I get to a certain point in time, and then I could save that whole session as a test and say, run through all of these, or given this initial state, run through all of these actions and make sure that the state is what it should be at that point in time. Or maybe it just shouldn't error. Maybe it should actually just make sure that it successfully runs through that session at the right time. So I'm not sure. It could be a cool idea. Another probably more interesting idea is generative and property-based testing. This is super, super cool stuff. It's basically just generates random input and will it just dumps random input into your function. And property-based testing allows you to make sure that the output is correct. So you can actually, for UIs, you might say if a checkbox is checked and this other thing is selected. So I played around with this. So I wrote some code using the GenTest library that generates app states. So this is what it looks like to generate app states and dump them into the UI. So this is just literally creating as many UIs as we can using any random data. What's interesting about this is, this is sort of more of a fuzzer, right? This isn't doing property-based testing, but you could easily do, this is just kind of a fun hack for me. You could easily extend this to do either property-based testing, or you could be dynamically creating actions. Okay, so the core principles are, must be composable, testable, debuggable, and library loadable. It's very, very solved using just simple functions as much as possible and a single essential app state. So the Firefox is actually having a release today. You should go download it. One of the things new in Nightly that we just built is a memory tool. So this allows you to show all of your memory, where it's allocated, what is taking up the most space. This is all written in React and Redux. So this was our first prototype into actually using it completely, not just migrating single code. I can't take credit for this. Actually, my teammate Jordan and Nick Fitzgerald and other people actually did some fantastic work for this. So we're slowly doing this. We have a lot of code. We're not gonna be anytime soon using all like React and Redux, but we're very close. But if you're interested in contributing, we're all open source, of course. So contact me. It's a little awkward right now because we are trying to figure out this very hard migration phase, but there might be things that we can find if you're just interested in doing React stuff. But I think in a couple months we'll be in a really good place to take React and Redux contributions. So that's it. Thank you.
Great, cool. Thank you so much. I think we have, 2 more minutes left. We can open the questions. If we can switch it to Slido and see what are the questions on stage or on the system. So you connected all your computers and all your tablets and all your mobile phones. We're reconnecting, so. Could we refresh the screen, please? Hopefully.
I can try to go there.
You can try it, right? I'm not sure if we have enough time for that. So.
Yeah.
No questions at all.
Okay. That's
In
fine.
the morning, there are no questions at all. Okay, guys, you should ask questions. The system should work, so ask questions and it's cool. So nevertheless, thank you so much for your talk, and give it up for James, please. No worries. Just Okay. So guys, after this talk, we're gonna have a 30-minute coffee break, so hold tight, and then after this talk, you can go out for some coffee and water. Yeah.
Hi, everybody. All right, so let's get started. First of all, I'd like to say thanks to all the conference organizers for inviting me to be here. This is actually really special. Falcor is a project that I slaved a good almost 2 years on, so it's really cool to come and get to show it off to everybody. Before I get started, my t-shirt right here, I have a bunch of these, and hoodies too. So if anybody wants a really cool Falcor t-shirt or hoodie, let me know, because I'm not taking them back to the US. My name is Paul Taylor. On Twitter, you can find me at trexcellent with no vowels. People think it's related to Trick Cereal, and it's not. I was a founding member of the UI platform team at Netflix, and my first project was Falcor. So I guess let's get started. So we started with the idea of Falcor with the observation that every user wants to believe that the entire cloud, like all the data out in the cloud, is on their device. Users behave that way. They constantly scratch at the screen until the data loads. Like, we're really just impatient. And that's fine. So then we let ourselves know, well, that's obviously not true. You know, we know that's not true, but what if we could code as if it was true? And that's where we started with Falcor. But before, actually, I don't know why my notes aren't showing up. This is, nope. So, all right, cool. Okay, so going back in time a little bit, even before I was at Netflix, we had the concept of REST. And we asked ourselves, like, what's the most successful distributed system ever designed for browsing information? And obviously, it's the World Wide Web. And now this isn't going forward, so I'll just do it on my computer. There we go. And that's great, because Netflix ultimately really is a browsing problem. Users just scroll through an endless library of movies for hours at a time trying to figure out what they want to watch. And for a long time, Netflix had a RESTful API. Pretty standard, you know, request movies or lists by IDs, and then the server returns you the data. But the services weren't granular. So as Netflix expanded and built more complex user interfaces, we found we couldn't, this wasn't flexible enough to build user interfaces efficiently. Because we had sort of monolithic services that would return you lots of JSON. Well, what happens tomorrow if we introduce a new A/B test and half the users don't need that data? Well, they're downloading it anyway. So we started building, that's House of Cards. So we started breaking up our services into more granular services. But then we got slammed with the idea that, especially on mobile devices, there's a lot of latency, especially on cellular connections. You know, just every single network request you make has just some latency in the network. And that's really an artifact of how HTTP was designed. When it was designed, the web was a place to get things like documents and text files, maybe small little executables. But nowadays, the web is a place to do things. We have web applications that will tend towards more granular services. So web pages serve small amounts of large resources, but web applications serve large amounts of small resources. So in 2010, as we transitioned into being a more a service that was on more devices and everywhere, much more dynamic, Netflix's RESTful API became a restless API. So we took all of our URLs that we had that used to be unique, that the browser could just cache, and we started adding dynamic properties to them. This is the other great design pattern for distributed systems is RPC, remote procedure calls. Each different platform could say, all right, this is my state, this is the stuff that I care about, but then we don't end up with our unique URLs anymore, and all of a sudden our resources aren't cached. Because with RPC, you might be requesting for the same piece of information via a different URL. So yeah, same info, two different URLs. So what we wondered was what sort of programming model could give us the caching benefits of REST with the loose coupling that we get through HTTP redirects, but then the small message sizes and the low latencies of RPC. And that is where we got to Falcor. Get some water real quick. Really should have done this before the talk. So Falcor, what is it, beyond a really cool name for a project? Well, I'll tell you what it's not. It's not a replacement for your database, your MVC framework, or your web server. Falcor just fits into your existing stack without messing things up, but it allows all the layers to communicate more efficiently. So what we do with Falcor is it's a combination of a local client library that creates an in-memory cache and the idea of a big JSON object in the sky. And effectively, that JSON object bridges the gap between your client and your distributed systems everywhere. If you know anything about Netflix, it's a massively distributed architecture on the back end. But we don't want to burden the client with that information. Let's see. So on the client side, it gives you an async model, an instance which you can new up and you can request data for, just like you would if it was if you were using REST, but so with the same paradigms, but you don't know that it's doing the caching for you. The async model also allows you to execute remote function calls, but in a way, like function calls have side effects, like if you add something to a list or remove something from a list, you need to be able to communicate those side effects back to the cache through either invalidations or value updates. So how does this work in practice? So ideally, the server implements, at least at Netflix, the server implements what we call the Falcor router. And the Falcor router is that big virtual JSON object in the sky. It doesn't exist. It would be too big to hold in memory on any one machine because it's just tons and tons of information. But we're going to pretend like it exists. So the client, when it's going to load up and it needs to render the view, the client locally will ask its async model for some small part of that cache. The async model knows that it doesn't have it because its cache is totally empty, and it goes to the server and tries to get it back. The server says, oh, cool, yeah, here's this little piece of data. Here, sends it down, and the client can store it in the cache and fulfill the request and render the screen. So then the user starts interacting with the application, and they do something else that we need data for. So we just do the same thing. The cache goes and says, all right, cool, give me that little piece of the cache, and then we can render the next screen. And lastly, get this next one, go into the movie details there. And now we've got like some small part of our large JSON graph in the sky locally. But what happens when we go back? So if we hit the back button and go to this screen again, we'd be making the request for the same piece of data we already got. But the async model is smart enough to know that it doesn't have to go to the server to get it. So it can fulfill on the client side, it can render the view synchronously without the view you having to change any code that you wrote. So what does Netflix look like on Falcor? It doesn't look like an omelet, I'll tell you that. The Netflix domain model is ultimately a list of lists. It's just a list of lists. They call it a Lolamo. Each list contains titles, and each title has little bits of information about the movie that you're looking at. But as you notice right here, we see House of Cards, and it's actually in two different lists. We've got House of Cards in recently watched, but also House of Cards in new releases. So we've got some amount of duplication there. But what really that means is Netflix's domain model isn't a tree, it's a graph. So here you see the same title, Friends, in two different lists. And on the server side, really, it's a graph. But when we send it down to the client, how do we, it's just JSON. JSON is a tree. How do we communicate that to the client that it's actually the same resource? Traditionally, if you have a graph on the server, which lots of people have graphs on the server, and you need to communicate the graph down to the client, you kind of have to serialize it into a tree and create duplicates, give it IDs of some sort, send it down through the big cloud, and then your UI has to somehow reconstruct the graph. There's like two really big problems with this. The first is that you incur the network cost of duplicating data. So for someone like Netflix who has a large server bill, that's obviously problematic. But also you incur the cost on the client side of all this complexity. That why should you care? It's not your problem. Or shouldn't be. Oh, wait. There we go. So JSON graph. JSON graph is this just idea that really is the secret sauce that powers Falcor. It allows Falcor to do the intelligent caching, batching, and deduplicating of requests. So on the server side, if we had our entire JSON model in memory, then we wouldn't have anything to worry about. But since we can't have that, we create the idea of a JSON model in the server and hide it behind our Falcor router. So having Falcor on the server gives you the caching benefits of REST so that the client doesn't have to make duplicate requests. The client can make small requests as it needs and have those requests batched up. So it's actually using kind of one of the features of HTTP is that you get lots of data all in one, like Falcor would batch that up and make multiple requests in the same go. And then it also supports function calls. So in this sort of straw man user interface model right here, if we have some sort of controller that's going to broker communication for the view doesn't know or care like where its data lives. It just knows it's going to get some and then render its pixels. The Falcor model sits on the client, and the controller just asks it for some data. Whenever the Falcor model eventually resolves, gives the data back to the controller, and the view is just saying, all right, if you're using observables, it's really easy. This is an example using Angular 2. You can just drop them straight into your template. Let's see. So the paths that we create conceptually are RESTful. They're based on unique IDs. There are references along the way that allow us to do path optimization. But we use RPC to send over because we use an existing network transfer protocol. So the browser actually can't cache our requests. We have to do all the caching, which is fine. It's really not that bad. So the server sends us down this little piece of data. The controller sends it down into the view, and the view gives us some HTML. And that's the story of how Netflix is able to share the same data model across radically different user interfaces and platforms. Thanks. Now, I know I finished kind of early, but I'm happy to answer any questions. All right. I'm going to go with anonymous first, because I can see Andre's thoughts in the... how does Falcor compare to Relay and GraphQL? It's really interesting. When we were building Falcor, we had a few meetings with the GraphQL team just to present what we were doing, hear what they're doing. Falcor is really, the idea of Falcor is, what do we need? Like, what are the minimum set of operations and things we need to make working with a JSON object on another machine feel like we're working with a JSON object on our local machine? The data is the API. So Falcor isn't doing things that JavaScript wouldn't normally do. So if in JavaScript you don't have comprehensions or predicates, you have to drop down and actually do programming stuff with that. You can't just create queries. So we didn't try to write a query language. We wrote kind of a DSL that allows you to describe how you might retrieve lots of data in a single array. For example, if we wanted to retrieve 50 movies, but we wanted to retrieve them by index, we didn't know their ID yet, and we needed to render a list that was 50 long, rather than send an array of integers from 0 to 50 to the server, we just said, all right, well, we'll standardize a little object that has a from and a to, so we can say from 0 to 50, and that kind of just says compression right there. That's about the extent of the sort of DSL or query language that we implemented for paths. I have no idea how GraphQL expects to be able to predict that they can retrieve data from cache whenever they've got dynamic predicates, but they're also a lot smarter than me, so they probably know the answer. Is that sufficient for everybody? Andre. So Netflix is mostly a read-only or browsing experience. How does it perform in cases where reads are as often as writes? So I think it's a common misconception that Netflix is a browsing experience. You might be surprised to learn there's a lot of writing happening too. Maybe it's just not users causing the actions to occur. So in Falcor, when you set something, you set a value through the cache. First, we set it locally. Then we bundle up that set and we communicate it back to the server. But there's a special protocol. The server can say, no, you're wrong, because we might have concurrent writes, or we might have some information might have changed in the server, and now that user, their credit card's declined, or they're not authorized anymore. So the server can always send us back it's the source of truth, in a sense. So it performs pretty well, actually, in cases where I'd say reading and writing are about equal. And you can use it as sort of an immutable store. There's some new UI work being done in Netflix to use Falcor as an immutable store for, well, it's not technically immutable, but it reports to you the results as if it was immutable, as a store for your React application state. Cache invalidation, cool. These questions are more in line with what I did, because I wrote the internals, so cache invalidation is really near and dear to my heart. So with Falcor values, values can have metadata. We respect just a few little pieces of metadata that we built in features for, but you can add your own metadata and do special stuff with it if you want. But specifically, we have what's known as timestamps. So you can say, all right, the value on the server is newer than the value on the client, or vice versa, the value on the server is older than the client. We actually have that problem on TVs when you're like watching a movie and you've like fast forwarded, your bookmark on the TV is about 8 minutes ahead of the bookmark on the server. So if you were to watch a movie, store your place, leave the movie, come back within 8 minutes and watch it, the server would tell us that you're where you were, when it last knew the value 8 minutes ago, and not where you actually were when you stopped playing the movie. So what we do in cases like that is we tell the server, no, we've got a newer timestamp than you. But conversely, we also have value expiry. So you can set an expiry metadata, say expires at an absolute time. It expires, let's say, 5 p.m. today. So when the cache is going through and reading things, if something is expired, it's older, then it treats it as if it wasn't there and tries to go and get it again. You can also say expires with a relative time. So you can say this thing expires 30 seconds from now, no matter what time of day it is. And then lastly, there's a manual cache invalidation way. So you can take your model and you can say just blow these things away, get rid of them, and it'll just completely clean them up. And also because Falcor works under memory constrained devices, whenever the model keeps track somewhat of its size, and if you give it a max size, it'll start kicking things out as best it can if it starts going over that size. Which should be all right, because if something goes out of the cache, next time you request it, we can just go back and get it again from the server. So, pagination, lazy loading. So we don't have sort of a native implementation of lists or pagination. We have kind of a standard or a convention that we use for lists. Essentially, in JSON, you could treat an object that has keys 0, 1, 2, 3, 4, and a length of 5 as if that map were a list. So typically when we have a list of things like one of our lists of lists, we can say, first, all right, cool, give me the length of that thing, and so I know the total length, and then make a follow-up request and say, well, I don't need all of those things, I just need the first 15. And as you're scrolling, you can just keep making more requests to the server. That might change sometime in the future, but for now, that's the convention. Optimistic updates. Does whoever asked this question, do you mean push data, like push notifications and value streamed to you, or what's the context for that? Yes. Yeah. So optimistic updates. We called that optimistic concurrency. So if you do a set, like on you set some data in the cache, we until we hear back otherwise, we'll pretend like it succeeded. You also run into some interesting problems where, let's say I do a get for a large list of paths. I'm going to get the movies for the first 10 lists and the 75 movies in there. But let's say I'm on a memory constrained device. I might get some of that data, merge it into the cache, kick some of it out, and then not have it by the time, like I might be waiting on multiple requests. I might have had to split that request across, or split the request for paths across different network requests. So we have this problem where we have to figure out constantly, all right, did we kick some data out of the cache that we really need now, and so now we have to go back and get it again. But eventually it all kind of settles, and we have all the data we need. Developer preview. We use the word developer preview because really it was me, Jaffer, and Michael. And Jaffer, was architecting it and didn't really code it. So it was kind of just two of us, and we didn't really want to take the heat if anybody got into trouble. But now I'm not at Netflix anymore, and Michael's on paternity leave, so we've got some other really good people working on it, but they're ramping up. Developer preview will eventually go away, but I can't say when because I don't work there anymore. But I can say absolutely it's in a production-ready state. We've been using it. The new Netflix UI that launched last Christmas, the new TV app that's launching, the new phone and tablet. There's a version of Falcor working in Objective-C that we expect to open source, last I knew. There's a Java client that I think just got open sourced. So as far as like production-ready, Netflix is using it. And that's why we didn't even want to release it before you were running in all of our UIs. So that's kind of how we did things. Some kind of support for managing. Yes, managing permissions. Yes. On the Falcor router, there's an authorization. You can only be authorized for certain paths. There's a way that you can configure that. And if you're not authorized, then it'll send back errors to the cache on the client. And you can handle those errors if you need to. Will we get live updates? Maybe. I can tell you that there's some amount of it that we'll have to rip out to do that. But I thought about doing it last weekend, so maybe. It's open source. we can all work on it. How's Falcor different? I have no idea how Falcor is different from Meteor's DDP. I have no idea about that. I do see advantages using service workers in a networking caching layer. We actually experimented with that on iOS, and it worked really well. I think it only worked if we were able to get our data as binary data and pass it back, because it's always doing copies across threads, but it was very, very fast. Oh, so why does Falcor weigh that much? Because it currently has RX in it. And it's not going to have RX in it in a little while. And I think we brought the size down to something like 68K, and maybe less. Honestly, it was 2 years of like going really, really hard, and also everything changing all the time. So there's a lot of legacy, at least that I know about. And some of that is that we just used RX internally. So no, it does not mean you have to model your data as a graph on the server. There's actually, I guess I should, if you go to netflix.github.io/Falcor, you can see all of the demos and examples. There's one called the Falcor Express demo that specifically uses PouchDB because it doesn't really need to be deployed, but you can just run it locally and see how you could implement a router, and calling into your databases. That's exactly the idea, is that you transform it on the fly before sending it. It's like your server doesn't have to know or care. You just put it in a format that the client can efficiently cache it. Yes, it is ready to work over HTTP2. So Falcor models have a data source. It's just an interface with a get, set, and a call method. Right now, there's an HTTP data source. The Falcor router actually implements the data source, so you can actually run the router and the client, both on the client. And so all you really need to do is write a data source that uses HTTP2 instead. Client-only data. Falcor. Yes. Well, so Falcor is not a replacement for Flux by any means. Falcor is try to be as bare bones as possible. It's just a library for getting data.
So let's do one or two more questions.
Cool. Right. So.
Sorry. There's a lot of questions here. That's very good. There's going to be a discussion. What we can do is during the break, we have one room specifically prepared for this kind of situations. If there's more discussions that you want to have, and you can go to the room on the left at the very end. And Paul, you're going to be there. You can do one-on-one discussions and talks.
I'll be giving out T-shirts.
Giving out T-shirts, exactly. So let's do one last question from the Slido slide,
right.
And then we're going to move to a coffee break. So
yeah, somebody else. Who wants to vote? Does anybody want to vote on the question, or should I go by the thumbs, or just the top one?
The thumbs is the voting, actually.
All right,
yeah.
all right. JSON API. So JSON API is more complicated than us. We're not trying to define a schema. The cache has very few conventions. And the idea was that your data is the API. there's really only one or two like special types of objects inside the Falcor cache, and so just so that the cache searching algorithm can, delineate references and follow them and optimize the paths. But Falcor doesn't try to tell you that you need a schema and you have to follow some rules.
Great, cool, awesome. So Paul, thank you so much for your talk. So 3 important information before you head up. Paul is going to be in a room called the speaker's room or the VIP room at the very end of the long hallway for the next 30 minutes, more or less, with t-shirts and for more one-on-one talks. We right now have a coffee break for 60 minutes, so we're going to be here back at 11:15 to have more talks. And if you want to charge your computers, phones, anything, we have a charging room also in the same hallway where you can put in your computers or devices and charge that. So thank you so much and see you in 60 minutes. Thanks. the coffee break, and you had some coffee, some water, and time to talk to the speakers that were in the rooms and in the space. Now we're gonna continue with the next sessions. We're having 3 individual talks. The first one is gonna be given by Daniel Stegerwald, and hopefully he's all ready and prepared. You can plug in your computer right now, hopefully. And then we're gonna have a talk from Nikita Prokopo, then one more, and then we're gonna have lunch. And organizational information for lunch, it's gonna be upstairs. There's a lot of free space, so you can go there. There's gonna be served lunch, also in the restaurant, and also the place where the coffee breaks were as well. So 3 places where you can eat, and it's all ready for you after these sessions. So Daniel, the stage is all yours. Give it up for Daniel, please.
Hi. Thank you, Wi-Fi. So, wow, win. Okay. So hi, welcome in this beautiful city and a great conference. I'm really glad I was invited here. I will talk about functional programming in JavaScript. I should introduce myself. My name is Daniel Stegerwald, and I'm a former Google developer expert for 3 years, and now I'm the JavaScript teacher. I maintain the Ashta development stack. It's basically probably the most maintained starter kit for universal web application, native application written in React, Redux, ImmutableJS. It's something, it's not used only by me, but we have already 44 contributors, and that's all. So if you want to know more, just check it. So, the topic of our talk is the functional programming, and what's the buzz behind that? Because, wow, cool effect. So, there is on the right side, you can read some boring description from Wikipedia, which is not helpful if you don't see the code, and therefore I will show you some real code, because one code is worth of 1,000 words. And let me do a small prediction. I think the functional programming is going to mainstream for the next year, finally. It's still a new thing for a lot of people. I'm quite surprised. I had a workshop yesterday, and I was asking how many people know the functional programming, and only 3 or 4 hands were raised. So that's why I decided this talk should be more basic than advanced. And the next reason why it's not super advanced is that I am talking only about the stuff I'm using in production. It's something like Facebook does with the open source. Facebook is open sourcing only stuff they are using in the production. So I think it's a good pattern. So, what's happening? I think if someone is reading Twitter and the newspapers and etc., he must realize that functional programming it's hot stuff. Even the old languages like C++, 11, and Java already has a lambda expression, and with the JavaScript and the BabelScript, we had a lot of beautiful syntax, pretty useful for functional programming. Also, I would say the functional programming in the front end has been introduced by React mainly, because why React is different and why the other libraries are copying the React is the React has the functional roots. The same apply for Flux and Redux and Immutable and Lambda. So as you can see, you know now what about I'm going to talk. What is functional programming? It's not esoteric stuff, but it seems like esoteric stuff. I was previous year in the Google Developer Conference, and I tried to talk with my colleagues from Google about the functional programming, and they told me, it's something academic stuff. It's not usable in the production. You know, OOP is here forever. And so it was my failed. I tried to explain why functional programming works, but I didn't succeed. Never mind. So just a quick list. Don't stay calm because I will show you the real examples. So it's basically pure functions everywhere, immutable values, composition over inheritance, records over classes, and it's all about the timing side effects. And as I said, it's no esoteric stuff. I think the functional programming is something like artificial intelligence. You know, it sounds cool, it sounds magic, it sounds strange, artificial intelligence, but when you understand how it works, it's just a boring, ordinary programming. Why functional? It's nothing new, it's a pretty old thing, but for some reason we forget what we have learned dozens of years ago. If you know, software is eating world is a famous quote from Mark Anderson, and because the software is driving everything, must be as good as possible, and the functional, it's proved, functional programming leads to less bugs, less complexity, more readable code, and more performance. So, it's OOP really bad? Object-oriented programming? No, it isn't. It's just misused. You know, this is not should be supposed to be hate speech against OOP, you dicks, you did it wrong. No, no. OOP just was misused because nobody, we all as developers are self-educated guys, and for some reason nobody told us about the functional programming can be so fun and so good. But it can be misused like OOP was. I like to think about object-oriented programming like about distributed state. And it's something inevitable. Distributed systems are ugly, they are hard, but they are here to stay, and that's all you can do with that. Nothing almost. So, in my slides there I leave that a lot of links useful for you to self-educate yourself. I highly recommend this beautiful talk about functional programming design patterns from Scott. It's fun to listen to him because he is a very good speaker, not like me. And he explained all these details in a very simple way. So, how many of you are using design patterns in your code? And be honest, raise your hands. Well, that's a good thing. And do you like that? Do you think you are doing a good thing? Probably yes, because it was written. We are supposed to do that. But sometimes it's not as good as it could be. We have more options. So again, what's wrong with OOP in more detail? Basically, every method call on some instance is effectively side effect, and side effects are hard to track, hard to reason about, and nobody likes surprises in code. Surprise in a life is good, but surprises in a code is nothing good. So, inheritance, we were told that we should use inheritance, but inheritance is a trap because it freezes your design mistakes, and such a code is not flexible enough, and it's hard to change it later. Also, all these design patterns is just the simple principles, but the hard thing about design patterns is how to name these things or correctly, because we are masquerading as nouns, strategies, factories, commands. And if you think about design patterns as just simple functions, it makes much more sense. Naming stuff is hard. Yeah, you know. So, and that's how it looks like in the real application. So, it was joke, but all good jokes are based on the reality, and this is the reality we have to deal. React, I think it doesn't make sense to talk about the React in the details on the React conference, because the React is the reason why you are here. So I would just highlight some things. The people still are misunderstanding the React as the virtual DOM, and all the virtual DOM is just implementation detail. The most important thing about React is functional composition. And that's why the React components are written in the code. JSX is just the code looking like XML-like syntax, which is proved for hierarchical structures, but still is the code. And I really have no idea how the other libraries like Ember or Angular is trying to express functional composition in a HTML string tag soup template. Recently, I watching the development around Angular a lot. Recently, I checked the issues, and there was something like, let's vote about the right syntax. So they are still trying to solve the best syntax for the misused HTML, and I highly believe that HTML should be just the projection of your application state, not source of the truth, but who am I to judge them? So, the React can be used in a different way. The best way I think React should be used is a pure React with ImmutableJS. Basically, it's just the regular React component with should component update method, which is used for all these ImmutableJS checks. I will show you examples later. And if you know the React new suggested stateless component syntax, it's beautiful, it's even more minimal, but don't use it yet, at least in HT, because in HT every components are pure, every component is pure. And the stateless components still doesn't have a way how to do the should component update check, and I was speaking with Sebastian, who is probably the leader of the React future, and he told me they are considering the should component update check. Maybe they choose different approach, and as I already said, HT is something I'm using in production. So it's despite the fact it's using the functional programming patterns, etc. It's something which is supposed to be mainstream and stable for production. So stateless components are nice, but not ready for HT yet. And now, these examples. So if you haven't ever seen anything from functional programming, the simple and the most obvious pattern of functional programming is just function and pure functions without side effect. A little example here, I think it's obvious. Function, pure function. The most beautiful thing is it's really easy to reason about function. It has input, output, and that's easy. But we are using also dirty classes. And I love this example from the great functional book. I highly recommend to check it, Mostly Adequate Guide to Functional Programming. I love that style, how it's written. This is a quote from that guy. This is a super simple class, but somehow it doesn't work. It's the great demonstration how hard it is to thinking about state and its mutation, and you see a lot of code. And all that code can be rewritten in just this simple mathematical expression. So I think this versus this. This is class-based OOP, as we thought to do that with a lot of abstraction. And do we really need such an abstraction? I don't think so. I think this is much more sense. And it also illustrates how the functional programming works. It's manipulation with data. And it's so helpful because it's so often for a programmer to be paralyzed by analyzing. And if we have function, it's hard to be paralyzed because the function is basically a task you must be done. It has input, output, and that's all. Next slide is about something also pretty familiar for you. Yes, we have a lot of array helpful methods. And the thing is, we don't need it. Because with functional programming, we would like to deal with the persistent data structures, which is collection which are immutable. And as the name suggests, ImmutableJS. It's the library from Library, from, again, next good thing from Facebook. I think personally the Facebook saved us somehow because I can hardly imagine what we do without the Facebook and its influence to web development. We would probably hack to Angular or something like that. So, a lot of you probably know underscore and Lodash collection methods. And we don't need them anymore because almost all these pretty useful methods are part of the rich API of ImmutableJS. I don't want to spend the time to explain how ImmutableJS works internally. It's your homework, and I believe next speakers will describe it in more details. Just quick introduction. It's pretty simple. Instead of object, we have map. And every manipulation with the map create a new object. And the same is for array. So instead of array, we have lists. And I think this line is pretty important to know. When object is immutable, we can easily compare them. And that's the key for super fast React rendering without the hex, immutable data structures. It could be hard to start with the ImmutableJS without examples, and I have to say the examples in the ImmutableJS. Documents, docs is not as detailed as we would like to be, so you can just a second. Yes. Here. If you know how to use the ImmutableJS in your application, just check the hash there. And for example, reducers in the to-do. So, how to update the nested structures, how to add things, how to find things, how to remove things, all these create, read, update, delete operations. I would highlight one thing, and it's the record. Record is basically replacement for class. I said classes are bad for most tasks we have, but it doesn't mean we should just deal with some plain structures. We want to have some structures named with some properties, etc., and they are called records. And The revive thing is important for server-side rendering when we need to revive state. Basically, these 3 lines convert plain JSON to record structure. As I said, because immutable structures can be changed, we can compare them just with a simple identity check in the JavaScript. So no deep diffing, costly algorithms, but just simply check, and this is how pure components work. Just this one method is optimizing your application without any details. The records have another super beautiful feature, and because to read the value from the immutable structure, you have to use the get method. But if your immutable structure is a record, you can use simple dot notation, which is pretty useful. So back to my presentation. So you have seen some immutable structures. Now you know why these immutable structures are useful for rendering. It makes rendering super fast. And now you see some diagram. And this is some diagram of, you probably were implementing something like that dozens of times. What's wrong with that? It's wrong. What's wrong is that we simply doesn't know what happened, where, why, without the debugging. Because that's how OOP works. But we can do it better with the Redux and actions. So instead of some magic method call, which change some data in some strange way, we encapsulate every change in action. It's basically design pattern command. And we have previous state, and we have next state. And beautiful thing, especially I like these 2 pictures because this is probably the most narrative explanation how upstate works. Your application is just movie. The movie consists of screens, and every screen is described by one application state. So here we have a previous application state, action with some payload which changes state, and the next new one state. So finally your application makes sense. The changes in your application. So you just have seen Flux design pattern from Facebook, and I am using the Rex implementation. I was using my own implementation, but I'm always happy when I don't have to write the code and maintain my own code, and I can use something better, and Dan Abramov did a wonderful work. There were a huge amount of Flux implementation, and basically always the same, just the API was a little bit different. And the important thing from this slide is the winner takes it all, and if some technology is winning, it's super hard to compete with such technology or library. I clearly believe the React won. You would have to make a 10 times better library to compete with React. And it's same for Redux and Flux implementation. Redux just won. It has great documentation, great implementation, so it doesn't make sense to use any other Redux implementation. And if you want to know how it's used in HT, just check. I would like to highlight that all components are pure, and I recommend you to strict top-bottom data parsing through the props. Some people asked me, isn't it, because if you are using the props, you have to pass the props through all parents, isn't it verbose? Maybe, but sometimes it's good to be verbose. You know, Harry Potter, it's the 7 big, huge books. It is verbose, yes, but it's also a good read, so no, it's not always that verbose is bad. So the last line, side effects isolation in actions. Redux is synchronized, but our application are asynchronized, and the state mutations and the side effects and all the dirty stuffs belong to the actions because they are isolated in one place, and isolation means you have control. Next beautiful design pattern, functional pattern, is higher order functions, and in React we are using higher order components. It's basically component taking another component as a pattern. And this is yet another example from HT. I am using the decorators and higher order components to hook lifecycle to components. So it's something like relay, but for example, for Firebase, if you want to use the Firebase, you can't use relay. Maybe you don't need it because the Firebase has a pretty nice API. So that's how I'm using the higher order functions and components in the React. The last thing I would like to highlight is DI containers. I was using DI containers a lot, and if your application consists of a lot of small classes, DI container is must. But if your application is functional, you don't need DI container so badly. And because I don't have the time, again, I recommend you to read these 4 links. This is how we inject dependencies, is how we do pure DI, which means manual injections in HT. It's something like Angular services, but without the magic and without the string and without all that stuff. Just plain, straightforward injection of the stateful instances. This is not something I am using in HT, but this is a randomized functional composition in JavaScript on steroids. It's a very, very beautiful library. I don't recommend to use it right now because it doesn't work with ImmutableJS. Still, it's something you should know because this picture. Read why Ramda, you will understand. Conclusion. Mark Seaman, this blog, the first line, he is a great writer, and he wrote an article about why functional programming is the next step when you are trying to do object-oriented programming as best as possible. Then you have to write functional programming. Time is up. This is a beautiful slide, but it's for your homework. Me, as a libertarian, I see the state in the programming and the state in the society as the same evil, and it's really beautiful how much similarities are between the state and the programming and the state and the government. So, thank you very much for your attention.
Cool. We have time for one question, so you can choose one.
One question?
Yes, one question and a short answer. So the first one, probably?
Let me read them. I like does functional programming scale from development cost point of view? Definitely. And what about definitely, yes. It's yes or no question, a yes or no answer. And Jake, it was great, and now is that, so what I should tell more?
And on this positive note, we'll end the discussion.
I would like to say something about the combining 2 paradigms, OOP and functional. That's a good question. And because, as I already said, it's not like that OOP is always the bad. Use OOP when you have to deal with the stateful stuff. Sometimes it's inevitable. And you can see in a HT, I have two places in all applications target where I'm using OOP and it's not misusing OOP. I believe we can discuss it later.
Exactly. So I think
Okay.
you're going to be
Thank you again.
You're going to be in the VIP room. You can talk to him again. Thank you. Thank you, Daniel. So for the next talk, we have Nikita Prokopo with a long topic: how immutability, functional programming, databases, and reactivity change front end. So give it up for Nikita, and you're ready to go.
Yeah. Oh, it's not right. Okay, this is better. Hi, my name is Nikita. Yeah, and I'll talk today mostly about the storage technology and why it is time for the storage to come into the browser, why we need this, how can you benefit from that. And I'll start with a little of background. So for the last 5 years probably, I mostly work in functional programming languages. So Erlang, Clojure, and ClojureScript now. So I write applications for the browser in ClojureScript. And in free time, I do various open source projects. One of them I will talk about today, but this is another one. I will take a minute of your time for shameless safe promotion. This is a programming font with ligatures. It's called Fira Code. It's pretty cool, I think. And the reason I want to announce it is because literally 2 days ago, the GitHub released a new version of Atom editor that supports ligatures. So finally, it's the first major code editor that allows programming ligatures. So it's pretty cool. Check it out. Thanks. Okay. And for the talk. I want to start with the state of the web. All right. So where are we standing at, and how things look in general for the applications. It all started with thin client idea, which doesn't hold through anymore, right? So right now, the application you write in a browser in JavaScript can do anything you want, almost anything you want. So it's just a generic application. And so the idea is that we are not writing client-server architectures anymore. We are writing self-sufficient applications that run that just happens to run in different places, right? So in a browser, you're not writing a client. You're writing an application that has its own processor, state, memory, network, which can communicate over the network to just like the serial applications do. So so idea is that if you look at it from this point of view, they're not that different. So client and server are not that different. And I think in the future we will see more of them coming closer together and sharing programming paradigms, technologies, approaches, and stuff like that between client and server, just because they're generally doing the same, right? But for today's talk, I think that the time of the storage solutions has already come. So it's already time for the clients to start adopting storages. Just because the applications we write today, not all of them, of course, but we're already seeing a lot of applications that runs in a browser that have a complex, big state, and you have to manage it somehow. So the bigger the state is, the more complex your queries are, access patterns are. So the more you want to do about the state, the more you need something to help you with it, right? So you can do it all ad hoc, in an ad hoc way, but it's kind of, it will not probably work because, well, you'll not probably spend time to implement all the nice things that databases used to have. And yeah, so usually people want databases for stuff like that. So you want manage state, you want to operate state, you want to change the state in a predictable way. You want to synchronize state, all right? So synchronization is usually tied up with the storage solutions, right? So storage needs to have some properties for synchronizations to work, so they're usually tied close together. And the solution I'm going to talk today is called DataScript. It's a project I write, it's open source. And it is essentially, it's lightweight in-memory data structures that runs in a browser. And it happens to have all the properties of a database. I usually call it a database, but in fact it's something more lightweight, or if you want to decomplex it, something like that. And I think we should dive in and see more about it. So it looks like, yeah, when I say it have most of the properties of the database, it does it, but in kind of a different way, right? So the idea of DataScript was based on commercial database, Clojure database called Datomic. They have pretty much a lot of good ideas in it, and it happens that they could be ported for a browser where they still make sense. So I took the model of the Datomic and I ported it into the browser, made it open source, and I'm going to talk about it right now. So yeah, so data model. You expect, well, relational databases usually have tables, right? So they store data in tables. It's not true for DataScript. In DataScript, the storage is simpler. It stores all the data in tuples. Tuples contain entity, attribute, and value, and it looks like this. So here we see that we know two facts about entity number 1. We know its name, and we know its age. We know 3 facts about the entity number 2, and only 1 fact about entity number 3. Right? So why it is made that way? The first one, it's more flexible. You don't need to pre-allocate the structure to pre-allocate the schema to describe which attributes you are going to have. The second one is that it is a better fit for different irregular data patterns. So for example, if you have sparse or irregular data, you don't pay the overhead of having empty columns in a table, right? Which relational databases do. It's also natural fit for multi-valued attributes. For example, you see that friends here is multi-valued, so a person is allowed to have multiple friends. In SQL databases, it usually ends up with additional table and all the pain related to it. Here, it's just naturally supported. And we support reverse references, so we don't have, we can not only reference this way, but we can access reference another way. So we can check friends of a person and whom this person is friend of. Yeah, and another property from the relational world, from database, is indexes. Indexes are good if you have a big state, right? So if you have tens of thousands items or hundreds of thousands items, which is, I think, is pretty much a reality nowadays. Not everybody needs it, but there are applications that need it. And indexes are the way to access such data set in an efficient way, right? So you will probably never write an index if you are using like ad hoc solution, except probably, I don't know, primary key, so you can put all your data in hash map and you will get fast primary key access, but you will not get the access from, for example, by value. So I have an index of persons, and I want to find all the persons that have certain name or which have age bigger than something. So indexes allow you to do lookups anyway. So you have you are storing your data like this in a flat structure, And the benefit of it is you can access it like by row, by column, by, I don't know, Vulkan references and stuff like that. So any ways you want. So you have a big data set and you need to look at it from different, I don't know, points of view. And it's easy to do with technology like that. Another big achievement of this is queries, right? So the SQL in a server-side world is pretty much great. So it's declarative, it's compact, engines can optimize it. You are saying what you need, but you don't say how you need to get it, and it's a good thing, right? So it has its downsides, but it's a good way to express complex data needs or queries in your program. In DataScript, we have query language. It's not SQL, as I said. Everything is kind of different. It's called Datalog, and it has the same expressive power as SQL has, plus it can express recursion. So you can write recursive queries, and it is good for like traversing the hierarchies or graphs. So if you have a graph of friends, you can write a query where we will see it. Yeah, okay, so this is an example of a query in Datalog. I'm not going to like explain everything here because we can spend a couple of hours. But yeah, so the general idea that happens here, we have a query that accepts database and a person's email and finds this person. Then it finds a department it works in. Then it finds all the persons that work in the same department. So here is join happens. Then it finds the salary of each person, so another join. And after that, it do two aggregates. It calculates total salary and average salary of So we get department, total salary, and average salary of department the person works in, something like that. Yeah, so it's pretty compact and pretty, another cool thing here is, it's in Clojure syntax. You can write the same query in JavaScript. I just don't have an example here. And the good thing here is basically it's data structure. So it's a list of expressions, and you can programmatically build it. It's marginally better than SQL when you have to concatenate strings and all the crazy rules about where the comma should go and stuff like that. It's kind of better. Another example, as I said, recursive queries. It's a query when you find a transitive friends. So if there is a chain of friends between A and B, we say that A and B is a friend if there is a direct link, or there is some person X that is friend with A and is friend with B. So it's kind of logical programming, and Datalog is based on Prolog somehow, I think. Yeah. So, something like that. Again, this is an example of recursive query. And that's not all I can say about the queries. There are a couple of superpowers about them. So you can run the same queries over collections, right? So it not only works over the database, it also works over the plain collections like arrays or maps or lists. You can feed in multiple databases. So database is a in-memory thing, so you don't have to set up something complex. You can have multiple databases, obviously, and they can have different info. For example, one can have salaries, another can have emails, something like that. You can put all the databases into a single query and execute join between them. Works just fine. You can mix, of course, collections, databases. And you can use user-defined functions. For example, during the query, you find a person, you need to calculate some complex expression just to check if this person should be in a query, or we should exclude it. And you can just pass in a user-defined function that will be executed during the run of the query. Yeah, and continuing about superpowers, so the database actually is immutable, right? So we just heard the talk about immutability and the benefits of it, how it works for database. It works just the same way. Database is a value that you cannot change, but you can write, you can have a function that takes a current value of database, applies some changes to it, and returns you a new value of database. So leaving the initial value intact, so it doesn't change. The new value is completely different reference. You can access the old one, you can access the new one, you can forget one, and it will be garbage collected. If you don't, well, you can work with both. So the whole database, no matter how big it is, it's just a value. It's truly immutable, you can change it. Yeah, it doesn't have any hidden state, it doesn't have any complex setup process, so it's just in-memory data structure. And yeah, immutability is pretty great for all the same reasons. It's great for immutable data structures and immutable strings, right? So it's easiest the testing, the concurrent programs. We don't have concurrency in JavaScript, but we have it in JVM, for example. So it doesn't cause any problems if you're running it concurrently. It doesn't, well, mess up with the database if you run some test and just see what happens, and test fails or not fails. Everything stays perfectly fine. You can run what-if speculations, so you have a database, you want to see what will happen, how the state will look like, how my target function will look like if the database will contain just slightly different set of facts. So you just transact that facts to the database, you check the new value, and then you throw it away and continue with the old one. And well, of course, one of the biggest benefits is history tracking. So you can track all the states of the database you are using, for example, in application. You're using a database for storing the state of your application, so you can track all the states your application has been into, and you can do it efficiently, right? So just as with persistent data structures, well, actual DataScript is a persistent data structure under the hood. If you have multiple databases that were created one from another by transacting like small values. So for example, the first database is a very, very big database with, I don't know, 1 million facts, and you add one more and one more and one more, and in the end you have 1,000,005 facts. All of them will share the big part of the internal state, and well, they will be all in different and small parts that actually changes, right? So they all will reference the same big chunk of memory. It will not be copied over, so you don't pay the overhead of copying the big chunk of memory to just get a new database. It will reused. So it's a practice that functional languages employ for data structures, and it works just fine for database. So basically, internally, the database is just a persistent sorted set. Yeah, transactions. Transactions you also expect from a database, right? So if you, well, they make more sense in a concurrent environment where multiple entities can change your database, for example. In JavaScript, not so much. But still, yeah, there are a couple of nice properties for transactions as well. One of them is that transactions are serializable. So it means that transaction is actually a data structure that looks like that. It's actually a list of just the changes, right? So the first change is we assert a new fact about the entity number 1. The second and the third sort of come together. It's actually a rename. So we delete with a fact about the name of the person number 2, and we assert a new fact about the same person with different names. So basically it works like a rename. And yeah, so all the transactions are reduced to the form like this, which can be sent over the network, which can be stored in local storage, for example, something like that. So basically, you not only have a database, you also have changes that happens with your database. You can have them as data structures that can be serialized, right? So and it is better than having, for example, a function. If you would have just a function to change the database, well, you can send the change over the network. You can send a function over the network, but you can send the data, yes? And yeah, you can embed, actually, it's not, this is pretty Spartan, it's actually more featured than that, but they are mostly cosmetic features. You can embed user functions inside the transaction, like during the transaction you can run a query over the database, current state, and generate new fact just while the transaction is executing. Yeah, it works just fine. And another good news for this is that if you have this stream of transactions going through a database, you can listen for it, right? So there is a special facility for listening for this transactions queue. So you just subscribe and you get all the transactions that come through a database, meaning that you can listen to it, you can react to it, you can, well, build, for example, if you are using it for application state, you can update your user interface, right? Another, well, yeah, you can update user interface, you can run data synchronization with the server or something like that. So basically, the reactive features. And yeah, and because transaction is a data structure, you can actually reuse the query engine to run the queries over the transaction data. So for example, you're just looking, you're interested in changing of a name, right? So you just query if the current transaction have something related to a change of a name. If it doesn't, you ignore it. If it does, you update the specific part of your user interface that, well, displays that username, something like that. And a couple of future benefits that are not yet in a code base, but will be eventually one way or another. I think one of them is persistence. So as I said, DataScript is in-memory data structure. So you, well, yeah, it only exists in memory. It's not persistent. You can, you don't, it doesn't communicate with local storage or something by default, right? But you can do it right now, of course, by serializing the whole database. And more and better way to do it is to have the support for it in indexes. Indexes are simple B trees, the same, well, data structure used in all the databases, server-side databases. And yeah, it can work like with partially realized indexes, meaning you can have a big index stored in local storage, for example, and you can just deserialize and load only parts that your query touch, and it can run over the well, okay, yeah. It works on demand, right? So you only need those parts of the indexes that you actually touch. And it means that you can do a pretty much efficient serialization for DataScript. With pluggable storage, of course, so we don't ask much from storage. The storage needs just store by key and load by key. And probably for concurrent environment, it will need compare and swap. But yeah, it's pretty much doable. But it's not there yet, but will be eventually. And another property you probably need, so yeah, even though the application is self-sufficient and runs in a browser, it usually needs to talk to someone, right? So the application that doesn't communicate, it's not that interesting, at least in a browser. So most of the in-browser applications communicate, and communication is hard, right? We have, at this conference, I think we have 5 or 6 talks about just this problem alone, how to propagate changes between, synchronize changes between client and a server. And even if you have 2 databases, like client and server, it's already hard. In reality, you have end-to-end, you have multiple devices per user, and you have replicated storage on the server, so it's super hard. And well, yeah, because of asynchronousy, it just gets down to this, everything will change all the time in no particular order, so it's complete chaos, which you supposed somehow to make sense of. And DataScript can help there in a way. It doesn't completely solve this problem. Well, it doesn't solve this problem at all, but the properties the DataScript has helps you to solve this problem for yourself in kind of a better way than you will do with, I don't know, mutable storage, for example, mutable ad hoc storage, right? So the one thing is linear logs. So as I said, the log of transactions that goes through the database is linear. If you have the same log on the server, well, on the server it may be a queue or datomic database which has the same log. The problem gets down to just synchronizing 2 linear logs, which kind of solvable to a way, except conflicts, right? We can send the transactions over the network, which also helps, right? So the changes that happens are already in the data form, and we can run optimistic local updates. So for example, if you are offline, you have a DataScript database, and user trying to do something with your application, the changes he generates, you can apply them to local database first, so he immediately see what he's done, and in the background you can synchronize them. Yeah, and well, at the moment of synchronization, there's well, 2 pitfalls. First, you might be offline. It's okay, right? So you just retry later. And the second one, it may cause a conflict because, well, while you're touching your application, somebody on server changed something, and now server wants his changes applied to you, and you want your changes applied to server. In that case, well, you can apply the server's change. You can roll back your optimistic local updates because database is immutable. You have the old state of database, or you can calculate it because the format of these transactions is reversible. You actually, given this, you can generate exactly the transactions that rolls back this. And well, well, you still have to manually resolve conflicts somehow, but DataScript kind of helps you rolling back, trying local updates, stuff like that. Yeah, so I'm wrapping up. The DataScript, it is intentionally designed as small, focused, and decomplected, meaning that all the different parts are independent. Like you have storage, you have queries, which know how to work with the storage, but you can work on collections and stuff. You have transactions, and they all work together, but well, can be interchanged, and you can build different things if you don't like some parts of it. It plays well with so it tries to do the minimal thing well, right? So it doesn't have a lot built in, like it doesn't have persistence built in, it doesn't have synchronizations built in, but they are possible as a library, and I think the DataScript is a good foundation for building stuff like that. It is currently used in a couple of production projects. There's yeah, some of them. This one I work in, the Cognition, and other ones are, well, sort of applications in the browser, right? That's it. Thanks for the listening, and I will take questions now. Okay, I guess we need to remove this jQuery question, right? I think jQuery is dead. Well, browsers do what jQuery tried to do. Well, we have document query selector, so I don't know why you need anything else. Advice in using DataScript from JS, yes, no, how? Oh, yeah, sorry, I forgot to say that DataScript is, well, it initially was written in ClojureScript with JavaScript API, so you can include it as a JavaScript library and do most of the things. I hope all of the things from JavaScript. Just I don't have a production customer who is using it from JavaScript, so I'm not completely sure, but it has pretty good coverage and test suite for JavaScript. And it works on the JVM as well. So ClojureScript and Clojure are dialect of the same language for the browser and for JVM. So I ported it back to the JVM, and now you can run it on a server and on a client, and that's why I was talking about the immutability and in concurrency, because you can run it on a server. Yes, no, how? Is there a need for more JS CRP suggestions? Yeah, so there is JavaScript API, you can use it and it mostly works. I think it can be improved, but I need a feature request or something about it because I personally use it from ClojureScript and Clojure. What about performance of DataScript? How many records is able to handle effectively real time? Is there any backend part of the DataScript to synchronize data with DB? Yeah, so performance is okay-ish. Yes, the question is, the indexes are bit trees, pretty wide, so it doesn't actually matter how big your database is. Like, you can store 100,000 items with no sweat. You can probably store 1 million. Yeah, the problem, the most time-consuming operation is filling in a database, right? So if you have a page, if you're trying to fill in database on page initialization, you will need to get all the data into the indexes. So you need to sort it. So the most limiting factor is sorting the data that comes from a server if you're doing it on each page load. If you are storing database like in local storage, as I said, with, for example, indexes, persistence based on internal index structure, which is not there yet, it should be better, right? So you, well, okay. But if you are downloading like 1 million items on each page load, you probably already have a kind of slow application. So it's not exactly DataScript bottleneck here. So yeah, I can answer it like the size of a database doesn't matter that much. The initialization time depends on the size of the database, and if you run a query that returns a lot of data or scans or a lot of or joins a lot of data, of course it will be slow, right? But it will be slow anyways. I don't think DataScript adds something there. So the answer is, I guess, that you need to have your head turned on, and you need to be aware of the size of data sets you are operating with, right? So some things are impossible just because you're just asking to do a query over just a lot of data. It's impossible anyways, not because of DataScript. Is there any backend part of this to synchronize data with DB? No, there isn't, but there will be a talk tomorrow by Sean Groove about data. It's a data synchronization library for data-making DataScript, so you might be interested in that. Won't immutability cause performance issues when working with larger data sets? I think it won't. I mean, so immutability, how do I put it? Yeah, as I said, immutable data structure shares the data structure. If you have a 1 million database, it items database, and you add a new item into it, you're just copying over a pretty small part of the tree that doesn't depend on the size of the initial database, right? So overhead of putting new data in the database doesn't depend on the size of the database. So it's pretty effective, I think. And for example, at least it's better than JavaScript arrays, which have to reallocate all the time if you put new data into them, if you grow them, and if for example, the array is super big and you want one more item into it, you have to copy it over into a new allocated buffer, right? So in that case, it will depend. I'm talking about JavaScript mutable arrays, right? So in that case, it depends on the size of initial data set. For immutable structures, it doesn't depend on it. So yeah, something like that. Could you give an example of the DataScript production usage? Yeah, well, on the GitHub page or on my slide, there was 6 projects that are using DataScript in production. Why not implement enchaining API instead of query syntax? Yeah, to change. Okay, this is a kind of design question. Query syntax is okay. Yeah, how do I put it? So the idea of the queries in general is that you can optimize the query as a whole, right? If you have a query, the query engine, in theory at least, can look at what you need, what you start with, what you need, what will happen, before doing any real work. And it can make decisions to do all what you're asking it about in kind of optimal way, right? At least you have this possibility. With chaining API, you're just telling the engine what it has to do in what exact order, right? So it has less room for improvement. Well, it means, I mean, in general, right? For the DataScript, I don't know, it doesn't matter that much because we don't have query optimizer and queries are kind of executed one expression after another. There are some optimizations in between. So for example, in chaining API, I don't know. So the basic idea was to support the datomic syntax first. And when I get there, I don't think I need something else. So if there is a need for chaining API and I can see the benefits of it, I can, of course, add it. So I just didn't so far. How would you serialize a conditional transaction? For example, withdraw money only if user has enough funds. Yeah, so yeah, the idea is this serializable format of a transaction is a result of like executed transaction, right? So you have a database, you apply some function to it, you apply a transaction to it which contains conditional function or something like that, and it executes over this exact value of a database, and it produces the changes that happens on during that transaction. So, and that part is serializable and you can send it over. And if you want to apply the same transaction on a different database, well, it's not kind of possible, I guess, yes. So the serialization of transactions is for deltas between database state, something like that, right? It's not for the code that you execute, so you cannot serialize like a transaction before you execute it, something like that. What about Well, I don't know. I don't know who is asking these questions, and I don't know if I answer them or no. But okay. How do you obtain concurrency on an immutable database? Well, you just don't change the value. So if you don't change the value, it's concurrent. You can access it from multiple threads. It doesn't change. Is it possible to transparently synchronize it with a backend? Yeah, okay. Again, you probably need to see a data talk tomorrow. Why do reactivity and functional programming appear to be the way to go in front-end programming, but not so clearly in back-end programming? Well, if you've seen the Scala guys started the reactive movement, I guess, on the back-end especially. So Java has streams, if I don't mistake. Go has channels and stuff like that. Well, Erlang has message passing. So the push paradigm has been there on the server for a long time. And well, probably the only thing that is not as widely adopted is functional reactive programming, right? So, but it sees its way in a Scala community, at least. That's what I am aware of.
We have time for one more question, and then we have to move to the next speaker.
Looks like NewSQLDB on the client side, if I am corrected. What's the difference with the CouchDB? Yeah, okay, this is a great question. It is NoSQL just because it doesn't support SQL. It supports something better, so I'm not sure you can call it NoSQL. So CouchDB is kind of limited. You only have primary key access. You don't have queries. You don't have transactions that modifies multiple values at once. You don't have a lot of things, right? You don't have you have indexes. But you have to build them manually, something like that. So it's just much more featured.
Great. Cool. Thank you.
Thank you.
Cool. Great. So now we are going to have Mark that flew in from Australia for the talk. And you have a very unpleasant slot before the lunch, so you're the only thing dividing these wonderful people from the food they're craving for. So hopefully no stress, and you're going to do a great job with that. If it's going to work out. Cool. So I think we're ready to go, right? So give it up for Mark, please. Thank you.
All right. Well, let me grab this so I can move around. Sorry about the noise. So as you heard, my name is Mark Dalgleish, and yes, I'm from Melbourne, Australia. So if I pass out on the stage, I apologize in advance. I had a very long trip to get here. So I'm here today to talk to you about the case for CSS modules, or I guess more importantly, where it came from, what it means for the world of CSS and front-end programming, and more importantly for such a smart crowd as this, where can we together take it in the future? So to really put it in its proper context, I really want to take a step back to the beginning. For me, the beginning of my career. For me, it started with this book. Now, this is, from what I understand, not a classic book. It was just a random book I picked up off a shelf in '99. At the time, I wasn't into programming really at all. I dabbled, but for me, I was really interested in the web. And the obvious place to start for me was HTML. There was a chapter in there, chapter 13, it was very small, that introduced CSS. I won't read this out, but the summary really is that they were saying that CSS wasn't quite ready for prime time, but it was really going to change things. So, you know, CSS has come a long way since then. For me, I really fell in love with CSS around the time I saw this project called CSS Zen Garden, which is around to this day. And it really proved out the real idea behind CSS, which was separating your presentation from your semantic markup. Because given a document with semantic tags in it, you were free to kind of change up the way it looked purely by changing the CSS. And in a world of table-based layouts, this was a real game changer, and it really changed the way we think about structuring our websites. But that design pattern really highlights a big difference between two different ways of working, which is documents and web apps. I'm sure most of us in this room are now working in the web app space. When you work with documents, the model pioneered by things like CSS Zen Garden maybe don't make as much sense. Documents have a very different way of thinking. When you want to style the way a document looks, thinking globally makes sense. You want to be able to change every header on the page, every paragraph, every bullet list, and so on. But when it comes to building single-page apps with CSS, you've got this big contrast between the global scope, the true nature of CSS and what it was designed to solve, versus the maintenance of a big, complex application. I'm sure we've all been there. Over the years, we've seen a lot of different approaches come out of the CSS community to try and solve this. The one that really kicked it off was OOCSS, but we've also seen Smax, BEM, Suit, and now, of course, in the React community, more controversially, inline styles. The big one, I think, that has the most usage in production is BEM, Block Element Modifier, and it's ultimately just a naming convention. It's just putting restrictions on yourself so that when you style the page, you're trying to scope your selectors down to a single class with a strict naming convention that tells you you're targeting a specific block or section of the page, elements within it, and then modifiers for the different states that they're in. When you use that in a bunch of HTML like this, things got quite noisy, and I know for a lot of people this is where it ended. They couldn't get past the aesthetics of it, but this came with a lot of benefits because it really brought some missing structure to our CSS, and code bases weren't just degrading over time, but they actually became maintainable or actually able to be refactored, which I'm sure many of us have experienced. The older style of CSS was basically impossible to refactor it without breaking something. And we're now well and truly within the age of components. We've got web components coming to browsers now, Polymer's polyfilling that, Angular has its directives, but given this crowd, I think it doesn't really take much explanation to say that React is really making a big impact in this space right now. React is all about components all the way down. Your entire app is a component. And we don't have special types of components like controllers and so on. They're all just components to us. But interestingly enough, components are nothing new. They weren't invented in React. They certainly weren't invented on the web. But from the earliest days of the web, we had a bunch of built-in components. Of course, we've got things like select boxes, which give you a lot of rich interactivity with a simple tag. You just drop it in the page, and there's a lot of behavior you get for free. The HTML5 date picker is another example, which varies depending on the platform you're on. You get a lot of stuff for free with these tags and a very, very simple usage of them, just dropping a tag in. But for the purposes of this talk, I really want to highlight the fact that when you use these things, CSS and images are private to the component. They're completely abstracted away from you. The implementation details are just not important to you. You just describe that you want a date picker, you want a select box. That, of course, was not true if you used third-party components. I'm going to take the canonical example of the jQuery UI date picker. You just want a simple date picker, and you've got over a dozen files, lots of images, CSS, JavaScript, and you've got to navigate this maze of files and figure out how to integrate it into your page. It wasn't too difficult, but you were really confronted with all of this implementation detail. And our tools reflected this mindset, over the years. We really held on to this notion of treating our asset types differently in their own little silos. Gulp is a really popular front-end build tool, but really it encourages this mindset by forcing you to think about your asset types as a series of disparate streams. It's very common for you to have a JavaScript build task that might run it through Browserify and Uglify and so on. You have your CSS task that's only thinking about your CSS, your images, and so on. And when you look at a tool like Sass, for example, this, again, is something that's purely focused on only one asset type. It's thinking about your CSS. And big complex applications have trees of CSS that depend on other smaller CSS files. And so what that ends up creating in your project is something like this, an index.scss, which is just a wall of imports, pulling in all the smaller files, and then you have a big tree of CSS but no other asset types. So then what does tooling look like in the component age? In the React community, the de facto standard at the moment for build tools seems to be Webpack. And that first time you really get your head around Webpack, it completely changes the way you think about structuring your applications. Because what Webpack does, it makes you think about that single dependency tree, starting right at the root of your index.js file and traversing all the way through your different asset types. So with React, it's very common when it's used with Webpack to make the first line of a component a require call to bring in the required CSS file to make the component that we're exporting actually work. So you'll see here we've got class names starting with my component. In order to make that work, we need to pull in its related CSS file. For the first time, the relationship between this component and the CSS that's needed to render it correctly is right there in the code rather than in your head. That does wonders for maintainability and really helps the code base scale really, really well. While at the same time, you maintain that simple interface that we experience with the built-in components, where if you want to use this component, you just import it in JavaScript with the React flavor that we have here, and you can just export it, render it out, and you don't have to worry about the internals. The fact that it might use a bunch of CSS files, or one, or none, or lots of images or fonts, we don't really have to care when we actually want to import it and render it. Now, I work at a company in Australia called Seek, which the #1 job site there. They're a household name. Whoa, I nearly fell off the stage. Okay. There's a big piece missing here. Okay, I'll be careful. Now, we were very interested in React, not because we could jump on a bandwagon, because it was actually solving some real problems for us. We wanted to have rich, progressive single-page apps. We wanted to have all the benefits of a single-page app, where it felt fluid like a native application, but it had that solid foundation of a server-rendered app, where it's completely crawlable. You could view source and see all the content that you could see on the screen was right there. It meant performance was much better because the first thing you see is not a loading indicator, it's the actual jobs you were searching for. It's overall something that really opened up some amazing new doors for us. And so we started working on this at a work hackathon. And for us, there were some really important requirements to make that work. We needed server-rendered CSS, which meant our CSS couldn't depend on anything running in the browser, like JavaScript affecting styles. For that, we needed hover, focus, and active, so that the page actually came to life immediately. There wasn't a delay before it became interactive. Media queries, of course, are really important for this, because if you render the page on your phone, it needs to look correct right off the bat. We wanted to have CSS animation there so that when things were loading, we could have nice fluid loading indicators. And more interestingly, perhaps controversially, we wanted to at least have the option to have pseudo classes for non-JS interactions. Now, I'm sure quite a few of you are wondering what exactly I mean by that, and so I've prepared a little demonstration. Here I have this little cartoon rocket sitting on the moon. I'm just going to click it, and you'll see it launches, and we've got a few things moving at different speeds. Now, that's not terribly exciting, except for the fact that that required no JavaScript. That was just a big checkbox hack. And if you're unfamiliar with checkbox hacks, let me just click the checkbox again and reverse it. So that rocket was actually a label for a checkbox. And if you know anything about HTML, you know that clicking a label also changes the value of the checkbox. So when you play with this technique, what you can do is, more practically, you can make it so that your menu on mobile is hidden off screen. And when you click the little hamburger menu icon, what you're actually doing is clicking on a label for a checkbox that changes, that makes that second rule apply, which is getting rid of the transform. You can transition from one state to another. Now, this is really important for those primary interactions, something like a menu, where you don't want to block users from opening the menu until 400 kilobytes of JavaScript downloads. It makes a lot more sense to just make it a standard part of the styling. And that's something that we definitely wanted to leverage for the primary interactions in our app. So interesting enough for us, this was in late 2014, and something else really important happened at this time. There was a presentation from Christopher Chadeau from Facebook, and he said that CSS has fundamental flaws at scale that can be solved by writing styles in JavaScript. This is the most memorable slide from that talk, which ran through the problems with CSS at scale. And this one slide caused a Cambrian explosion, much like we saw with Flux implementations. Lots of people trying to solve the problem of CSS at scale by addressing these points in particular. And I'm certainly one of those people that really had to reevaluate what we were doing with CSS. And I was really excited about the future that this opened up. Michele Bertoli, I hope I said that right, who I believe is watching on the stream now, he created a really great project called CSS and JS that runs through all of the different projects that people have submitted to him that are attacking these exact problems. You can go have a look now. This is just the top of a very long table, all the different projects, their versions, the different features that they have. It's worth noting that more X's doesn't mean it's better, it's just there's trade-offs here. Now, for me, the library that really inspired me early on was React Style by Andre Pop, who I believe is in this room. Can you raise your hand? You here? Yeah. Hi. Thank you. I didn't know he was going to be here, so that's really cool. So React Style was the first CSS and JS library that I kind of had a close look at. I run MelbJS in Melbourne, and I actually got one of our regulars to give a talk on React Style when this was brand new, and there was a lot of buzz in the air for this approach. So basically the idea, I mean, it's kind of old news now, but the idea is that you would build up your style sheet in JavaScript, and then you could just attach it inline to the elements in a very familiar fashion. But for me, what really sold me on it is that you could do server-rendered CSS because it came with a Webpack plugin to extract those styles and generate CSS files. That was really exciting to me because it meant it was going some way to addressing these problems that I'd raised that, for us were really important in our project. But there was, again, some trade-offs with this approach. It didn't have media query support. It does now, but at the time it didn't. Didn't have any CSS animations, which was going to cause trouble for us. But most importantly, as you saw with my crazy rocket example, we needed pseudo classes. And unfortunately, React Style made a choice of not supporting these. And this was actually a common thread. If you really want to go all in on inline styles, it makes sense to not support pseudo classes. So there was a bit of a challenge for us in adopting these approaches. And yet, when we looked at these things and we really thought about what they were solving, what they were doing for us, particularly in the long-term maintainability of a project, and we couldn't help but want it. Like, it didn't solve all of our problems, but there was just something to it, right? Like, it made a lot of sense. So for us, we found ourselves kind of caught between these two worlds, and we were asking ourselves, how do we embrace the inline style mindset, even though we're stuck in this bad old world of regular CSS? We don't hate CSS, let me clarify. So for us, the answer lay in something I've already touched on, which is BEM, Block Element Modifier. So the idea for us was really to recognize that the abstraction in BEM, the block, is really the same as a component. It's really the same thing. And that means these two approaches really go well together nicely. So for us, we followed a very strict rule, which was that we would never use a block outside a component of the same name. So what that meant is for any given CSS file in our application, you would see right next to it is the JavaScript for it with the same file name, and that formed a component boundary. So that was our React component held together with Webpack. And I'm sure it goes without saying that this, of course, scales nicely into a tree structure that forms the basis of your whole application. But it's fractal all the way down. You've got CSS files for each component all the way through your application. And if you drill down into the file system, again, you can see that you've got this repetition in name. You've got the same, you've got the component directory, and inside you've got its JavaScript and its matching CSS file. Any images it needs are scoped there. You look into that CSS file, and all you'll see are rules of the same name. Everything's prefixed with that exact same component name, and this makes maintainability much, much better. But for us, one thing that's really interesting about this approach is we found that it plays really nicely with the CSS ecosystem. With a lot of these CSS and JavaScript approaches, they were having to kind of reinvent the wheel in a lot of ways. But for us, because we were using Webpack and we were using loaders, we could just chain them together. Here you can see, CSS loader is right in the middle of less loader and auto prefixer loader. So we could use preprocessors, we could auto prefix our classes for cross-browser compatibility. We could plug it into like linting tools and whatever else you want to use. For us, that was a real productivity boost, and it meant that we could bet more safely on this approach in the long term, whereas CSS and JavaScript was still very much unknown territory. This made it very easy for us to get people on board internally, because you look at this and it just felt like regular old CSS. You were getting this crazy boost in maintainability, but it didn't feel like something really, really different. I wrote about our approach in a blog post called Block Element Modifying Your JavaScript Components. I was really excited about this approach. I really wanted to share it with the world. And I thought this is where we were going to stay for quite a while. But something interesting happened on the side. A new feature landed in Webpack's CSS loader called Local Scope. And basically what Local Scope did was change everything. So if you look at the top of that file we had earlier, where you would require a CSS file, that's very uncommon in Node land, right? To just require something as a pure side effect. Instead, with local scope, you could actually import styles from a CSS file. Now, the first reaction you might have looking at that second line is, what does that styles thing evaluate to? If I'm importing something from a CSS file, like, what is it? Is it the contents of the file? It's a bit strange. So to make sense of that line, we're first going to look at the CSS. So this new syntax was introduced. You wrap this :local around a selector. So here we've got a header and a footer class. And that had some interesting effects on the CSS. So what that meant is that when you imported that styles object from the CSS file, you now had an object with references to the header and the footer. So you can see now in our div, we're attaching classes for styles.header and styles.footer. It's much more explicit now, the relationship between the classes that we're getting from that file and how they relate to the DOM in our React component. To make a bit more sense out of this, if you look at what came out the other end when you compiled the CSS, what started as these locally scoped, human readable classes turned into globally unique hashes. The big thing to realize with this now is that we have no more naming collisions. You're free to call things whatever you want. You can have 12 header classes in your app, and as long as they're in different files, you're okay. Just like when we work in JavaScript and you don't have to worry about clashing variable names in your modules. It was much, much easier for us to manage. And that styles object, all it did was map that human readable name that you provided to the globally unique hash. So when you say that this div has a class of styles.header, what you're actually saying is its class is that thing there, which I'm not going to attempt to read out. Now, if for some reason, particularly in development, you want to have nicer names for these classes, it was completely configurable. So you could tell CSS Loader that you want the local identifier name to be the name of the file, 2 underscores, and then the name of the local. So effectively what you're doing here is you're getting that BEM notation for free out of your build system. And it was much, much easier to maintain, much easier to look at as well. Now, at Seek, we were already sort of working with this BEM style, locally scoping everything to the component, as I talked about before. So as soon as we saw this feature, we couldn't help but go all in. And it really didn't take long for us to port the entire code base over to using local scope. It was a natural fit. But what that resulted in is something really interesting. We had basically any CSS file in the application that you looked at would just be a wall of local, everything local, 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 all the way down. Eventually, you'd come to the very odd exception, like in the case of React, when we were using CSS Transition Group, what you would do with CSS Transition Group is style the classes that introduced differently. And those classes are globally scoped, so we wouldn't localize those. But that was really the exception. Now, we looked at that, and a natural question started to come out, given the sheer number of these local selectors throughout our app. We said, what if locally scoped CSS was the default? You look at any other tool that we were working with, JavaScript. If you wanted something to be global, you had to go out of your way to put it on window. It was not something that happened by accident. You very much had to go out of your way to globalize something. Why is our CSS any different? So what we did is we opened up a new tab in our editor and we experimented just with the API. We said, what if we could transform this automatically? What if we could drop all of that local, all of that noise around all of the selectors and just write the classes? If we needed to have a global class in that odd exception, we flipped the model around. We said, what if we had :global? So in this case, we're saying our locally scoped panel class nested inside it is a global class called transition active enter. And this worked amazingly well for us because in our app, we only had global styles in the normalized CSS and in these transition classes, and that was it. Everything else was locally scoped. And so with this simple change, this would make things a lot better for our code base. So luckily, there's a really fantastic tool, I'm sure a lot of you are familiar with it, called PostCSS. They call themselves a post processor, but basically, it's a preprocessor that you can write plugins for in JavaScript. And so with very little code and not a lot of time, we created this simple plugin called PostCSS Local Scope. And its job was just to make that transformation that we talked about earlier, which is turning .class into :local.class. And of course, it also had room for :global. So it would, if it saw a global notation around a class, it would leave that untouched. It would leave that as a global class. This work that we put into this little project and all the thinking behind it, I wrote up about it in another blog post called The End of Global CSS. Now, I was really surprised to see that this blog post really took off and got a lot of people talking about it. But for me, most importantly, it got the attention of Tobias Koppers, who created Webpack. He reached out to me on Gitter and said, I hope it's okay if I integrate PostCSS local scope into the CSS loader. And of course, what am I going to say to that? It's a definite yes. So shortly after that, we got an experimental feature in CSS Loader called Module Mode. All you had to do was add $module to your CSS Loader, and you would start to get this built in. In my blog post, another thing I sort of raised as an idea for the future, I said that we could start generating shared classes between components automatically, treating style reuse as an optimization at compile time. And what I meant by that is, if you look at that styles object that you import, there's this one-to-one mapping. If you say styles.foo is actually mapped to this global myComponentFoo, your component actually doesn't really care about the implementation of that class. So you could just as easily swap this out for a many-to-one. You've got this one style name that actually maps to 3 classes, or it could be as many as you want. And so that creates a lot of interesting room to kind of refactor your CSS without even touching your markup at all. Tobias Koppers is a machine. He takes these ideas, these threads, and just builds entire new features overnight. So to my excitement, we had this new feature composition that came out basically within a few days. So what you would do is you would take this class, and if you wanted to say it was actually made up of other classes, you would just say that it composes the heading class from typography.css, it composes the box class from layout, and then when you use this class in your app, it's actually going to be made up of 3 classes, the original class you defined and the 2 you're composing. So if you look at those files, they're just regular CSS, again, with no special syntax. You just write .heading, .box, the kind of classes that in a typical application are way too generic and would cause a lot of issues. With CSS written with this special module syntax, we completely sidestep those issues. So again, when you look at that styles object, it's really just 3 classes mapped to a single name that you insert into your document. As we were working on these features, I reached back out to Tobias on Gitter and I said to him, have you thought about writing a standard for CSS modules that others could implement? What you're doing could totally fix the CSS ecosystem if it's widely adopted. And again, not long after we had this conversation, a new organization fired up on GitHub, a new repo with a big README describing what CSS modules are in the hope that we can start to kind of get this beyond just being a feature hidden within Webpack, basically. So I created the CSS modules logo, first as a joke, but it kind of stuck. And it's no longer marked as experimental. We also added an S to the end of the option once we formalized the name. So now you have CSS Loaders modules mode, and you get this built in. So a lot of you are going to be using CSS Loader right now. So you already, if you're not already, you already have CSS modules built in, and you can just turn it on as easy as that. There's a bunch of us working on it. It's not just Tobias, and it's not just me. Really what we're trying to do is make this into a real thing that's not just built into Webpack, not just for React. This is just trying to fix some of the fundamental problems we have with CSS, and we're still not entirely sure where we're going with this, which is pretty exciting to me. So yeah, we've got it in Webpack, as I said, but we've also got it working in Browserify, JSPM as well. But there's a big word out there, not just within the JavaScript community, of course, but people use CSS everywhere. So if you feel that your build tool is missing, or your language, or the environment that you work in, I really would encourage you to look at how you could contribute to our efforts. It'd be really great to get CSS modules, making CSS more maintainable for everybody, not just the people in this room. Now, Michael Jackson said this on Twitter very recently. He said, "I'm really encouraged by the work on CSS modules, though it only fixes part of the problem." And I agree. Like, CSS modules is by no means finished. Like I said, we're not entirely sure where we're going with this, which I like. But there's some big things that are missing. One thing that's actually about to land in CSS Modules 1.0 is a feature we're calling values, written by Glenn Madden on the CSS Modules team, a friend of mine from Melbourne as well. And basically, values let you define these simple values that you can just plug into your CSS. That's not new in the world of preprocessors, but what's really great about them is that they work really well with CSS modules in general. So what you can do, for example, is you can build a breakpoints.css file, and you can define the values right there, give them nice, meaningful names. You can import these into other CSS files or into your JavaScript. So if you look at this component here, what it's doing is it's importing a value from breakpoints.css, and then it's plugging it into a media query. So standardizing media queries across your files is now something that just is part of CSS if you're using CSS modules. The other big problem, and probably the harder problem, one that's keeping me up at night basically, is theming. There's two problems with theming. The first one is around overriding styles, but I actually think this is the problem that's kind of already got some good solutions out there. Some of you might already be familiar with a pretty small project of mine called React Themable. And the idea with this project is to try and make it so that styles are just props to components. If you import a third-party component and you want to override its styles with your own, in the olden days what you would do is just write a bunch of global CSS with bang important everywhere to try and override their stuff. We're trying to make this a bit more of a first-class part of components. So especially those of you who are component authors, maybe pay close attention to this, because I'd like to get some more support on this approach. The idea is that with your component, like I said, you just pass in a theme as a prop, and you can completely customize the way it looks. So as a real-world example, here we've created a theme for this component, and we've just defined some classes that will be part of its public API. And then inside of your React component where you're rendering it, you can import the theme from your CSS file, so it's a CSS module. And then here we've got kind of this first-class CSS module. We're passing the object right down into the component, and the component can use that instead of its default. Now, component authors are going to look at this and say, like, yeah, that's great, but the world doesn't revolve around CSS modules. There's a lot of different approaches out there. And I completely agree. The last thing I want to do is create some kind of like monoculture around CSS modules. So what I did with React Themable was make it so that it kind of worked with as many different approaches as possible. Here you see it, using it with Radium. We're creating a style sheet in Radium. We're wrapping that component with Radium's decorator, and then we're passing in the theme. And this works great. You've also got support for JSS, another great project in this space. Here we're building up a JSS style sheet, attaching it to the DOM, and then we're handing it the sheet's classes down into the component. That works as well. We've got inline styles. If you just write a standard object literal, there's nothing fancy going on here, but you can just pass that right in, and it works fine. What's really interesting is that after I came out with React Themable, this pattern actually landed in React. Not so much the working across the different styles of CSS that are out in the wild, but this idea of like a first-class CSS module, it's already there in React 0.14. So basically what happens now is when you use the transition group, where previously you would provide a transition name and it was just a string that would be prefixed to these global classes, now what you can do is you can pass in an object that maps these enter, interactive, leave, and so on. You map them to global classes. So a common use case would be something like this, where you might have some BEM-style classes in the global scope, and you're saying to React's transition group that you want to map to these global classes you've defined. But that looks very familiar, doesn't it? I mean, essentially, that is what we get from a CSS module. So that allows a really interesting pattern. It means that you can define your transitions in a simple file like this, and you can just call them .enter, .enter active, and so on. You don't have to come up with some new name for it in the global scope. And then what you can do is you can import the styles from that transition file, and you can pass it down as the transition name. Essentially the same pattern that we've seen in React Themable, but this is in React Core. The other problem with theming, and it's the big problem with theming that's caused a lot of debate, is how do you override theme variables? If you think about something like Bootstrap, where the way you work with it typically is you override the built-in variables in their preprocessor. It's a very roundabout way to achieve what's very natural in JavaScript, because essentially what you kind of want is to have functions in your CSS. You want to be able to import someone's theme, which is a function, pass it in some overrides, and out the other end comes some CSS. Now, if you think earlier to our desire for CSS and JavaScript, one of the big reasons we're attracted to it is because it just simplifies a lot of things. JavaScript is just a better programming language than any preprocessor. It's much more widely supported. It has a great package manager behind it in the form of NPM. We really want to leverage this ecosystem. So one thing I've been experimenting with wildly is something I really want to share with you today. It's definitely not a complete idea, but that's sort of the idea. I kind of want to get some feedback on it and get some input. Before I continue, I really wanted to add a disclaimer here. The views expressed in this presentation are not necessarily the views of the CSS Modules team. This is the source of much debate. So CSS modules in JavaScript. That's kind of the idea that I'm playing with. It seems to contradict the whole point of CSS modules, but I don't know, it's interesting to me. Because if you look at the way you use loaders in Webpack, you can just chain them together quite simply. You might have a preprocessor before the CSS loader, but if the preprocessor is transforming one file type into another, what's to say that you can't have some other loader in there that takes in JavaScript and outputs CSS? Now, the point I want to make today to try and inspire hopefully a few of you is that CSS modules, I think, make a great compilation target. Why is that? If you compile something into a CSS module, what you get is first-class Webpack support. You can just plug into all the other tools out there, which means you get local scoping for free. Your CSS in JavaScript solution doesn't have to worry about this problem at all. It's a solved problem. You can extract a CSS file with standard tooling. Again, this is something that we're already doing in Webpack. We don't have to reinvent the wheel. And more importantly, I think for people working on these new projects, especially those of us who don't have a whole lot of free time to do this stuff, really what you want to do is you want to focus on the API, not the tooling. So luckily for us, Andre Pop, again, has inspired me with his open source work. He created a really great project called Styling. And it's probably the thing that really got me thinking about this solution. So the idea of styling is that rather than writing a CSS file, where typically if you wanted more functionality, you might write a Sass file, instead of reaching for Sass, just reach for plain old JavaScript. In this case, we're importing this styling library. We're importing a color library that we pulled off NPM. We've got primary colors. Here we've got values, right? We can just import values from other JavaScript files. And then we export these named styles, wrapping them with this styling function call. And it's just JavaScript. You can do anything JavaScript can do. But I think more importantly, the social factor around JavaScript is really important. All of the functionality on NPM is available to you. And anything that you do to solve these CSS-related problems, you can just wrap it up in a function and publish it. It's really great. And configuring it is nice and easy. In your Webpack configuration, when you wire up the loader for any file, in this case that ends in .style.js, you're saying that it first needs to run through Babel before going through styling, and then after that it needs to go through CSS loader and style loader. I threw my hat in the ring to try and get my head around this problem. I created a very small loader called JSS loader. It's not production ready, it's very much an experiment, but I just wanted to test the waters in this space. And this is kind of what it looks like. So it's very much inspired by styling as well. What you do is you can, again, you can import values from other files. Here we're importing a function, breakpoints as a function. It's like mixin. So here we're using the object spread notation to say that this selector inside, it also has a large screen breakpoint with a different padding value. Now, in this case, wiring up is even simpler, but that is a source of its limitations, so I will warn about that. The loaders here, we've got style loader, but that comes after CSS loader with modules mode, but more importantly, before that, it runs through JSS loader, and it's as simple as that. And the great thing about using something like JSS, again, it fits in with this idea of trying not to reinvent too many wheels. JSS is a really great tool. It's really good at what it does. It's basically, if you think of it as a preprocessor for CSS made with JavaScript, there's already a plugin ecosystem around it to do things like nested selectors and extends, automatic pixel values, camel case, sorting of props, that sort of thing. And if you want to make more plugins, you just plug into JSS rather than into some weird thing I invented, which is really cool. The big concern for me, and this is where a lot of the debate comes in, is how does this affect the approachability of CSS modules? The interesting thing about working in the open source space is that our main concern is not just creating the best thing possible, because if no one uses it, it's not that interesting, really. For us, it's really important that we raise the quality of CSS across the board, try and get everybody thinking about writing CSS in this modular fashion, thinking about component-driven design. And I think there's a real risk that the further you kind of go in the deep end with some of these approaches, the more you're going to just lose the wider web community. So there's a real balancing act here. For me, and the rest of the CSS team, what a CSS modules team, what do you do at these decision points? It's really not easy. We want to make CSS as powerful as possible, but we don't want to break the language or make it into something too esoteric. And this is where your input is going to be really important. If you want to talk to me about this during the conference or on Twitter afterwards, I'd love to talk to you about it. But more importantly, I want you to experiment with us. I think there's a lot of room to try some new things in this space, to try to improve CSS, maybe to make CSS modules a common compilation target for CSS and JS. It's definitely something that we don't know where we're going, and people like you are going to help drive the future. It's also worth stressing that CSS modules, my addition to really kicking that off was relatively minor. It was a small amount of pretty crappy code. I've since improved it, but the point is that it started off with a very simple decision to improve the interface for developers, focusing on that developer experience, and the rest will come. I want to end by saying that the community around React is really, really impressive. And when I say React, of course, I should be a bit more inclusive. It's not just React. There's a lot of great libraries out there in languages, Elm, CycleJS, some really great work happening. And in the CSS community in particular, there's just a lot of people trying different things. It seems like when it comes to Flux, we've largely landed on Redux by the sounds of it. But CSS by no means has sort of ended up in that space. I think CSS modules is the closest we've got to a consensus. I hear a lot of people using CSS modules, but I don't think we're finished. And it's really exciting that so many people care about this problem. That's it for me. Thank you so much for having me. It's really a pleasure being here. Thank you so much for listening to my talk.
Great, cool.
So we have time to go roughly through 4, 5, 6 questions in a timely manner, and then we're going to go for lunch.
I'm going to skip the troll question. I mean, what do I say to that? Thank you. Andre, Andre was a proponent of CSS modules for a while. His question is about the wall he hit about the lack of constant sharing. Hopefully values in CSS modules addresses this problem. Using Freestyle. Freestyle is great. I had a look at it as a result of your tweet, and I'm actually, I think it's the first thing that I've seen that really makes me think about it as an alternative for me in my project to CSS modules. Its killer feature is that it can render the CSS for just the things you see on screen, whereas something like CSS modules, you kind of have to just bring in a bundle of all styles in the app. So I think we're still trying to address these problems, but by all means, use what works best for you. I'm not here to sell you on CSS modules. I kind of answered the second one as well. So values in CSS modules coming in 1.0, so keep an eye out for that. Talking about CSS and JS, how to manage selecting of parents, siblings, since we can't rely on CSS now. Well, I think the design patterns in something like BEM, it's all about kind of trying to minimize this sort of stuff. We do very simple nesting in our applications, but the really good thing about CSS modules is that it scopes it to the one file. So when we do nesting, it's only nesting within the rules of a single file. We definitely don't nest across component boundaries in the CSS. If you want a component to look different depending on its context, we make that a prop of the React component. So if a component can be in like a primary or secondary mode, if it's a button, for example, you don't make that depend on whether it's in a certain parent. You make that a prop of the component, and that leads to much more maintainable code, much more testable code. Doesn't local scope feature bind your CSS to Webpack forever? This is exactly the line of thought that led to CSS modules being extracted from Webpack. My feeling is that as much as I love using Webpack, CSS modules, the idea in it was much greater, I think, than any one tool, and really deserved to be something that you could use anywhere. So, like I said, we need the help of the community to continue this effort, but we don't want to couple you to Webpack. We want you to have modular CSS no matter where you are. I guess I'll answer one more. I'm going to pick the best one. Let's see. Yeah, okay, that's a good question. Andre pops one. So as far as I know, composers can result in non-deterministic style overrides. How to solve that? That's a really good question, and it's something that is probably one of the areas that we need a bit more tooling around. The idea that we're floating at the moment, just to clarify the problem, when you're composing multiple classes into one, imagine that you're composing 5 classes, and for all you know, like 2 of them might actually be defining a rule for the same property. So now you've got this situation where the rule that wins is kind of determined by the source order, which is completely abstracted from you, right? When you use a tool like Webpack, you can't say that this class should be in the file before that one. So that's kind of one of those things that you can't, I'm not sure how you solve that. The idea that we're working on at the moment is it's going to be like in some sort of linting tool perhaps that'll warn you and say like, hey, you just shouldn't do this. It's actually a bad idea. But that still has to come. So in the meantime, tread carefully and hopefully we'll have a better answer for that soon. That's it. So I'm going to be around the conference, of course. So please, I'm alone in a foreign city. Come talk to me. I'd love to talk to you. Even if I look like I don't want to be bothered, I do. So come talk to me. Thank you very much.
Thank you, Mark. Thank you. Well, that's a great way to end the first half of the first day of the conference. A couple of information before you stand up, guys. First one is that we have a fully functioning charging room. So it's halfway, and your iPhones are almost dead. So you can go to the end of the long hallway. We have international connectors. We have chargers for iPhones, new ones, old ones, Android devices, whatever. Just if you need to charge, you're happy to go there. Lunch is provided upstairs. Lunch is provided in the restaurant, and lunch is also provided in the room between the restaurant and here. I've forgotten the name of it. So 3 places, pick your favorite one. Just don't be at one place at all. So you just spread around. And the last one, the people that don't have the proper t-shirt size, we're going to have them tomorrow for you ready. So you can exchange them at the registration tomorrow. So that's it. Have a great lunch and see you in 60 minutes. Thank you. This is going to be a very intensive session with 4 presentations. So we're going to have 4 different speakers come up in this session, so bear with us. So let's better start on time. So I would love to welcome Colin on stage from Formidable Labs. Give it up for Colin.
Test. All right, there we go. Welcome back from lunch, everyone. My name is Colin McGill. I am from Formidable in Seattle, and I am here in Slovakia thanks to Reactive Conf. They reached out and invited us out and made it happen on I don't know, a month or so. So I'm pleased to be here. I would like to dedicate this talk to 3 people that have most inspired my career, and if you know these guys, you'll see why throughout the talk. One of them is Brett Victor, the other is Mike Bostock, and the other is Shan Carter, who did graphics for the New York Times. So I'm going to give you a quick overview of what we're going to be talking about in the next 30 minutes, and then we're going to dive into demos, and I'm going to show you, and then we're going to talk about the motivations and the reasons why, and what this gets us and what's next. So this was the most dangerous looking idea I could find. I had an idea back in May, and the idea was, well, you know, if you just use React for the data layer and the DOM layer, you really only need D3's math, and you can ditch all the rest of it. And I started talking to some people, and the question was, well, what would you need to do to make that work? I said, oh, you just need to rewrite D3. So that's what we've done. That's what I'm here to talk about today, and not all of it is done. We've taken a number of strides down the path. What I'm showing you today is pretty unstable, so if you use it, it's at your own risk. But we've made advancements in the methodology enough that we know where we're going now, and we're really excited about it. So generally, this is a very exciting idea to me because this is full circle. What we've seen in the D3 ecosystem is a functional paradigm where every time the data changes, you can re-update, recompute styles, just like you can with inline styles in React. You can bind data, you can remove, add things to the DOM. And D3 was a big inspiration. And so now why shouldn't React, which has implemented many of these ideas, come back around and inspire D3 and change some of the core of D3? So to make this work, select all, select, data, enter, exit, update, everything that deals with data binding, everything that deals with keeping the SVG current, and everything that deals with touching the DOM goes away. Kind of like jQuery, D3 replicated a lot of that DOM manipulation to code in a functional way. And there were some rewrites needed, so transition, axis, and brush rely on these underlying APIs that D3 exposes to interact with the DOM. So those needed to be rewritten. We've gotten transition and axis. Those are done. Brush is still in progress. D3 really pioneered interactive data visualization on the web. It brought it and made it accessible. How many people in the room have used D3? Yeah, that's probably 75% or more. So the legacy of D3, I think, is multifaceted. I think in one way, it inspired Sebastian in an interview, I believe maybe it was React Europe, talked about being inspired by D3 and having worked a lot with D3. And I felt when I saw inline styles, and some of you know me from work with Radium, this is what I'm showing today is the next 6 months of open source work from the same team that built Radium, and this is what we've done after that. So, has anybody used Radium? Awesome, yeah, 25% or so. Okay, cool. So, the D3 has a number of advantages, and one of the biggest legacies that I think will be enduring is that it brought academic layout algorithms onto the client, things like Barnes-Hut approximation, implementations of force-based constraints. These are things that, this is math that will stay, and this is math that Victory.js uses, but the DOM model is not. So we're going right to demos, because I had the opportunity to do a dry run of this before I came here, and the feedback was, hey, it would have been awesome if you just showed us all that at the front. So I'm going to walk you through the code from the beginning and show you what it means, and then we will talk about the motivations. So again, this is updated 2 hours ago, 2 hours ago, an hour ago, an hour ago. This is under very active development by the team, so you'll need to, if you're going to install it, you'll need to get on a pretty fast-moving train. I'm going to be, please excuse me, I'm going to be going back and forth between the presentation and a number of demos. Okay, so here we go. Okay, so this does not look like D3. This is a React component. This is the most minimal implementation I could think of it's a pie chart. You instantiate it using a component. If anyone here has high charts PTSD, I'm intentionally trying to provoke you, because obviously, if you've seen things like this in the data visualization ecosystem, they're usually not flexible. They are usually declarative. There's a whole bunch of code underneath of this that's a black box, and such is not the case with React. We can manipulate things with props, and we can have full control over the data visualization, even though we're going to go back here to the other one. We can have full control over the data visualization, even though we have high-level control of the API. So where did this come from? You can see here we imported VictoryPy from VictoryPy. Well, because it's a React component, it's also an npm installable library, which is different from the interactive data visualization ecosystem to date. It's been held in GISs mostly, which don't have a lot of the infrastructure that repos do, and I'll talk a little bit more about that as we go on. So this is the source. I'm going to zoom in and show you just briefly that if you're familiar with D3, you know that D3, you don't have control over your SVG in a declarative way like this. You have to run it through a chain of functions. In Victory, that's no longer true. You have your SVG back, and one of the great advantages of this, and actually this was the motivation behind the whole project, was that it would make it more accessible for designers to get involved. Designers and people who are tasked with making charts that then need to become interactive. Typically, we have to rip out a black box with high charts and then implement something customizable, and that's a pain. So if we can have a high-level API and low-level customization, then we have the best of both worlds. So we are really obsessed with dev UX, and I'm going to walk you through. This is the Brett Victor part. I know that talk by Brett Victor and Betting on Principle was really purposed around finding your own principle, but his principle was really, really good. So this is his principle, but it's a really good principle. So in this case, this is component playground. So this visualization has all of the infrastructure of a fully interactive docs ecosystem. So designers, when they're prototyping interactive data visualizations, can play and generally manipulate the props of interactive data visualizations at the top level and then copy this and paste this into their project. So for instance, if we copy this out of here and paste this into here, it's still rendering with default data. It has a default prop inside for data if it's not overridden. And then go back to our demo. You can see that we just manipulated the code in context, and then we pasted it into our project afterwards. So all of these examples, you can build them. They are at that link on the lower right, and to get this to this presentation, if you don't want to type that in, you can use the short link in the upper right. So if you can find all of this source as well, because I'm going to go through it pretty quickly since this is a 30-minute. So Victory-Pi-npm, Victory-Pi-npm, you have access to npm installing every component. Victory-Pi repo means that you have all of the infrastructure around it, and then of course there is Victory-Pi native, because in this case, and I'm sorry I can't demo it on an iPhone today, but with the same API, group, shape, text, you can use React Art for React Native to do interactive data visualizations with the same API on native. And that's been a real challenge to date, is to do interactive data visualization, not in a web view in native, but in native. The libraries for iOS are not nearly as fully fleshed out as the ones for D3. So the next example that I'm going to show you of this API, let's see. Sorry. The next example I'm going to show you of this API is a slightly more complex composition example where multiple of these little primitives are composed into a higher level data visualization API. So in this case, I'll show you the code for this. So we have an SVG, and we instantiate an axis component. We instantiate an axis component. We instantiate an axis component, right? That's left, bottom, and right. And then we instantiate a line, and we instantiate another line. And the lines take in functions, because Victory line as a component can take in a series of points and interpolate over them, or it can take in a function and draw the function, plot the function. So each one of these components can be composed with the others to provide an interface for building up interactive data visualizations in a declarative way. One of the further advantages of this is this implies a way of managing state in a way that we have not had in the D3 ecosystem. And so now, all of that aside, I'll come back to chart at the end as a last demo because there's a lot to it. I'm going to talk about the reasons why what I've just shown you is a step forward, why it's different, how it compares to the D3 ecosystem for data visualizations as it's existed to date. So first, and the original motivation, is that this is much more accessible to designers. Designers are inextricably involved in the data visualization creation process. They can copy and paste out of interactive documentation and write into their projects. Not only that, but the interactive docs that I just showed you have a scope, and you can pass fetch into the scope, which means that we'll soon allow people to fetch their own data out of a gist. So for instance, take a gist, put it onto raw git, take that and put that into fetch, take the URL and put it into a fetch polyfill in the interactive docs, fetch your data into the tree map interactive documentation and load it in the browser, and then play around with the colors. And you can hand some code to a designer and allow them to manipulate the interactive data visualization in place. And that's an advantage that it's making it much more declarative for them. But unlike previous iterations of declarative data visualization frameworks, and I can't emphasize this enough, this has been something that has been tried over and over again. Well, we'll just wrap D3 and we'll put in a config object, and then the config object will configure D3, and D3 will run and put some stuff onto the page. That's not what this is. This does not sacrifice low-level control. You still have all of the access to your styles and running styles as functions, because you can pass them in at the top level and have them executed in the context down below as they're put onto an element with Radium. The next advantage is that SVG is markup. loops are explicit. So previously in D3, you would have node.append circle dot attribute. In Victory, you just have circle radius is 4.5, right? You don't have to construct. You can see above node and below text. See below text. It's just SVG again. You don't have to pass the SVG through a chain of functions, and that syntax made it inaccessible to designers, and it was very difficult for us to get our designers to think inside of this chaining methodology. But this is a flatter kind of syntax because it's just simply SVG. The next thing is that data iteration and data binding in D3 has always been a little bit confusing. Actually, the API, even though I've been using it for years, always still I have to wrap my head around the enter and data. And in Victory, it's simply take an array and map over it and instantiate some SVG. That's it. So .data and .enter become a map over an array that returns some SVG that gets put under the DOM. Nothing more to it. Why that's possible, of course, is that React is keeping track of the component lifecycle and all of the data binding that D3 was. Composability is something that D3 had. It was you could take a bit of SVG that was constructed in chaining and put it into your JS file, and you would be composing the data visualization out of these chained functions. But I think that there's a nice Lego-like web component-y kind of syntax in Victory, in that you have React components which are able to be stacked on linearly, and you can pass props into them, and you can manage the state from a parent component. And that's something that we've used already to great effect. Of course, you also, because it's React, get Radium, and you can use your styles as data, and you can swap out themes for data visualizations as objects and pass those around asynchronously, whatever you would do with an object. You can also, there's a top-level API that we're exposing. We're working on the syntax for this right now, but basically, you can pass in, has anyone, well, okay, if you've used D3, you've seen the Lambda syntax, where you do attr, or you do .style, and then you pass in an anonymous function, and that's called with every instance of the data. So you don't lose that power with this, because this is a little bit of magic. This is one of the little bits of magic in the API for Victory, that when you're writing a Victory component, you'll have to take into account that you'll have to execute the styles in the context by passing in this.props to them. And that's something that will be documented later on, so you don't have to worry too much about it. But basically, you have all of the expressive power of using the logic of JS with styles that you did with D3. You don't lose composability, and you don't lose functional styles. In D3, state management was kind of a punt, because this isn't necessarily bad. It's simply a statement that, well, you're going to do it in your app how you're going to do it, so I'm not going to spend a bunch of time on it. And nothing makes it really let's see, how do we say? This is mutating the data, popping children on and off of the original data structure to manage state as things change. And the place that we can go with React, of course, is to make everything a component. And when we make everything a component, we can manage state within the component. So we can say that the tree, and this is taken from a tree example, we can open and close nodes on a tree and have a way of using the React component lifecycle where the state is managed by the component rather than managed in a random place in the app or just outside of data visualization. It means we can share code and publish components that have state in them. We can publish a collapsible tree to NPM, and that collapsible tree is reusable by other developers or anyone, and because it has a props-based syntax, and it's not going to leak into the rest of the code where this might mutate your data. The next thing that you get is that you get repo infrastructure. Previously in D3, there is an emphasis on GIST, and I think that repos are a much better abstraction for data visualizations because every issue, every data visualization has issues, you can fork it, you can file PRs against it, and that means that data visualizations can be improved and added to. There is a wonderful example of, I think, the problem in the GIST ecosystem in that when someone adds a feature, they effectively add a feature as a gist, and then that doesn't get found. There's a discovery problem in GIST because the GIST proliferates, so there isn't a centralization of all of the data visualization features for line chart, say. There's a very interesting feature in one of the components where you have Voronoi in back of a... I'll show you. Hold on. So this is a very interesting feature. It's very, very smooth. And the reason that the hover is so smooth is that this is backed by a Voronoi that is capturing the hover events. So this is a feature that will not be captured in almost any other line graph, but it's an excellent feature for hovering. Glitchy hovering over lines is something that plagues almost every interactive data visualization. So why wouldn't we want to have that as an option on a line graph that we could just simply turn on or off, smooth hovering? It's a nice feature. And if we have repos and PRs, then we can improve the data visualization ecosystem collectively, and that's something that is lacking now, I think, in the ecosystem as a whole. So the other thing that you get is you get build, you get infrastructure, and you get dist. You have lint files, tests, you have Travis, you have Babel and Webpack hot reloading while you're building data visualizations, while you're building these components. You have a package.json with explicit dependencies, readmes and docs. You've minified dist, which means you can CDN a pie graph and pull it into your React app. That's something that you haven't had. So there was a problem with this, which is that if you instantiate hundreds of components, victory-line, victory-tree, victory-tree map, victory-chord, victory-force, on and on and on, you end up with hundreds of components. Well, if hundreds of components have all of that build infrastructure, that's not dry. So one of the things that Formidable has endeavored to solve is, and this is something that soon you'll be able to use. Again, all three of these things are under active development. Ecology, which are those interactive docs. Builder, which is the solution to having hundreds of repos with infrastructure, and Victory, which is the data visualization library here. Builder is a way of managing NPM scripts at a meta level so that you are abstracting your Webpack config and your test infrastructure and your lint files into a kind of archetype, we call it, that then is applied through a CLI tool to all of these components. And so if you are producing, for instance, at your company, a UI library, and the UI library has hundreds and hundreds of components, you're going to have a problem in terms of build and test infrastructure on those. If you want to change your ESLint config, you have to go do it in all of the files. So abstracting that into one file and then interacting with them through a CLI becomes desirable, and that ecosystem benefits so. Victory animation is up on NPM, and NPM is another huge advantage. You can't NPM install a gist, and so letting future programmers on your project know, hey, I went out to this gist, and I copied a bunch of code, and I hacked it up so that it would work in my project, and here's the pasted link in the code back to that gist, is not nearly as helpful as I rely on this version of this tree map, and it's installed through NPM, it's in the package.json, that dependency is versioned, and I'm going to pin it if I need to. It itself has dependencies that can be pinned. The interactive docs themselves are an advantage. I'm going to show you, if I have time in just a second, I'm going to show you how to get ecology going on your own project. But ecology.js are those interactive docs with the side-by-side editing in browser. The React Native is the last benefit, and that is the 11 reasons why this is helpful. There are a whole bunch in the works, and I could have filled in. I left the open dot because it's just going to keep going. I think I have one thing to say about my experience with React over the past 10 months or so. I think that if you zoom back and look at front end as a whole, the reason that we're able to do what we're doing with Victory is because this is just functions. We're building on top of functions on top of functions. And this, I think that we saw a lot of inflated expectations with what previous frameworks were going to be able to deliver and in what time and how they would work. But a lot of them just hid the bad and moved the bad around and had different compromises. And I think that the slope of enlightenment, I think this is, if you zoom back and look at the front end architecture and ecosystem, I think this is the slope of enlightenment. This is after the bad. So that's my take on it anyway. But this was built by Formidable. I build with Formidable. If you'd like to work on this, work with us, work on any of this, come talk to me. Find me around the conference. I'll be here for the rest of today and tomorrow. And with that, I'm going to take a couple questions. I just want to show you one last thing of this, which is that okay, here we go. So chart is a component of components, and you can use chart to basically take care of the scatter, line, bar, the problems in data visualization that are repeating themselves on a daily basis, and you don't want to have to create custom solutions every time. But all other benefit of it is that if you look at the demos for this is in demos for Victory-chart, there's also a number of wonderful examples of how to compose Victory blocks together, to Victory components together, to create interactive data visualizations. So, okay, and okay, I will stop there. There's basically 3 independent things that I wanted to talk to you about, and we got through it. We have 54 seconds, sorry. So I'll take like a couple questions really quick if there are any, and if you want to flip the screen up and I'll answer the ones at the top. Okay, how do you handle interactivity like events? Great question. So, great. So d3.mouseMove is going to be if you want to add a click handler, that click handler will have to be put in as a prop. So it's handled at the top level, and anything that you want to apply an event to, you'll have to probably right now, okay, like right now or later. Right now, you would have to fork it. Soon, the API will expand enough that we'll have handled this. But basically, the more custom that you need it, the easier it will be for you to simply fork it. But then you're starting from an existing project and repo. So let's see. The next thing: how does wrapping D3 inside of React affect? Okay, performance. Great. So we profiled React animation, and we profiled this, and we ran a bunch of functions. We profiled all the functions, and we profiled the DOM, and the bottleneck was all together now. Yeah, the DOM. Yeah. So adding a bunch of stuff on top. Yes, it does affect things. Done.
You can finish your sentence.
Okay. Sorry. So let's see. How does wrapping performance? Performance, the bottleneck is not React. The bottleneck is the DOM. Okay,
fantastic. Thank you so much.
Good. Thanks.
Thank you, Colin. That was a lot of slides in 30 minutes. Nice job. Next up, I would like to invite Christian Alfani to present State UI and the stuff in between. Much. You made it. Fantastic. Nice. So in the meanwhile, we with Colin in the lunch break, we had some shots just to make him a little bit more relaxed. So I think we did a good job with that. So let us know in the comments or on Slido if you like the presentation. And I'm going to leave the stage for the next speaker. All set?
I think so.
Okay.
Exactly. Oh, should I just
log
use?
in.
Oh, sorry.
Great. So give it up for Christian.
Hello. Hello. Can you guys hear me? Yes, great. Okay, welcome to my presentation on State UI and the stuff in between. My name is Christian Alfoni, and I am the author of a library called Cerebral. But I also do other stuff, like address bar, which basically just converts the address bar in the browser to an input, so you can listen to changes on it, you can change the value of it without any side effects. And I also co-founded a project called Webpack React Cookbook, together with a guy who calls himself Bbro online. He's the guy maintaining it now, but I recommend you check that out. I also brought the Yahoo dispatcher to Angular with the Flux Angular project. And I also have a project called Formsy React, which is a form builder and validator for React. I have a web page at christianalfoni.com, where I mostly write about React and Webpack and stuff like that. And I'm currently working on my own project, my own little startup, actually using Cerebral to build a service to teach kids how to code, and hopefully inspire them to become developers like us one day. And I do some consultancy on the side. So my talk is really about complexity, how Cerebral can help us express complexity. Because we do not really want to hide complexity in our applications, and we certainly do not want to reduce it, like removing features and stuff like that. What we need is a way to express all this complexity in our applications. And Cerebral is one perspective on how we can achieve that. So this is a piece of UI. And this is how our users consume the state of our application. And actually, as a developer, I also consume the state of my application going into the UI. So if I wanted to know if this checkbox was checked, I went into the DOM and I checked if the checkbox was checked. But that's not a good idea. It gets you into all sorts of problems. And then React came out. And React shifted my mindset. It made me think about my application separately from my UI. So specifically, my UI is now an output of my application. And like with Backbone, I had grabbed state from a model, shoved it through a template, and produced some UI. But I would still go into the DOM to figure out if the checkbox was checked or if the input had some value. With Angular, it's kind of, you have this two-way data binding, so it kind of like intertwines your application with the UI. But with React, it's the complete opposite. It's like you have your application, and the output is the UI. So this is like the flow inside our applications. It doesn't matter what we use to build it, but what we want to achieve is to have some initial state, and we shove that through some render mechanism, which produces some UI. And then something happens in the UI, and we want to change the state of our application. So the stuff in between there is really render and changing state. I'm not going to talk about render, but I am going to talk about changing the state of our applications, because it's really hard. It's really, really hard. So the smallest context with this flow is a typical view or a component with React, where you have some initial state, and then we shove that state through some render mechanism, and we produce some UI. And typically, we would click a button, and that would run a function. And that function would change the state of the view, either implicitly or explicitly cause a new render. Like with React, it's implicit. We just call setState, and it does a new render. But with, for example, Backbone, we have to explicitly call render after any state change. But building applications is not just one view. We have many views, all handling this flow. And we also need global state. We need global state in our applications because we want to share state between our views. And this is handled differently with different libraries. Like in Backbone, you have these abstractions, different abstractions for state called model and collection. And you have lots of these entities, lots of models and lots of collections. And with Angular, you have the same kind of stuff, but it's just called something else, like resource and service and factory and provider. And all this is about state, but it's just wrapped in APIs and stuff like that. And you can actually also think about your router as keeping some of your state, like what views am I supposed to render, what is the current URL, and stuff like that. And the problem here is that it's really hard to reason about all this because we're creating so many relationships inside our application, having all these entities representing our state, and then having these wrappers with all the APIs and stuff. But then we got Flux, and Flux really cleaned up this stuff. And the really great thing about Flux is that we moved away from having multiple abstractions for state and moved into having one abstraction called a store. And that's really great. And another thing about these stores is that they are a very shallow abstraction. We don't have lots of APIs for talking to the server and stuff like that. It's just basically an object where you put other objects and stuff in. And the problem with Flux, though, is that when you want to change the state of your application, you have to, often you start in the component. You have some click handler or something that has some logic. And then you have the action creators, and they have some more logic related to this state change. And then you have logic inside your stores to actually produce the new state. So it's kind of like split between these three layers. And personally, I think that's hard to reason about. But then I found this project called Baobab. And Baobab is a single state tree. It's just one object representing all the state of your application. So the components has the ability to point into this tree. They can point to specific paths and listen to changes. And what's really great now is that we do not need the dispatcher. We just need something to handle our state changes, and that is typically just functions. And these functions just has access to the tree, and they can change the state on the tree. And what's very nice is with the latest version of React, we can have stateless components. And this image is something I really like. It's the same flow I started with, but now it's more in a global perspective. So now the components only does rendering. And then you have a layer for changing the state of your application, and you have a single entity representing the state of your application. So I built applications like this for some time, and this is typically how I would change the state of my application. I would write a function, in this case called getToDos, but it does more than getting the to-dos. It's also changing the loading state, it's setting the to-dos, or it's setting an error. The point is that to understand this change, you have to read all the implementation details. And this is a really simple function. You can imagine how complex this can get, and you have to read all the implementation details. So I wanted to make this better, and I looked at different places, but ended up actually looking at like the good old days, where we have just HTML in the browser. Easy to build applications. But these applications also needed to change their state. So what they did to change their state was typically with a form, like we wanted to post a new to-do. And this post request is actually a request for state change. And what handles this request for state change is the router. And the router commonly has a concept of middleware, where you have multiple functions, each of them performing a specific task. Now, what I like about middleware is that it is expressed as a flow. As I said, you have one function doing one thing, then the next function does something. But it also has this request object. So you're not limited to only operating on the output of the previous function. You can kind of like share state as you move through this state change. So taking this into account, now we're back in the client. And we're going to talk about Cerebral. So Cerebral kind of like fits in between your state and the UI. And the way it changes the state of your application is using something called signals. So something happens in the UI or some other part of your application, and it fires off a signal. And this signal has actions, and it's just functions that has access to changing the state of your application. So the thing here is that typically with Flux, we do a state change, and that specific state change tells the UI to do a change. That's not how it works in Cerebral. With Cerebral, it's the signal that decides when it's time for the UI to update itself. Going okay? Good. So smack right in the middle, between your state and UI, you find Cerebral. And now we're going to dive a step deeper, and we're going to talk about these signals and actions. So the way you build a signal is by composing actions into something we call chains. You might think of pipes, maybe, but I think of them as chains. And these chains can be composed into a signal. So in this case, we have just one signal with one chain and 3 actions. So something happens in the UI, and Cerebral runs the first action. That action changes some state in the state tree. And then it runs the second action, which actually grabs some state from the state tree. And I want to access my current state when I am changing my state. For example, if I'm changing the state of an issue in my project application, I need the ID of the project. And I don't want to necessarily pass that through the component. I want to just be able to access it. I might need some information from the user or whatever to do this state change. And then it will run the last action, doing some state change, and then it notifies the UI about an update. But we have to do more complex stuff than this. So we have to do asynchronous stuff. So imagine that this first action is changing some loading state. And then Cerebral sees that the next action in line is asynchronous. So what it does is just poke the UI and tells it that, okay, I have some changes for you now. I'm going to do something asynchronous, so you can update yourself. And then it runs this asynchronous action, which is typically a request to the server. And the response from the server can be like success, error, not authorized, not found, whatever. The thing is that this asynchronous action can output to a specific path. So in this case, you can imagine that the asynchronous action outputs to a success path. And this path is just a chain with one action, changing some state and then notifying the UI that it can update itself. But we have to do even more complex stuff than this. We also want to run parallel asynchronous stuff. So we can imagine here that we have 2 requests to the server, one of them taking 1 second to respond, a long time, but just for an example. And that results in a success. So after 1 second, it will run the success chain, running just one action. But the other asynchronous action takes a bit longer. And when it's done, it will run its success or error chain. And then finally, when all this is done, it will run the last action. And then update the UI. So we're going to take a crash course in signals. So I'm going to use the example I had earlier with Baobab. So the way you would express this with a signal is first naming it. And by convention, the name should be what happened inside your application for this signal to trigger. It's just easier to reason about stuff that way. So in this case, when the application mounts, we have defined a chain. And the first item of this chain is set loading to-dos. And set loading to-dos is just referencing an action, just a function. I'm not going to talk about these actions because I just don't have time for it, but it's just a function receiving some arguments, making you able to change your state and stuff. The second item inside this chain is an array. So an array inside a chain means that the actions inside it will run asynchronously. So get-to-dos in this example will run asynchronously. And then we have an object after that get-to-dos. And this object represents paths. So in this case, the get-to-dos action can output either a success or an error. If it's a success, it will run a chain containing one action called setToDos, or if it's an error, it will run one chain containing setToDos error action. And when all of this stuff is done, it will run that last action, unsetLoadingToDos. So what we're going to do now is have a little demo. So let me do this correctly. Hello? Okay, let's try this. Okay, so what you're seeing here is the typical to-do MVC application, only running with Cerebral. So you have the typical UI here on the left side, but you also have the Cerebral debugger. So Cerebral has a Chrome extension, which is its own debugger. So what happens here when I change the UI is that you can see what signals were triggered when doing this state change inside the application. So you see what signal triggered, what actions were run, what input did it have, what state mutations did it do. And if I hit enter here, we can see a more complex example with more actions and some asynchronous actions, inputs, outputs, and all that good stuff. And now we can see how, like we often underestimate the complexities of what we do. And adding a to-do seems like a really simple thing. But it is actually quite complex, as we can see here. There's a lot of stuff happening. What's also really nice is if I click this model up here, we can see the complete state of the application. And what I'm talking about now are like these three layers. You have your UI, which of course the browser handles, but you can also see the state changes of your application using the debugger. And you can at any time see what is the complete state of my application right now. And the big hype these days is time travel debugging. And you can do that because Cerebral knows about everything that's happening inside their application. So you can do that. We actually used to have a slider here because I remember the Elm example. But the slider is just really cool. It's not very practical. So we decided to have some buttons here instead. Okay, I could talk more about this, but I'm actually not going to do. Okay, I want to mention one more thing. It's like you have no insight into the code of this application, but if you were able to read the signals here, you would actually get an understanding of what does this application do? What is it trying to achieve? And I think that's really powerful, that you can just grab a developer, open up the dev tools, and just start playing around the UI, and you understand the internals of the application. All right. So I said I was going to talk about complexity. So this is complexity for you. And you're probably thinking now like, oh, what is this? But I'm going to make a statement now, and that is that when you read this, you will understand what it tries to do. So we're going to go through some of it now. As we can see here, it's trying to load an access token at the very top here. And two different things can happen. Either that token is found or it's not found. If it's not found, it will try to log in. And that can result in a success or an error. If it's a success, it will set the access token, and then it will try to verify that token. I'm not going to go through all the rest of it. But this was an example pasted by a guy named Brian on the Gitter channel. Hi, Brian. Thanks for the example. And he wanted to ask us some questions. Now, we didn't know anything about the implementation details of his application. We didn't even know that this was related to Google and their access tokens. But he wanted feedback on this. And some of that feedback was, why do you have to verify the token after you have a successful login? And what Brian answered is, okay, it's just in the Google documentation. I have to do that. But I think it's kind of nice that we were able to ask that question without reading any implementation details. And then we have like these scenarios. So when we handle complexity, I think most of our bugs are scenarios not handled. You know, you create some request and you have the catch, and then you really, I can do that later. But it's very explicit here, what scenarios should be handled. So what we could tell Brian is that, okay, when you verify the token over here, why are you not handling the token invalid scenario? And we have the same thing down here. It's verifying the token, but it's not handling the scenarios. So you can kind of like sit together and you can build these signals, not implementing any code at all, and everybody talks about and understands the flow of changing the state of the application. So it's of course possible to refactor this. I like to express it mostly like you saw on the previous slide, but since these are just functions, these actions are functions, you have the possibility to just use normal JavaScript. For example, factories. So instead of having a get-to-do section, as we see here, you can have an action factory. So it's just a function that takes an argument and it returns an action using, in this case, the URL. But you can also use a new spread operator from ES 2015. And you can just put actions and paths and whatever you want into arrays, and then you can just spread these wherever you want. You compose it together. And you can even create chain factories. So you can pass in some custom actions to a chain factory, and it will return a chain for you, having some default actions. So this is an example of how we could refactor Brian's example. If we see at the bottom here, that is where we have the initial chain, and we're loading the access token again. And it can be found, or it cannot be found. If it's found, we run the verified token chain, but if it's not found, we run the login chain. And as we can see here in the verified token chain, it's reusing the login chain. So this is like composition. And it's really kind of fun building an application, because as you move on, you start reusing your chains and you start reusing your actions. But before I close off this presentation, I forgot to set my timer. I'm not sure how we are. Oh, nice. I just want to show you how do you actually use this with a component. So you would define some state in your state store, and you would create your signals. And with Cerebral, you get a decorator. So we still need stateful components. We need to like grab state from other places and do other stuff. And so what you would do is create a component that uses the Cerebral decorator. And this basically just means that, okay, I want an isLoading state and a to-do state inside my component. And I'm going to grab that state from isLoading path and to-do's path. And inside your component, you have access to props. So this state will be available on the props object. And you also have access to the signals themselves. So you say like props.signals.appMounted, and you can call that signal. You know, this went quite well. I'm finished. Thanks so much for listening, and maybe it can help you out.
Great, cool. Thank you, Christian. We have a couple of questions from Slido that we will great if you can answer in the remaining 5 minutes.
Which benefits Cerebral have over Redux? So Redux doesn't really have a concept for handling complex state changes. You have like this action creator, which basically is just a function, and then you have to like do all the requests. You have to implement everything. You do not really have an abstraction over like with Cerebral. It's like an abstraction above, if that makes sense. I'm not like an expert in Redux. I'm actually working on a project now using Redux. But yeah, that is my statement on that. Hopefully it makes sense. Callback hell. I have not met, maybe you think about the tree structure, that it looks kind of like callback hell. The example I show now is like really complex, and I want to compare it to callback hell, because that's like implementation. What we're doing is declaratively expressing how our state changes should run inside our application. But maybe that's more a matter of opinion. I don't think of it like that, at least. Do we get runtime error? Well, actually, these actions, if you're working in a bigger application, you have the possibility to define what outputs should this action have. and you can type check its inputs, you can type check its outputs. So in the case with the arrow here, you can say that this should have an error output, and if you define that, it will instantly tell you when you fire up the application, there's something wrong in this signal. You have said that this action wants an output to an error, but I can't find it. If you do not define it, it will happen at the runtime, like when the action actually runs. What's that? How do we components update if you're missing? If you're not passing props down all the way, are you using? Yeah, exactly. So the decorator just wraps the component and listens to a change event on what we call the controller. Cerebral is a controller. And when the change happens, it will do a shallow check on the paths. So it's important here that the state tree is immutable. So you can use ImmutableJS, or you can use Baobab, for example. And yes, there's some events happening in the background. And yeah, I just answered that. ImmutableJS, yes, it works. Is it already used in production? The project I'm working on now is not in production. But there are multiple projects using it now. And so I can say, no, it's not production ready right now, but it will be during this year.
Fantastic, great. Thank you very much. Thank you. Sorry. No worries. So now we have a very special speaker, also from Silicon, no, from where exactly? I know the States, but where exactly? Salt Lake City, not Silicon Valley, Salt Lake City, even better.
It's a Silicon Slope.
Silicon Slope is the name I've been told of the place. And we're gonna have a talk on front-end can be more functional by Julia Gao. And let's connect the HDMI cable.
Okay. Can I take this off?
Yes, please.
Okay, let's see. Okay. Oh, I don't know. I put my stuff in, so it should be on there.
Not really. Never mind. So let's go back.
Yeah. So it's on the other one. This one. There you go.
Mirror this one. Or oh yeah, no. It's good.
Oh, there you go.
There you go. There you go.
Cool.
A little bit more.
Do that?
Yes, fantastic.
Cool.
Cool. So give it up for Julia, please.
Hi. I'm really excited to be here and talk to you more on functional programming and how to make front-end more functional. Who am I? I'm a software developer, and I like astronomy, functional programming, React.js, and some games. So today, I'm going to talk about some concepts about functional programming, and then hopefully it will make more sense. So we've all seen this picture. And it's obviously a joke, but also kind of true. So functional programming emphasizes on what simple functions can do. And there are obviously tons of concepts, but I am going to talk about two simpler ones today. So stateless functions and immutable data structures. So let's learn more about them so you will then understand how they may help you. Stateless functions, or pure functions, or this word that I can't pronounce, which just means no matter how many times the same function is getting called, if you pass in the same arguments, then the output should be the same, which makes the function really predictable. So let's think about the absolute function in math, which should calculate a number's distance to 0. So this code makes sense, right? You give it the same number 3 times, and you get the same output back. Now, so there are no side effects, and they produce fewer bugs. So we all know that one thing that used to work, and somebody changed something, which affected your code, so makes your code no longer works, which sucks, right? So just think about how frustrating you will be if you give it -1 and then it produces 5. So let's look at this doSub function. You give it 2 A and B, but then you return A plus B plus this other stuff that you don't know where it's from. And then you call this doOtherStuff, which changes this global variable. And then when you first call the doStuff function, and then you call the doOtherStuff function, but then if you recall the doStuff function, given the same parameters, then the outputs are different. But if you write it this way, which you give it 3 parameters, and you don't rely on the outside stuff, which makes the function produce the same outputs every single time. The second concept is immutable data structures, because one does not simply mutate a data structure. Let's think about these two, plus plus 5 and high plus by. Now, when we first look at them, plus plus 5 simply returns a 6. We wouldn't expect this changes all of the 5s in your code to 6, right? Now, same thing with high plus by. We wouldn't want all of the highs to change to high by, only this one. So if that makes sense, why is it different when we declare variables in our function? So think about this one. We give it A, and then we return something based on this other function that also takes A. And then we return this object that contains A and B. This can create a problem because we have no idea what this other function is doing. So A can be changed. So we have this function, which takes a person, and then we mutate the person's age by +1. And if that function is currently the func, then A is getting changed. Now, Eric has this great code. It says the DAO of immutability, the true constant is change. Mutation hides change. Hidden change creates chaos. So now you're like, whatever. But if you think about this previous code, even if we compare the same, the person object to the previous person object without a change, it can't tell what is being changed. And the change is actually very, very quiet. And now you don't have any proof that the person's age is getting +1. But of course, you can also do console log before and after, but nobody wants that. So if we write it like this, which returns a new object, and we copy every single properties inside of the person object, this can prevent mutation. But in this case, this is fine, because person only has 2 properties. But imagine you have to copy and paste 500 properties. That gets very tedious, right? So instead, we can use this object.assign, which copies every single thing in the person object and only changes the age. But this also returns a new object, so the person parameter is not getting changed. Or you can use ES6 rest and spread. So then we can deconstruct the age property and copy whatever is copy the rest of the person object. So now let's talk about functional programming in your front end. Disclaimer. I know this is still JavaScript, so things like these will happen, but that's not so bad. Or things like these can happen. But I feel like if you think you can make things better, we should do it. So first things first. Let's all not use vars anymore. Let's change it to let's. Because this is awesome. Or even better, use const. So let is very similar to var, but let is let variables are block scoped, which means so we have a b equals to 1, and then we do something else, and then we reassign b to 2. But since b is also within the if block, the outside b is not being changed. Unlike the var is getting changed. But const variables cannot be changed, which means you also have to initialize them when you declare the variable. So in the first one, a is being declared to 1, and then you try to change a to 2, now that caused some warnings or errors. Now the second one, you didn't give any values to a. So up to this point, we simply used JavaScript syntax. But if you want to take functional programming to another level on the front end, you can also use ImmutableJS with React.js, or ClojureScript, or PureScript even. So how many people here are actually currently using any of them? Cool. Awesome. So I'm going to talk about ImmutableJS first. So this already looks pretty promising. So it has data structures like maps or sets or lists, and they follow a pretty similar rule as in the ES6 APIs. But the ones in this library can never be changed, which also means you make a new map, sets, or list every time you try to make a change. So before this talk, I have a lot of ideas of how to make the slideshows, and I changed a lot of times. But then I was like, okay, I'm going to talk about functional programming, so why not use the functional way of thinking about it? So I make a new copy every time I change the flow of my slideshow, which is really heavy, right, and slow, and this is so inefficient and stupid. But fortunately, ImmutableJS uses this thing called persistent data structures, which means they only copy or they only change the things and corresponding paths to the data to another copy, and then they actually, and then, so for example, you changed 4 to 8. So now you have to make a new path, H and F and C. But the rest of the paths are actually making the same reference. And this is normally pretty bad because sharing data, so shared data can be changed, but since ImmutableJS cannot be changed, then this works perfectly. So I was like, okay, this is cool. This is awesome. So can you all see this? Okay. So on the left, we have a regular map, which you can set it to 1 and high, and then later you can set another one, 2 and by. So now the regular map has size of 2. But if we make a map in ImmutableJS library, we set it to 1 and high, and then we have to reassign whenever we make a change. So the first map is staying the size of 1, sorry. And the new one will have the size of 2. Another example, say we have this whole big object, and then we reset the z, which is the root, to 4, and if we call the map, it still has the original data, where if we assign to nested 2, now nested 2 only has z and 4. Switching gears. So we're going to talk about something that you may or may not be familiar with. ClojureScript. So Clojure is a dialect of Lisp, and ClojureScript is a dialect of Clojure that compiles to JavaScript. And ClojureScript also has immutable data structures. So it also has Lisp syntax as well. So this is the same example as the previous one. So we get the person, and we only change the age property and return that and whatever else is inside of the person. And ClojureScript is actually very modular. So you can create a sub-module inside of the hello world, so then you can reuse it later. And it also has immutable list. So if we have v, 1, 2, 3, and then later we add 4 to it, v is still 1, 2, 3. Now region. Region, now you can write React components inside of ClojureScript. And similar to regular functions as components in React 0.14, I believe. So now you can recognize a lot of the syntax, like the p tag and the div, and even the style sheet. So if all of the built-in data structures are immutable in Clojure, then how do you change variables? So Clojure has this concept of atoms, which is just another data structure, and atoms hold immutable data. So whenever you change, it changes by applying the swap function. So like that. So you make an atom in myAtom, and then you assign it to 0. And then when you try to change myAtom, it's actually pointing to the same atom, but it's an atom that's being changed. And region uses its own atom concept, which it just refreshes or re-renders whenever you make a change. It's kind of similar how components works in React. So if you want to know more about Atom, there's a link to that. And now, PureScript. So PureScript is written in Haskell, and it is a strongly typed language that compiles to JavaScript as well. Therefore, if you're not writing in pure script, you're writing in impure script. So it has the Haskell syntax as well. And back to our previous example of the person. So you take a person, and then you copy everything else from the person, only changes the age. And this is how you will write in pure script. So I don't know if all of you are familiar with the concept, but if you're only starting, I suggest to start with ImmutableJS, and then if you are more comfortable with it, then you can move on to PureScript or ClojureScript. And I know starting something new is very, very hard. And it may be outside of your comfort zone. But I think we should all expand our comfort zone and write something that's more predictable and really easy to think about. And that's all I have. And I really love these things. So if you want to talk about them, you can simply tweet about it. And all my slides are on my GitHub as well. Thank you.
Thank you very much. Great. Thank you so much. Do we have any questions? Oh, yeah, we have a... OK.
Yes, I may have to get back to you on that because I do have a lot of functional programming books, but I can't remember them on top of my head. But I will get back to you on that. Yes, sorry.
Great. Great. Thank you very much, Julia.
Thank you.
So next up, we have Viktor Grishenko out of Swarm.js. So we'll ask him to connect his computer into the system. We've tried this in the last lunch break, and it worked wonders. So hopefully, won't be any problems with it right now. Are we okay? Yes, we're all okay. So works nicely.
Really okay?
Yes.
Okay, let's start.
So probably want to close this.
Yeah, thanks.
Cool. So give it up for Victor, please.
First remark, I have made this presentation in Apple iCloud, the web version. Because the connection to the internet is intermittent, probably we will experience it firsthand how some web applications suck on intermittent internets. I have a backup version in PDF. So, I'm Viktor Grishenko. I'm the author of the Swarm library, which implements RDT-based data synchronization. Whatever it means. I started working on data synchronization in academia many years ago. Then I worked for Yandex, that is a Russian web search company. And currently, I'm kind of free-floating. So I didn't even have time to start, and I already got a proof of my point. Ta-dam. Okay, the PDF version. So, what do reactive applications react to? Actually, the original title for it was like, say reactive one more time. The idea here is very simple. I mean, if we only work with local data and we have a local application, then probably all our problems are already solved by MVC architecture, which was introduced in the early 70s. And what is the tricky part of current web applications is actually working with distributed data. Somebody may modify the data concurrently, for example. And Reactive came from Facebook, and Facebook is a good example. They always give a feed of recent changes and recent events. So I will be mostly talking about data synchronization. That is not the case of Facebook, because Facebook has like very limited synchronization. They have counters, they have replies. But if you implement like very simple interactive application, even a single user application like to-do list, if you consider one to list, a typical user has several devices, and the value of the application is keeping the to-do list synchronized on all the devices, even for a single user application. So that kind of synchronization. Another issue with synchronization is intermittent connectivity. So currently users have, first they have several devices, second those devices are typically connected by wireless internet, which is typically unreliable, and the connection is intermittent. So if you are trying to make like more rich web applications, then we have to deal with it somehow. Oh, sorry, I forgot my clever talking points. So I will be addressing different technologies of data synchronization, like to give you some general understanding of how things work, what solutions exist, who is using what, in the good sense, and what are the advantages and shortcomings of different solutions. This is GraphQL and Falcor are mostly relevant to this talk, because those are technologies which are mostly focused on fetching data from the server. So the key to like serious data synchronization is version data. Version data, I mean, like all the versions of the data somehow identified. So you more or less know which version you have, and you may express the changes as a difference from a particular version. So, well, this interface probably looks familiar to you. Well, the bottom part is actually a Git client. That is like the most common example of version data for every developer. But this is not a web application, obviously. Actually, everything built with Hoodie and PouchDB, CouchDB, it kind of reminds Git very much. I mean, it has a graph of versions, and the user is left to his own tools to merge concurrent versions. So that is the general approach. A little bit higher is Google Docs. You see linear revisions. A little bit higher, I think, is Wunderlist. And the top thing is Google iCloud. They use very strange hashes to identify versions. So they use like sequential identifiers and hashes. I don't really fully understand their approach. I mean, I only know more or less how they build it. Because, yeah. So, four basic ways of synchronizing your data. 4 basic technologies. Patches. Every developer is familiar with patches. So patches can be generalized to synchronize arbitrary data. The technology is very old. So the key paper was published in year 86. Operational transformation, the technology that Google is using for Google Docs. Key paper, 1989. CRDT. This is the logo of the Swarm project. So CRDT is quite a recent mathematical abstraction for dealing with data that naturally exists in many distributed replicas, writable replicas. So basically, you have many replicas of your data. Users may write to whatever replica, and then you need to somehow merge it. This way? Yes. This way? Yes, fantastic. Haha. So, and the fourth option is basically ad hoc solution. It is like, what kind of synchronization? We will implement it over a weekend. It is a very common attitude, and typically it ends in failure. That is the one used by Evernote. So, the most basic computer science abstraction for data synchronization. It is state machine replication. I will describe it in terms of Pacmans. So the idea that a Pacman is your state, and it is modified by some operations which are consumed by the state. And once the state is deterministically changing by those operations, then you can copy over your state to a different computer, feed in the same kind of the same operations in the same order, and the result will be the same state. So more or less literally, that is how master-slave replication works in all the SQL databases. Oracle, MySQL, PostgreSQL, MongoDB, which is not SQL, but anyway. They have writable master, which consumes operations. And then the master plans a log of consumed operations, which are like totally ordered by the de facto order. And that log is fed to slave servers, which are not writable, but only readable. So that is the way to scale reads. Unfortunately, this technology is not usable for client-server synchronization, on the simple reason you cannot copy the entire dataset to the client. So, the next approach is patch-based. It is the one used by Apple iCloud. It is quite a simplistic one. It assumes, it kind of implements this client-side version, not like a full replica, but it is understood as a server version plus some delta. So the client always maintains some delta of its state relative to the recent most server version. So when the client has to push some changes to the server, it simply sends this. If the server has exactly the same state, the server also applies the changes. But in case the server got some concurrent changes, then the update is rejected, and the client has to update its local version, and then rebase its changes, and then push them once more. Well, the good part, it is a really understandable model. Everybody is familiar with patches. It can be generalized a lot. Like, there may be like 3 patches for arbitrary JSON structures. And another good aspect is that there is a linear sequence of versions. There is no concurrency. Concurrency is kind of ignored, worked around, sort of. There are some problems. For example, it is not real-time ready. I mean, if changes happen really fast, at the time scale of change propagation, then you push your changes, the server already has a new version. You update yourself, rebase changes, push again, the server has changed already. So this loop may continue indefinitely. So this is not like a good technology for real-time systems. And another aspect that it actually pins lots of memory on the server, because the server has to keep the client state in memory to interpret all the patches sent by the client. So the server has a copy of a client, essentially, in memory. And as we have seen in the beginning of my talk, it doesn't really work well on intermittent connections. Because intermittent connectivity introduces kind of non-trivial situations. Like the user disconnected, did some non-trivial sequence of actions, submitted it, it failed, or maybe it failed one way. Like the server received it, but the client wasn't acknowledged, like, and everything. So basically, it is not really good for intermittent. Google operational transformation. Actually, it is not Google's technology. It came from academia. The idea is that we break down state into atomic operations, and we understand state as basically accumulation of a sequence of operations. In operational transformation, we don't pretend that we have a single linear sequence. Instead, we rewrite operations in flight to make them fit for our local order of events. So the client-side replica is not phantom replica, it is like real replica. But we need to rewrite operations in flight. I mean, if you inserted some symbol at position 7, send it to the server. Server already has some concurrent change. So that is now position 5. So the server rewrites the operation, sends it to another client, but for another client, it is already position 10. So operation is rewritten at every step. Apparently, this technology is not really good with offline because it took Google more than 5 years to make decent offline mode. But the good part is that actually, I don't like OT because it is really hard to understand. I mean, the story of OT is like first 20 years of operational transformation is like every next article rejects the previous article, saying there are some failures and there are some concurrency cases which are not actually resolved. The top problem of OT probably is it is hard to understand, it is fragile. So if you screw up one operation, you screw up everything. And it also has the problem of pinned memory, which, I mean, the server needs the full model in memory. The most simple approach, which is like the most simple implement, and that is the top advantage, is doing some ad hoc stuff over the weekend. Obviously, this approach has some problems. I mean, you make test cases for like 1 million cases, then you deploy it to 100 million users, and every day 100 of your users lose all of their data on some strange reason. I mean, operational transformation has a mathematical theory for it. Patches are kind of less deterministic, but they also have a mathematical theory. And basically, if you go into synchronization and you rely simply on your common sense, you will, how to say it, you'll be doing really badly. I mean, the effects will be really bad. That is exactly the case of Evernote, because they had like ad hoc synchronization, and they were suffering from data loss for several years, unable to resolve it. I mean, like one client in a million loses data, and what can you do? So, CRDTs. CRDTs, sorry, is it actually the time when I should have started my talk?
15 more minutes or 13 more minutes.
Excellent, excellent. I'll have more time to advertise my project. So, CRDT, commutative replicated data types, or convergent replicated data types, or conflict-free replicated data types. Actually, conflict-free is a general term, and convergent and commutative, two kinds of it. Convergent is state-based, when you merge entire state of objects, and commutative when you basically pass all the operations to all the replicas and they absorb them in different order. So, so far, the top industrial code base for CRDT is React, React, the database. Who knows about React? Yeah, it's quite popular. I mean, it is a really good product. I mean, this state-based CRDT is a technology which is really, really hard to kill. I mean, every state may be merged with every other state. So, in terms of a Pac-Man model, it is a Pac-Man that is eating other Pac-Mans. And once one Pac-Man eats all the other Pac-Mans, it converges. I mean, if you have two states of the same object, you can always merge them and get the merged state. I mean, it is really, really hard to break. The problem here is that this technology is mostly good for server-side use when you have your database in the data center. You don't really care that you send back like 100 kilobytes and everything. I mean, on the client, you cannot simply send the state back and forth. Suppose you have a collaborative real-time editor, and every time you press a button, you send the entire state to the server. So that is the server-side technology. And finally, Swarm implements the other kind of operational transformation, the other kind of CRDT. Actually, operational transformation and CRDT are kind of rival technologies. It's a long story. I mean, even OT researchers go to their OT conferences and CRDT researchers go to their CRDT conferences. And they kind of don't talk to each other. The idea about operation-based CRDTs is that the state, the pacman, may absorb operations in slightly varying orders. So concurrent operations may come in whatever order. So this pacman eats operations like in this order. You see, there are two operations number 2, because both replicas had operation number 1, and then actually it originated here and spread here, and then they concurrently introduced operations 2, like 2, whatever, strich? Whatever, 2 strich, 2 double strich. So once they changed those operations, like both replicas got all the operations, but they got them in slightly different order. So op-based CRDT are data structures which are designed to absorb that operations maybe in slightly varying order and to converge as a result. The good part, they're usable like at the client side. I mean, like in operation transformation, like in patch-based architectures, you always only send the delta to the server and you receive delta from the server. Everything is explicitly versioned normally, and well, it is a little bit more difficult to implement than state-based CRDT actually. Yeah, but the good part is that you can kind of cache your data unlimitedly. I mean, all your data you downloaded from the server, you may stash in a local database, and that is okay. I mean, next time you will need, you may update it, or you may find that you don't need any updates. You may work offline, modify your data offline, and then it will merge asynchronously. So basically, the entire model is kind of defined in very asynchronous terms. I mean, it doesn't matter whether you have internet connection now, or you will have it like in an hour from now. It will work more or less the same. I mean, if Apple iCloud will be implemented with kind of technology, it will not have this kind of issues. Obviously, it works in real time really well because you only send back and forth single operations. So basically, the only limitation is physical propagation time. So this is the concept drawing for the Swarm project, which is not that far from reality. The idea, once you have Swarm clients at every client, like your Android client, web client, and whatever, Swarm kind of synchronizes all of your data in background. You may freely modify local replicas, it is okay. And it only uses data structures which are mergeable, so it will be automatically merged. And obviously, it may dump the data to various kinds of relational and non-relational databases. That kind of a thing. So the first developer pre-released about a year ago. It wasn't like, it was by no means production ready. It was like running. Flash crowd from Hacker News about, well, I don't know, maybe even 100,000 users. I mean, the demo. And over the past year, it improved quite a lot. I mean, in terms of production readiness. And the problem here is that operation-based CRDTs have not been run like industrially or in the wild before. It is a very new theory. So Swarm actually has some original mathematics inside, some problems which had to be solved for the first time, which is very thrilling, both for the developers and for the users, of course. But it is also very entertaining. So this is the architecture of the current version of the product. At this point, I think it is fair enough to say it is a distributed database because it is sort of a distributed database. It runs normally over some storage engine like level DB on the server and index DB on the client. And okay, it is hard to understand, so I'll better add some pacmans. The idea is like this. You have your local client-side state, which has CRDT objects. They're actually hidden from the developer. They're like poor math objects. Everybody likes poor here. They are not like poor functional, but they're like poor mathematics. I mean, they have no connection to graphical interface and whatever, completely passive. They simply consume operations and change their state. And there are API objects, syncables, which a developer is working with, which pretend to be regular JavaScript objects. And just sometimes they emit changed events because of remote changes and not because of local changes. And obviously they merge remote changes correctly. This is the Pacman part, the state. And there is also the log part, replica. Replica is basically a can of pellets Pacman needs. So replica deals with the operation log. So it keeps operation log, it caches operation log. If it wasn't, for example, yet sent to the server, it keeps states. So basically it is a key value database which synchronizes. Its mission is to ensure that every operation is delivered to every replica. That's it. So every Pacman gets his pills. And that is the general idea. So the architecture is kind of multi-tiered. It is kind of variably multi-tiered. So for example, you may have your local cache in the browser using IndexedDB. You may have, which may talk to on-premises cache or on-device cache daemon, for example. So for example, one of current projects is that you have a mobile device which has a database daemon on it, which is synchronizing like all the data in the system. I mean, independently which application is working with it. And well, it's also offline and real time and everything. And then we have like the cloud replica, which talks to all other clients. There are different variations to it, like synchronizing different tabs in the browser and so on and so forth. So probably I will show a little demo, which is about 1 year old. And it still runs on the server unchanged. It is a to-do list. So I run Iridium on the right, and I think Chromium on the left, and Chrome on the left. And hopefully I'm online right now. Yes, I'm online. If you have sharp vision and you may read the URL, then you may play yourself. Papyrus / go reactive. And then you'll have this list you may play with. So it synchronizes in real time. Well, the network is not really good, so like almost real time. And the good part, it perfectly works offline. So suppose I check all the entries on this side, and I remove this entry on this side. Okay, let's go back online. Removed one, check two. So there must be 2 of them on each side, and all of them must be checked. Yes, I am. So the internet is real crap, but the good aspect of this technology doesn't really depend on it. I mean, it may synchronize 1 hour later in case it will not connect. Yeah, it cannot connect, you see. Okay, let's give it some time to catch Wi-Fi. Quite likely it will need quite a lot of time. 1 second. Yeah. So another interesting trick is that it actually synchronizes different tabs. So for example, I launch another Iridium. I copy over the URL. The application is already cached. It has manifest. So you may load it offline. I guess people who watch the translation also decided to play because they have good internet. we cannot play here, but well. Typically, at this point, organizers start to feel slight panic because what if somebody writes something wrong? I don't feel any panic. Okay, I think it's time for questions. The project is on GitHub, so I don't know where the GitHub will load. No.
Slide out to see the questions. Yeah.
What does CRDT mean? CRDT is it is like a mathematical model for a data type where every object exists in numerous replicas, and every replica is writable. So the abbreviation CRDT, like the general case, means conflict-free replicated data type, which is further subdivided into subtypes, state-based and operation-based. State-based is convergent replicated data type, and operation-based is commutative replicated data type. So they are sometimes abbreviated CMRDT and CVRDT to avoid confusion. It is a rather new mathematical theory because basically 20 years ago we didn't have the problem. We had like one big server somewhere in the cloud, which was the source of the truth. So there was no problem with synchronization. And before that, in the mainframe era, we had that even less. And in the PC era, we didn't have to synchronize much too. So we simply had to send or pass around a disk with Word files, and it wasn't a problem.
We have time for one more question.
One more question, please. The patch-based model seems to work quite well offline with a central store, yes, sure, and multiple clients. Which category does it fall into? There is an issue here because Git assumes an expert user who can manually merge changes if the algorithm fails. And algorithm fails quite a lot. And you simply cannot use it in web systems because you don't have the qualified user. I mean, if you resort to the user, then basically you're screwed. I mean, do you have a time for one story from my life?
Of course. So it all started when you were 3 years old, right? This kind of story. Yeah.
No, I mean, it was a year ago. It was demo day. Me and my partner have been finishing the presentation in Keynote. So I was using iPad. He was using MacBook. He was working from home. And I mean, we edited it intensively. So at some point, we made concurrent edits. So for me, it said like, sorry, you cannot edit this presentation anymore. And for him, it said like, we have two conflicting versions, please pick one. So that is exactly the example when you resort to the user to make a decision. Some strange reason, that version was 1 week old. So basically, if you shift responsibility to the user, that is a good sign that you're doing something wrong. You are simply avoiding responsibility.
And on this positive note, I would end the discussion right now. Thank you very much, Victor. Thank you. So we have Paul give another talk because in the morning he had so many questions and so many topics to talk to in the room again. So please give it up for Paul and for his second talk for today.
Hello, everybody. Get some more water. Oh, good, that's working, okay. Well, hello again. you guys already know me if you were more awake than I was this morning. I am going to talk about evolving reactive extensions for JavaScript. So before I get started, just hands up or nod at me or something if you've heard of RX or have used RX. Cool. That's more hands than I expected. How about people who would consider themselves even slightly above beginner level? Maybe. Oh, that guy right there. All right. Cool. Well, actually, that's perfect because I tried to make the first half of my talk an intense introduction, whereas the second half of my talk is going to be flying into space. So, cool. Well, that's who I am. And I'm going to introduce the observable type to everybody. And if you've read a little bit about the observable type or you've heard some people talk about it, it might sound just like another event emitter or event dispatcher or thing that you subscribe to. You give it a callback and then it gives you some data later, which is partly true, but the observable is absolutely not in any way like even remotely related to any of these concepts right here. And that's the biggest hurdle learning RX is we all know reactive programming, we all use event handlers and get callbacks later, but nothing is RX. All of these guys are essentially the same thing. They're an array of callbacks. You can call a function that'll iterate over the array and then call all those callbacks with the same piece of data. That's all of these guys do that. An observable, in my words, is the idea of future values, maybe. But what does that mean? So I'll take a look at some other ideas of future values. In the first quadrant, we've got functions. And it may seem strange to call a function an idea of a value. But ultimately, that's kind of what it is. It's not the value yet. It produces a value whenever you want it to. But functions are synchronous. So a function can synchronously give you back a value. Something that can synchronously give you back multiple values would be an enumerable. Something that can asynchronously give you back a single value is a promise. And then an observable is something that can asynchronously give you back multiple values. I don't particularly like talking about it in terms of synchronous versus asynchronous because they kind of imply that asynchronous will always be some point in the future. Instead, I like to think about it in terms of pull versus push. And these concepts really apply to, they relate to who's consuming one of these ideas of values. So if you're a function or an enumerable and you're the consumer, you're going to pull the value. You get to decide when you want the value. If you're an enumerable, you get to do a for loop over it. But if you're these two bottom guys, it's actually inverted. The promise or the observable decides when the consumer receives a value. And the consumer doesn't really have any choice when it gets that value. So let's talk about the just basic functions. This is kind of what I mean when I say it's an idea of a value. We can instantiate a function, in this case, a function that returns us a random number. But we haven't really done anything except like create that idea of a future random number. But at the bottom here, we then go and get that value. This is also referred to as laziness. A lot of people see the word lazy and either think slacking off or that it's related to something else. That's really the concept, that you instantiate some sort of wrapper that later, when you want, you can invoke and get the value from it. So the anatomy of an observable is, if an observable is the idea of future values maybe, then just like with functions, with observables there's the creation step. Then there's the subscription step, which is analogous to calling the observable, like you would call a function. But then the observable has something that the functions don't have, which is disposal. So when you call a function, if in a single-threaded language, there's really no way to interrupt the function. You invoke it, and then it gives you back the value. But with an observable, especially whenever it could give you those values over time, you might want to cancel. You might want to stop listening and tell it to shut up. And that's where disposal comes in. So right here, just to break this down, here's kind of a creation step. If we're just going to create an observable that's going to give us random numbers in the future, we can just do it with the observable create factory. And that just takes a subscriber function. The subscriber function actually gets run whenever you subscribe. Like every single subscriber will re-invoke this function. So in our case, this function is going to instantiate or going to allocate a set timeout callback for 1,000 milliseconds from now. And then here's the third step, disposal, that functions don't have. You can't interrupt functions. But this, theoretically, after you subscribed, but before the set timeout had triggered, you could decide to throw away your subscription, and we want to clean up that memory. We wouldn't want this set timeout to keep going. And so this last step right here, I marked with a pink star, because this is actually where we call random numbers.subscribe. That's actually like the same thing as doing function.apply or function.call. So next. And this is like one of my favorite little tests. Once I tell people that, they're like, oh yeah, I totally get that, all right. But then I throw this at them. So if I just have this random numbers observable, and I subscribe to it twice, and then I print out the results, what do you think happens? A lot of people say the same random number gets printed. And I don't fault them for that. That's the event emitter model. But this is what happens. The first guy gets a random number, the second guy gets a completely different random number. And here's why. So when we create it, and then we subscribe to it, then we run the subscriber function for the first subscription, which calls set timeout. Then we run the subscriber function for the second subscription. And then eventually our set timeout completes for the first thing, and we call subscriber.next and pass it math.random. And then we call subscriber.complete. Then set timeout for the second subscription, number 2, also resolves, and then we pass the second subscriber a different random number. So just like if this were a function, and you called this random numbers function twice, you would get 2 different random numbers out. I mean, that's all it is. An observable is a future function. So if observables aren't event emitters, event dispatchers, or event delegates, what are they? They are functions. And here's my real definition for observable. This is what I tell to people when I want to freak them out. I say observable is a function that when invoked returns 0 to infinity values between now and the end of time. Which I think is a pretty accurate answer. Observables have operators. And what are operators? Operators are methods that perform calculations on the values. Things like map, filter, scan, reduce. If you're familiar with the array extras, or lodash, or underscore, then you'll be familiar with a lot of these. But then observable also has a lot of ones that are specific to it. If you're talking about asynchronous values, then you're talking about temporal operators like delay, debounce, time interval, throttle. Some people call it lodash for events. I don't call it that, but you can. So what does an operator actually look like? Like, this is just kind of a real basic crash course introduction. There's a lot more to this. But if we had kind of this basic structure of an observable where the constructor takes the subscribe function, it just puts it on itself, and then it also defines the map operator. Well, the map operator takes a function. It's going to return a new observable. What we have to do is we have to save out who we currently are, so that when someone subscribes to this new observable, we can call back to our source and map the events that our source is going to give us. So in this way, we kind of create this chain. So if we just have this observable chain, observable.of creates an observable that will on-next the arguments that you give it, then we have all these cool filters that we can apply functions over the events and change them as they go through. All right, so this part I usually don't talk about, because even people who like RX don't like schedulers. Schedulers are centralized dispatchers to control concurrency. And the reason I'm talking about this is because the rest of my talk has a lot to do with this part. This is really kind of a deep inside part of Rx that a lot of people don't really have to worry about. But they're absolutely key. If you're thinking about it, you have all these asynchronous observables happening. You might subscribe to this one and that one. They might be getting events in at different times. You really want to kind of send them through a central dispatcher or be able to coordinate them in some way. And that's really what schedulers give you. So there's a couple different schedulers in Rx. There's the immediate scheduler, which has sort of a trampolining. It pushes actions onto a queue and pops them off in a while loop. There's the timeout scheduler, which just uses set timeout. The request animation frame scheduler is one of my favorites because it allows you to very easily synchronize going from model updates to DOM rendering without thrashing the DOM. So what do schedulers look like? If I was going to create the range operator, range is kind of like Lodash's range. You give it like a start value and a length, and then in Lodash it would give you back an array of all those numbers. Well, in observable, we want to just iterate and create those numbers lazily. But you can give the range an optional scheduler. And this is really what happens with the scheduler. Scheduler has a schedule method that takes a closure and then optionally some state at the end. And then what you can do is the action can recursively reschedule itself until it decides that it's done and it doesn't need to anymore. This is really just there to blow your minds. You don't really have to read it. But schedulers are also useful. They can be passed into certain operators. Like in this case, I've got a mouse move event that might happen super fast. Well, I want to throttle, but I want to throttle on the request animation frame. So that way, I only call my React.render down here whenever the browser's ready to paint. Whew, all right, that was the crash course into Rx. I hope you guys understood it. This is really what this talk is actually about. The next version of Rx. It's officially going to be number 5. That's been sanctioned by the team at Microsoft. And it's available at github.com/reactivex/rxjs. And we have an amazing contributor list. In addition to companies like where I worked, we've got people from the Google team, obviously the Rx team at Microsoft, Mr. Andre Stoltz over there. Ben at Netflix has been instrumental. He's kind of the project lead. He coordinates everything. He's big into open source. And this OJ Kwan over here, I don't know where the hell he came from, but I'm glad he's here. These guys are prolific. They've written way more code than I have in Rx, so the rest of the contributors are also important. I just can't talk about them all. So the primary goals for this version of Rx is modularity, improving performance, improving the debugging story, improving extensibility, like what if you want to extend observable? And then also writing much easier to read and write unit tests. If anybody's ever seen Rx's unit tests, they aren't necessarily the nicest to you. In terms of modularity, that's been a big complaint from everybody in the Node world, is that with Rx, you've always kind of had to bring in everything or nothing. And these sort of like light builds that Matt would compile never really did it for him. So in this latest one, if you're using something like TypeScript or ES6, you can sort of import just the operators you want with modules. So that, the new Rx so far is on average 4.3 times faster than current Rx. Numbers I've seen personally on my machine are up to 11 times, but Ben was telling me that some of the macro tests are sometimes 26 times faster. So that's just ridiculous. I mean, I don't know anything that gets 26 times faster. So we have a full performance test suite, which is something Rx really never shipped with. Like, they were kind of added on later. But we've also got, with the Google Angular team, they got the benchmark tests running. So if you're crazy enough to run those, they'll like spin up 100 instances of Chrome and like thrash the DOM a whole bunch and see how Rx performs. It's really being battle tested pretty well. On the memory front, at least 50% fewer allocations on subscribe, and potentially up to 90 depending on what schedulers you're using, which is just amazing. Debugging too, also the call stacks are massively improved. If anybody's ever debugged or had to step through the internals of RX, you know, you on next, and then it goes to an internal on next, and that goes to an abstract observer next, and then that one goes to a try catcher, and then the other one comes back, and then you accidentally hit the other key that steps over, and now you've lost your place. So that's been a big help with the newest version of RX. I put together just a few little examples just to see the difference between the two. Is that one? Okay. So something we really needed at Netflix, like they were very, very anti-RX on Node. Ironically, Netflix, you know, writing RX Java and then using RxJS in the client everywhere, the Node guys weren't having it. So this is kind of what spurred this. We really needed to be able to get better looking flame graphs. So this is just an example where I did a flat map followed up by another flat map. Really not that crazy, like it actually happens all the time. And that's what RX looks like today. RX5 looks like that, which I don't know if that makes any difference. But what you see is like a lot of this stuff that's all broken up. Number one, there's a lot of de-optimized functions because they're doing a lot of try catches everywhere. But also you can't really follow an event all the way through the next because it constantly jumps back to the schedulers. So having these wider lines that then you can see, oh, that's where it's taking all the time, is really great, especially on the server. And here's another one where I use switch map. I did a switch map and then a switch map in RX4. And actually, this one kind of broke my computer. The graph was so long that I had to take screenshots in chunks. I mean, it was just wild. And this is what it looks like in RX5. So pretty big improvement there. So hope that's useful for everybody. So what got us to this point? We decided we needed to overhaul the schedulers. Internally, the schedulers do a lot for us. They're a really great concept, but there's a lot of legacy from C# and other stuff. We also completely changed the architecture of how operators are implemented. We implement them with classes and very, very few closures because we realized, talking to the V8 team, that they optimize prototype lookups and can create anonymous interclasses and do some optimizations there. We're also able to unify the observer and the subscriber, or the disposable. So that's how we actually get just off the top 50% fewer allocations, because those were always allocated in pairs, and now they're a single object. We also flatten the disposable tree, so if you subscribe to an observable and it's got flat maps and stuff inside of it, you don't know what's happening. There's this kind of expansive disposable tree that could potentially get created. We flattened all of that into a single list by sharing the same composite disposable between everybody all the way through. So removing disposables is faster, it's less memory. And then we also removed all these try catches from the internals, because if we're calling framework internal code, and we kind of trust our unit tests, then we're pretty sure we're not going to get runtime exceptions. And so all the try catches we're doing were just being annoying for debugging and de-optimizing our functions. The flat map versus lift discussion is kind of interesting. We went from an architecture where everything was kind of architected off of flat map. Basically, flat map is this God operator that can implement any other operator if you are tricky enough. So flat map's signature, not to get too TypeScripty into this, but it's a function that goes from type T to type R. It takes a higher order function, it's a higher order function, so it takes a function that accepts the value of T and then returns an observable of R, and then merges that together. If anybody, there's a lot of functional people here, so people are probably familiar. This is monadic bind. So this is exactly the signature of bind. So we moved to lift, which is at first looks kind of similar, but then looks a little stranger. It's also a function that goes from T to R, but it takes a selector that doesn't take a value, it takes a subscriber of T and returns a subscriber of R. but then somehow returns an observable of R, and it's just kind of this black magic voodoo. This is kind of the flat map way of doing things. This is like a map function that I showed you before, where we get our projection function, we sort of save out the source, then we just allocate a new observable and return it. This is problematic for a couple of reasons, because number one, closure scope is slower than accessing things on a prototype. Number two is it's inflexible, so if you subclass observable, like subject or your custom type, and then you call map, well, now you've lost your subclass type, so it kind of overrides, and now you're just back to using an observable. And also, there's all these closures down here when we subscribe to the source that really should exist on a subscriber prototype somewhere. We don't need to allocate them every time. So that's where lift comes in. This is how map would be written in lift. Really, map is just a function that takes a projector and then calls lift. So all of the operators want to call lift. Lift takes a map operator, which is just a class instance that has a call function. The map operator can store anything on its prototype it wants, but then whenever call is invoked, it's supposed to take the observer that you give it and then pass that to a new subscriber. So let's say I'm the first subscriber, then I subscribe to the map thing gets told about me, and then the map thing subscribes to the source. So that's how you kind of create the chain in a different way without using closures. This way is super, super fast. Also, it gives us the benefit that it delegates the new observable creation to the function. So if you're going to subclass observable, all you have to do is override lift. So this is kind of cool because when you called flat map, you got back out an observable, and you lost all your custom methods. What this also allows us to do is if you use something like WebSockets, where you have subjects that are two-way communication, you could never flat map those either because you get out observables. So we can maintain the bidirectionality of communication. And potentially in the future, just put in back pressure support too, the way that RxJava did. So we're keeping that open as an option. So this is kind of an example of using a mouse observable. I have a demo of this that I might be able to show at the end if I can get through this fast enough, where I'm subclassing observable. I'm overriding lift to return a new instance of the mouse observable. So every time you call a function, like an operator on the mouse observable, you're going to get a new mouse observable. I added these two little functions down here to track the velocity and then also concatenate friction events. And that's kind of a stub. And then here's how I'm using it. So if I do, this is sort of a canonical Rx drag drop example, where you have an observable from the mouse down event that you flat map, and inside of that you return all of the mouse moves until a mouse up, but I've added my own tricky little things here with the mouse observable tracking the velocity as the user is moving their mouse. And then at the very end, concat friction says, all right, once they've finished, let's take the most recent event, start with that velocity, and then fake a bunch of events. So whoever's subscribing to this doesn't know that they're getting fake events. And then, of course, we throttle, and then we render. Also, so WebSockets, this is really useful if you've got streaming stuff or little Bluetooth devices you talk to that talk over WebSockets. In this case, I'm telling Navi to shut up. All right, simple unit tests, marble diagrams. If anybody's ever seen this, this is from the documentation. Actually, Andre Staltz had the best idea I've ever heard, which is why can't we just write our unit tests as marble diagrams? Because that makes a whole lot more sense than like having an 18-line thing that checks numbers. So this is kind of what our unit tests look like right now. So you tell it what your observable is, you tell it what you're expecting to get out at the end, and then you say expect observable, filter to be this string. And that's it. That's the crash course in the new Rx.
Great.
If you want, I can actually just real quick show that little demo.
Okay, so let's get back to the screen.
Oh.
Yeah. Yep. Okay.
All right. So this is something I did actually like a while ago when I first joined Netflix. This is a virtualized scrolling list. Well, wait a minute. I don't know why it's not scrolling faster. There we go. It's scrolling, so it's doing all the scrolling natively. It's not doing any sort of, it's not using native scroll bars. It's doing UI recycling. It's not doing any reflow. It's using CSS to move. And then it's doing all the tracking velocity and slowing down with friction. I don't know why it's, there we go. It just, and it just runs super fast. And this is actually in an older version of RX, but this is just, like, everybody's always like, oh, RX is so slow. And it's a lot of times, it can be, but it's also in how people use things. Also, before I go, if anybody, I just want to point these out. These are two files which are kind of buried really, really deep in the documentation, but this is kind of the most common complaint I see about RX is that there's too many operators, and I totally agree. But there's a decision tree for static operators. If you're like, oh, I have this problem, and what do I need, you know, what operator do I use? You can say, I want to create a new sequence that iterates over an asynchronous element. Okay, bam, right there. And the same thing for the instance operators. If you're ever looking for the right operator to do something, you're like, it must be there. You can just go to this decision tree. It's in doc/getting started. So, all right.
Okay, cool. Let's move to the questions. Let's do like 2 or 3 questions.
Sure. How are observables different from ES6 generators? ES6 generators are actually closer to enumerables. They're poll-based. Although there is that weird, like, talking back to them thing. Observables are push. So you subscribe to the observable, you give it 3 callbacks, and then it decides if it wants to call those whenever. It's also different because the generator is, once you've enumerated a result from it, it's exhausted. You can't re-enumerate it, which feels like kind of a flaw, but whatever. Bacon. Bacon is multicast by default, actually, where there's a big discussion about that right now. The idea that an observable is a function, in RX land, they call that cold. I don't know why. It's really easier to understand if you think about an async function. But Bacon, the observables aren't always cold. But the problem is, if you go from cold to hot meaning that you have a subscription that is a subject that has a list of observers, just like an event emitter, you can never really go back to being cold or purely functional. So you have to kind of have the functional primitive, and then you can sort of graduate to sharing the events if you need to. How do we manage to improve performance? All of those techniques, moving to lift, revamping the schedulers. We do things like object pooling, or we recycle the same scheduled action. We basically went and said, all right, let's be functionally pure about everything, but then let's find all of the places that using dirty mutable state can, like, save us a bunch of time and money. So that's what we did. Why is it incorrect to call it Lodash for events? It's like, the idea is great, but Lodash works on arrays, and arrays aren't functions. Arrays are mutable things. A better example would be the IEnumerable type in C#. IEnumerables or iterables in Java essentially are factories for an iterator. So you can always go back and re-enumerate something, and that's why it's not necessarily the same thing as Lodash. You're not performing a calculation whenever you do a map and a filter sequence. Another thing that's different is in Lodash, if you're going to do map and then filter, well, you're creating an intermediate array to store all the results of the map operation. Then you're creating another intermediate array to store all the results of the filter operation. So you just created 2 arrays there. So you exhausted it to create map, then you did all the filter stuff. Well, in RX, it's not that way, since it's kind of a pipeline. One event goes through the map thing, then it immediately goes through the filter thing, and then you immediately get it. And then the second event goes through kind of like that. So, what, Falcor? Oh,
no. That's the one last one, yeah?
Yeah, Falcor will totally be compatible with RX because the result of Falcor has a subscribe function, and RX works with any object that has a subscribe function. It's just internally, we didn't need it anymore. We were using it to do some complex asynchronous state handling that we don't have to do anymore.
Cool. Thank you so much.
Cool.
Thank you. And as last time, probably you're going to be in the room back, and you can have your group of people wanting to talk to you wait for you there. I have 2 or 3 information before I'm going to let you for a coffee break. The people that are subscribed for Lightning Talks, please raise your hands. Lightning Talk speakers, 1, 2, 3. Okay, a couple of you. I will need you guys to come here before, like right now, after I say go for coffee. So we're going to test the computers. So please, the guys with Lightning Talks, and if you have your friends with Lightning Talks and not sitting here, just bring them here. That's one thing. The other thing is your coffee and be back at 15 minutes after 5, 5:15, for the last 2 presentations and the Lightning Talks. Thank you so much. I would love to welcome our next guest out of Yahoo, Rajiv, to talk about Universal React and Flux at scale. So I will leave the stage to Rajiv to give his talk on this topic. So give it up for Rajiv, please.
Hello? Cool. Okay, so implementation that we came up with pretty early on. I want to talk about why we made Flexible, what challenges it solved for us, and some of the challenges that we're facing right now as we try to scale it out. So before React, we were in a world with YUI. YUI was invented at Yahoo. It was basically the jQuery before jQuery. It provided the cross-browser abstractions needed to manipulate the DOM, provided a nice module layer. It was really nice. And then we started to move into doing server-side rendering with Node. And that's where we realized YUI can't simply be moved onto the server. But we did realize the importance of sharing code between the server and client, so we used Dust.js templates to achieve server-side rendering. So this is when a new thing called React came about, and we thought we could just swap it in and use it as a new template language. But we soon realized it was more than just a template language, because React comes with built-in events and a well-defined lifecycle. And what that means is you can now start to put the code UI, like your UI logic, right where your UI markup is. And that helps a lot in terms of making your code easier to reason about. Also with React, you no longer had to touch the DOM as much because it did efficient DOM updates with its virtual DOM diffing. So that meant you didn't really need the cross-browser DOM abstractions that YUI or jQuery might provide. And all of this with declarative templates that you can actually write in pure JS without actually transpiling them. It just made React a really awesome win for us. So as we started to realize the benefits of React, Flux was becoming a thing. And if you're not familiar with Flux, Flux is a unidirectional data flow. Actions dispatch some data into your stores, and then your views react to it and render. And you can fire off more actions responding to user events. But we wanted to get this working on the client and server. So how does this look on the server? Well, you don't have UI events, but it is a concurrent environment. That means you have two different users accessing your site at the same time. They get through the dispatcher, they get to the store, and to the view. And this is where it gets complicated because the view doesn't know what to display. Because now the store is a singleton, and so the latest value always overrides the previous value. So that doesn't work on the server. We realized what everybody else who was working on Flux at the time realized, which is we have to class the dispatcher and stores and instantiate them per request. And that solves our simple problem of each user getting their own view and own data. So this is all well and good. You have Flux on the server and client. So how do we make this truly universal? How do we make the client pick up where the server leaves off? Well, when you're done rendering on the server, you send your markup down. But that's not enough for React. If you call React.render, it'll throw away the markup and render its own markup because React needs the state that you use to generate the markup. So you also have to send down that state. Once you do that, the browser, the client-side Flux can take over. And you have that. So whereas before, we thought we were only going to share React on the server and client, we were now sharing Flux and Flexible specifically. This allows us to get rid of YUI on the client and instead rely on polyfills. So what this means is we write all of our code in just pure JavaScript whenever we need to, and we rely on polyfills instead of the cross-browser abstractions you might get with the jQuery or YUI. We were also able to get rid of our MVC abstractions and share Flux in both the client and server. And we were also able to use Babel to transpile our JSX because we soon learned that JSX was a lot more fun to write in. I want to quickly address CSS as well. So Atomic CSS is something that Yahoo's open sourced, and I don't want to go too deep into it because it's a talk on its own, but it's a really new approach to CSS you guys should check out. So what we have is a really cool Flux implementation that we use internally. Our internal framework wraps this Fluxible with our own Flexible plugins. Flexible was designed from the ground up to be pluggable so that you can use it for whatever use cases. We have our own Express middleware, and that's kind of it. That creates the stack for the entire Yahoo media organization. So one quick caveat is that before we made Flexible, this framework was a thing at Yahoo. So we actually realized all the parts of it that we could open source, that were generic enough to be open source. We abstracted it and then open sourced it. So now that we've kind of briefly touched on React and Flux that you guys are probably already familiar with, what is scale? What does it mean to be developing applications at scale? Well, for me, it means two things. There is scale of development and scale of product. Scale of development is that. That is basically our Webpack dependency graph. So you see like hundreds of modules, and that whole tree doesn't even fit inside of this slide. It's huge. And this is only one app. We have a lot of applications at Yahoo, and we have dozens of teams and hundreds of developers working on this. So how do we sanely keep developing? Well, once you get to a certain size, you have to invest in the right tools so that your developers can work productively. So some tools we use are ESLint and JSCS. This helps you enforce code quality across all of your repos. We use Grunt to run our tasks. We share Grunt tasks between projects. We use Yeoman so that people don't have to start off with a completely blank slate. You get a good starting point for your apps and new features. We use Webpack's dev server and hot reloading features for really cool like live reloading awesomeness. And we use our Jenkins CI/CD for testing and developing features without worrying about whether you've broken something else. And really, I know I'm just throwing a lot of tools at you, but it's not important what tools you use as long as your whole team is using the same tools. It's not important Grunt versus Gulp, but you pick one and you stick to it. That really allows the maximum shareability. So next, the scale of product. It's easy to think that Yahoo is just one product, but it really is a lot of products. If you quickly look at our menu, you realize there's a lot of diverse products here. How do we go about creating an internal framework that is able to support all of these use cases? We have to let each one of these teams, and there is a team behind each one of these products. Each one of them needs to work independently, but also we need to allow them to reuse as much as possible between the products. Let's look at one of them, the homepage itself. If we were able to start from scratch and design yahoo.com over today, if I gave this to a web developer, he'd be able to slice it into a 3-column layout, identify the important parts of the page, and come up with the layouts. Come up with the components that fit in the layout. This sounds easy, but at a scale like Yahoo, what happens is every single one of these components is designed by a different team. That actually makes it really complicated when you want to put it all together into one cohesive experience. And this problem is only complicated more by something we call context. Context is basically how the user is accessing the site. And this is very important. It's extremely important as your app starts to scale. A few examples of context. Device. A user could be on a smartphone, on a desktop, on a tablet. It's important not to serve the same exact experience to each of those devices. A small application or a startup might serve the same exact application across all 3 devices. And you might hide the fact with some responsive CSS. But what's really needed is responsive JavaScript. If half the code in your component is never seen by your desktop app and is only meant for your smartphone app, and vice versa, is there really a point in serving the extra bloat? to either device. I think we can do better. So authentication. In the same line of thought, if you have a logged in and logged out user, do you want to penalize the logged out user with all of the extra logic that comes with the logged in user? Maybe your logged in user is like a completely single page app with like so many like routes and features, but all the logged out user needs is just a way to sign up probably, and the value proposition. So let's think about browsers for a second. It's easy to ignore, understandably, easy to ignore IE these days. But when you are dealing with a scale like Yahoo, we have 1 billion monthly active users. Even if a tiny fraction of them use IE6, it becomes not affordable for us to lose those users and give them a broken experience. Even if these low-grade browsers don't support the fancy web page, fancy React applications, you can still give them a server-rendered page, have it look nice on the first load. You don't have to just serve them all of your JavaScript assets and have them not even load. So context has a lot of dimensions to it. Devices, authentication, status, browsers. You could even include A/B testing and locales. It could go on, and it only increases the complexity of your app. A first pass at this might look like this. You could just be like, oh, if I'm on the smartphone, let's render this guy. And if I'm on the desktop, or if I'm on this A/B test, if I'm in the experimental group, if I'm in the control group, you could do this all over your application, and this might make sense to you, but if a lot of developers are doing this in different parts of the code base simultaneously, you have this bloat everywhere, and people are afraid to delete these giant if-else blocks. So we actually don't want to do this. What we really need is a way to serve the minimal resources needed for the best possible user experience for that one request. And our solution for this is something we call dynamic page composition. It's essentially logic that will decide how your page will look and what resources your page will need based on the current context. And there are 4 important resources when it comes to pages: layouts, components, data, and assets. I want to go into detail about each of these. Layouts. Layouts are easy. They basically take in components as input, and then they arrange them into different arrangements based on what context you're in. The top one could be a desktop, and the middle one could be a tablet view or something. So to put simply, they take individual parts of the page and organize them into a page. React is extremely well suited for this because you can actually pass in components as props, and then the React component can just return markup. This is great, especially in React 14. Your layout functions can be pure functions. They just map components to markup. Context is extremely important here. So now let's consider components. It's important not to reinvent the wheel every time you write a component, especially at a large scale, because as your team starts to grow, you can envision that some teammates might be working on a feature, and that exact logic might be needed somewhere down the line, but people don't know that somebody's already written this. So it becomes important to maintain some sort of internal knowledge base where people can go to figure out if this kind of thing has already been written. So for example, if I wrote an image component, and this image component contains some commonly used logic where it won't load the image right away, it'll load the image when it scrolls into the viewport, saving some bandwidth. That sounds like a useful piece of code. I wanted to use it in an article page for the inline images. Well, this is great, but what if somebody else wants to write a gallery? This sounds like a great idea for a gallery as well. The same logic could be applied here. But we don't want them to rewrite it, because then now you have 2 components, 2 image components that you're loading. So what we do is we have good guidelines on how to create reusable, composable components. React kind of already, just by its nature, enforces composability. But if you take care in the API that you expose to other users and how to use your components, you can really make them truly reusable across any number of contexts. Data fetching in Flexible is actually quite simple. Actions are the only parts of your application that's allowed to be asynchronous and fetch data. They have access to this library called Fetcher. And Fetcher has access to all of your REST APIs. Once your REST API returns, Fetcher transparently returns the data down to your action. And the cool thing about Fetcher is that it works isomorphically on the server and client, and so you can write the same exact code and have the same exact data returned to you on the server and client. So once you get the data back, once you get the data back, you can follow through with your Flux flow, and the rest of your actions can also talk to Fetcher. This is well and good, but what about the first time you render an application? How do you get the data that you need for the first render? Well, if you look at the view gets its data from the store, but the store gets its data from the action. So somehow the action needs to know what view it is going to render. This looks like it's easily solvable, because when you're on the home page needs a certain amount of data. When you're on the next page, whatever page that you've defined, it needs to render a certain component. And it's easy enough to assume that that component has a certain data that you know about. But when you're dealing with an application that is huge and that has a lot of nested components, it's hard to reason about what data could be needed when you're trying to run this application. So it becomes a problem to determine the data that you need at runtime. So actually, one solution to this is Relay. Relay kind of solves this in the same exact way that we do. But Relay solves this by attaching statically onto every component some GraphQL query. That gets extremely complicated, and I don't want to talk about it. But all we do is we declare an action statically on the view. And we've already talked about the actions being able to access the fetcher and fetch whatever, any kind of data they need. It's just a pure function. So when you declare statically an action on every view, you're able to access these views, access these actions without actually rendering. You can run these actions before you ever have the need to render, populate your stores, so when it comes time to rendering, you can have all your data ready. We can see an example here. If a user is trying to navigate to an article page will map to an article view. And the article view will have its own initial action. So the navigate action will go to the article action, and then we'll fetch the data that we need. It'll come back to the navigate action, and the navigate action will continue through the Flux flow and render out the component. So next, let's go back 1 second. So here you can see that the view and the action are actually tightly coupled right there. It's also easy to imagine how this, in addition to the view and the action, the data service and the store could also be coupled to the article view. So we came up with a concept called bundles, which are the actual individual modules that are shared between teams. A bundle could be a component, but it could also be a store, an action creator, service, or CSS that this component needs to render. So we allow users to package these up as they would and publish them to an internal NPM registry. And this really allows maximum reusability, because now you have other users, they can just install it, require it, and see if that component solves their problem. If not, they can just get rid of it. But yeah, facilitate maximum reuse, bundles. So once you have these bundles, it's time for sending them down to the server. So in the old world, in an old single-page application, you have all of your bundles or assets. User comes to your page, he wants the bundles, he gets all of bundles. But we can do better than that. With smart asset loading, if a user comes to your home page, you show them just the home page. If a user then exhibits some action, like a scroll, you can then load, say that's the comments bundle. You can render the comments at the bottom of the page. And then if the user tries to navigate away to a different page, you can load the assets that you need later rather than now. So if we go back to the question of serving the minimal set of resources for the best user experience, have we achieved that? Well, with flexible layouts, reusable components, statically declared data, and smart bundle loading, we have all of the resources we need. But I don't know if we achieved the best user experience, but we have definitely achieved a better user experience. This will lead to faster page loads, smaller K-weight, and fewer requests made by the app. So what's next? Well, we're not quite done yet. These next few topics that I'm going to talk about are the challenges that we're facing right now, and these solutions aren't fully vetted, and if you guys have seen these problems before, please come talk to me. Time to first byte flush. If you guys aren't familiar, this is how long it takes from the time you get the request to the time you respond with something to the user. So typically, with a React app, this is probably what you do. You get the request, you route it to the proper assets, you get the data that you need, you render your components, and you send it down. But actually, you don't have to wait this long. You can flush as early as needed. You can flush all of your assets down so that the browser starts to parse all the JavaScript files as early as possible while you're still rendering your React components. This definitely provides a performance boost. What's even better than this is actually to flush more often. But this is harder to do because with our current architecture, and with most architectures I've seen, there is one single giant React component at the top, and React rendered string is a synchronous method. What that means is you have to actually wait until this whole thing completes before you can flush down anything. But what is ideal is to flush down markup as it becomes ready. So one thing we're considering doing is to have multiple trees that we can render. So the next is a concept called progressive rendering. And with progressive rendering, we're able to decide dynamically whether we want to render and serve data on the client or the server. So if you're familiar with the concept of above fold and below fold, everything in your viewport when you go to a website is above fold. And those things we definitely want to fetch the data and render server side. But again, going back to a comments module at the bottom of the page, you don't need to render it client side. You don't need to render it server side, so you can send it to the client and defer rendering it and save that XHR. So some few problems that we're facing right now, bad parts of React and Flux. Checksum issues. Any small error will throw away all your markup, and that's kind of just bad. So our solution that we're trying out right now is to have multiple React render trees so that if one part of the markup in one render tree fails, the rest of your markup gets reused. Other is iframes. If you ever try to re-render an iframe, it actually just reloads the whole thing because you can't diff the DOM inside of an iframe. So that's another issue that we're facing right now. It's not easy to solve with React's virtual DOM, unfortunately. But if you have any ideas about these kind of problems, come talk to me. I have some flexible shirts to give out, so feel free to come grab them.
Awesome. Great. Cool. We have still a couple of minutes, so we can go through the questions.
OK. So why flexible over Redux? Wow. So we just actually released this thing called the Reducer Store add-on, which lets you use Flexible as a giant reducer store and add reducers to it. So they're not necessarily mutually exclusive, but it's Redux leaves a lot up for interpretation outside of the reducers, because how you, like I was talking about, the layout, all that logic can be extremely complicated to handle outside of Redux. But we're experimenting with it. The Reducer Store add-on is something we want to try to see how the performance plays out. Right now, we have a lot of stores that, that a lot of different teams made, and so it's hard to ask them all to be like, hey guys, this new framework came out, can we all switch? So I hope I answered that one. Private NPM. What's been our experience using private NPM? It's not NPM Enterprise. We actually run our own NPM. It's called YNPM. We try to put a Y in front of everything internally. But we have a guy, he maintains YNPM. It works the same. We just have YNPM command line. I think it's a wrapper around the actual NPM. But it's been extremely useful for us because when you're able to not have to go to another repo to like clone it or anything to share code, you can just install it. That helps especially in release pipelines because you're able to install the latest versions instead of copying other people's code internally. Do I consider using React Server Renderer for initial page load? Yes. Yeah, that's one of the reasons we do it is because the initial page load will be much faster if rendered on the server instead of letting the client do all of that logic, especially because of the data. Because on the server, we're able to do all of the data fetching. So if our page has like 5 different modules developed by 5 different teams, that's 5 different backends that we need to talk to. We can do all of that very fast on the server because they're co-located in our databases. But on the client, if you had to do XHRs to all 5 of them, it's very slow. How are stores initiated when calling statically linked action of a view? This is interesting. We actually are able to statically, when I mentioned bundles, when you npm install a bundle, it comes with stores. And those stores are all like, we statically crawl our app, and we know how many stores there are. So when an action needs to dispatch some data, so these statically linked actions, once it gets the data, they dispatch it to the dispatcher. And the dispatcher, based on what the actual action string is dispatching, it's able to recognize what stores need to be instantiated. Because we've already parsed all of the stores and know what all the handlers that the stores are listening for, what are all the actions that they need. So we only instantiate the stores that are needed. We don't instantiate all of the stores. Can you have cycles in a tree representing actions? I'm not sure what that means.
No worries. I think we're out of the questions with the proper amounts of likes. So Rajiv, thank you so much for your time and for presenting this. Guys, I know you're all tired today. We have one more talk to go through, and then a series of lightning talks. The lightning talks are supposed to be fast, and I will make them fast, and we'll go snap, 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 so no worries. We're going to be on the right track, on the right time, as during the whole day. So please welcome Tomasz Kulich on stage. He is out of Vacuum Labs, one of the organizing company, actually. So hopefully it's going to be a good presentation. Tomasz, not to build you up too much, right? Yeah. Give it up for Tomasz. And we're missing a device, or not? No. Yes, we have it. Fantastic. We're all set? Yes, good. Nice. Go for it, Tomasz.
Where's the mic? I prefer this one, maybe. Awesome. Perfect. So thank you very much for coming. It's been a long day, so hope you have energy for just one more talk. So let's do it. Okay. Recently, I had an interesting conversation with a friend of mine. He asked me what we do at Vacuum Labs, so I tried to explain to him that we do mostly web development and mobile development, which surprised him. He was like, and isn't it all too easy? Is this challenging for you to do web applications? So I tried to explain to him that web development, if done right, can be rather tricky and challenging thing to do. But obviously I failed to persuade him because he went on like, okay, so you got some user screen, user clicks something, You fetch the data from the server, you display the data, you provide user with a new screen, some time passes, user clicks something else, you fetch some new data, display it, and so on, and so on, and so on. Where is the glory in that? And this is tricky because this actually sort of proves my point that web development is hard, because even in this very, very, very simplified idea of how web application might work, there is already a design flaw, or at least design could be done better thing. The issue is how we treat data. We get data from the server, we display it on client screen, and that's it. From that moment, the data start becoming stale. And as time advances, the data become even more and more stale. So finally, we end up displaying something completely maybe irrelevant to our user, which is not good. Now, we see many solutions to this problem around us. Many projects just tend to ignore this thing whatsoever. Okay, so users refresh the web page, whatever. Facebook solves this interestingly. They simply refreshes several parts of their web page. And this is done in a really ad hoc way. So when you are looking at Facebook, everything on the screen has different staleness, basically. GitHub is doing especially bad job about this. I don't know how about you. For me, it always happens that I see the GitHub, oh, there are 5 pull requests waiting for me. Yeah, it's going to be a long evening. I click on the pull request tab, and suddenly there is none of them. What happened? Okay, so I guess I have a free evening after all. Good. So the solutions we see around us are not perfect. What would we like to see? We would like to get, this would be the holy grail if we can just achieve this. We would like to display always fresh data, as fresh as they are in our databases. And we would like to do only a little extra work to make this happen. Because usually we cannot afford to invest much in this. I'd like to show you one solution which aims for this space. It's called Firebase. It's a database solution. It's database as a service. It runs in cloud. But first, one disclaimer. As Rich Hickey said, not everything is awesome, and Firebase is definitely one of those things. It's by no means awesome. But it has some really interesting properties, and it can be a real blessing for your project, if it's the right type of project. So choose wisely. Few attributes of a Firebase. As I said, it's database as a service. It runs in cloud, and your client queries directly the Firebase server. It completely bypasses your server, which is a really interesting thing. I'll get to this later. Its data model, it's a little bit NoSQL-ish. It's one big JSON document, or one big nested recursive map. This is example of write API, how you put data in the Firebase. So in this case, I query for a specific location in the Firebase. So it's event/123/city. I get so-called Firebase reference, and I can set this reference to whatever I want. So in this case, it's Bratislava. You can do this directly from browser. There is no server code needed to do this. And this is the read API. This is the killer feature of Firebase, how you read data from it. So once again, you navigate to one specific location, and then you subscribe to some events which are affecting this location. So in this case, I'm subscribing to value event, which means whenever the data in the subdocument rooted here changes, this callback is executed for me, with the proper value being the value of the subdocument below me. So with Firebase, you don't query for data, you subscribe for data. You create subscriptions. Now, let me show you how this concept can be used in building real web apps. So first, I show you what we got. Yeah, this is an example from wordy.com. We are currently building a new version of the website. I don't know if you know wordy.com startup. It provides correcting grammars of your documents by human editors. So you submit some documents, and they come back polished and shiny. One of the core features is that you can select your editor team. So here I have 4 guys in my editor team. It's all work in progress. This is really raw version of the application. There is no fancy graphics right now. But what I want to show you is already there. So let me show you what happens if I try to add some new editors to the team. Now, check out how the screen in between, the background screen reacts to whatever I do to the overlay. I remove editor from overlay is also removed from the background screen. Yeah, it's nice. This has nothing to do with Firebase yet. This is just that React is awesome. Okay, so now for some serious stuff. I opened the second browser. So I have now 2 completely separated Chromium instances. It's actually the similar demonstration how Viktor Krishenko was giving a few minutes ago. So I have 2 completely separated Chromium instances. I'm just logged in as the same person, and I'm looking at the same page, basically. Here is the overview, the overlay, and here is the editor's team summary. So it looks a little bit different. Now, let me show you how these 2 things synchronizes. Okay, so whatever I do in the left appears immediately on the right, and vice versa. Did you get it, or should I? Okay, so the message is clear, yeah? Perfect. I prepare a video because I have the feeling that the Wi-Fi might not be as good as I would like. Okay, so how can you build such an application with Firebase? I will show you one problem we had to solve, and I will show you how we do it. The thing is subscription management. Imagine this very simple app. There is a listing of events I want to attend on the left, and then there is some event details on the right. Now, what the application has to do. When I click on the left, item number 4, I have to make a subscription to Firebase, to subscribe to correct source of the data. And when this data arrives, I must display this data in the right panel. Now, if this data changes, I have to refresh the right panel. Now, if user clicks third event, I have to destroy the old subscription and create new one for another piece of data from the Firebase. Now, the question is, who should do this? Who should create and destroy subscription? Where in standard React Flux architecture should such code be placed? Where should it be written? So we were thinking about this for some time, and yeah, so there is this key observation that subscription to Firebase, they have some lifecycle events. They are created, then they last for some time, and then they are destroyed. And it's not only that creation and destruction of the subscription, their times seems to coincide with the times of mounting and unmounting some document, some element. So we came up with this solution. We created a React element with no visual representation, just for managing the subscription with Firebase for us. And then we use React to take care of everything else. So I now go a little bit technical. I show you the actual code, how this is done. So this is listen event details listener component. It's pretty valid React component. It starts with a big letter, everything is okay, yeah? it's created by listen Firebase function call. This takes 2 arguments. The first argument is, what do I want to listen to? So this is a function that takes some properties, and it constructs Firebase reference to which I want to listen to. In this case, it's event/props ID. The second argument tells, what do I want to do with the data once I get it? So in this case, I want to dispatch this data as a payload of some action, such that the data can be put to the application state. So once I have this React component, I can use it like this. This is some hypothetical, very simplified version of render method of the right panel. So first what I do, I render this listen event details component with the proper ID. Then I check whether the event data is already there, because if I first come to the application, the synchronization with Firebase, it takes some time naturally, it's networking. So in the first render, the data will probably not be there. So in case the event is null, I just display loading message. However, if I have the data, I display the proper representation of the right panel with all the data there should be. So once again, what will happen as time goes when user first comes to this site? So on the first render, the listen event details component is rendered, which has no visual effect, just the connection to the Firebase is created. And then since event is probably null on the first render, the loading message is displayed. Now, since I created subscription to some specific Firebase location, after a few whiles, the data arrives. The data got dispatched, as we saw already. The application state is changed, and the whole thing gets re-rendered. So the render is called second time. This time, I leave the listen event details listener intact. It stays as it is, but now I have the event data. So instead of rendering loading message, I render full representation of the right panel as it should be. Okay, so once again, the Wordy application. Now in the right browser, I open this Firebase Live editor. You can inspect and edit your data. This comes with Firebase. Now, down here, as you can see, there are some info about my account. So as you can see right now, I'm admin. I'm administrator. Which means I can go here and visit /admin URL. And what I got here is administrator page. I can change other people's accounts here. Now, what will happen if I change my role from admin to just plain user? Boom, suddenly this. There was no reload. It all happened automatically. And I just got this message that my permissions are not good enough for administrating the page. Okay, but I still can access dashboard and use the app as a normal user until I block my account. So now it's blocked. And yeah, once again, no refresh here. And now I cannot do literally anything with the app, which is kind of boring. So I unblock my account once again, which means I can use it as a normal user. And now I visit /admin page. Okay, I still don't have permissions. Cool, in my opinion. I don't think it's Firebase fault, actually. I don't know any solution that would solve all of these things at once. So several issues I would expect from Holy Grail database. The first thing is that with Firebase, your client talks directly to the database, which is cool. It's cool because you don't have to write a lot of read endpoints like this. I don't know how about you. I don't like writing these. Guys from GraphQL obviously also don't like writing these. The thing is, REST endpoints just for reading. data. You have to write them, you have to maintain them, quite often in different versions of your API. Still, they add quite small value to your project. They don't do anything useful with the data. Usually they just grab the data from the Firebase, serialize it, and send it through the wire. There is not much value added. And in ideal universe, in ideal world, not in this one, we could get rid of basically all our read API just by providing general SQL handler API. This works really simple. You just provide this /SQL URL. Any client can submit any query they want. You just execute the query completely blindly, whatever it is, and send back the result. There is one API which is sufficient for all your app. Great, isn't it? Of course it's not, because this can happen. So, yeah, this is no go for us. And sadly, there cannot be much done about this with SQL. It's very hard to introspect the query, to analyze it, and to see what the clients are really trying to do when they submit such query. Firebase has this validation mechanism. Well, Firebase has to address this somehow, yeah, because client talks directly to the Firebase with no server involved. So what they do is this: they created validation rules. Each validation rule guards some specific location in the Firebase. So in this case, we are guarding location user / some ID. And the guarding function is basically some snippet in some subset of JavaScript that takes 3 arguments: who is trying to do, what is he trying to do, and what's the actual state of the DB. So depending on these 3 things, you may say whether the action is correct or not, whether you should allow it or not. And it's an interesting validation mechanism, but it's, in these cases such as this, is not enough. In this case, I have 3 event objects and 2 users objects. And I link them together with some string IDs. So here, John has ID 4, and that means he's owner of those 2 events. Now, what I do is I separated John data to different subdocuments in my Firebase, which makes it pretty hard to validate. It's pretty hard to do validation rules right in such a case. Actually, if I was such that only John can edit his data, it's not even possible to write a validation rule for this case without tweaking the database schema, at least for a little bit. So that's sad. So this is what we got with SQL. Our query validating capabilities are pretty much non-existent. With Firebase, it's so-so. I'm not sure who's the winner here and whether we know it yet. Maybe something like GraphQL / Falcor. We'll see. Okay, so this is the big issue number 1. This is big issue number 2. How do you do updates to your database? With Firebase, it's really, really simple and straightforward. You just, as I said before, you just take the reference and set it to whatever you want it to be. And yeah, that works somehow, but if you want something more complicated like transactions, you just, nope. There are some things in Firebase which you can use, but none of them has really transactional kind of capabilities. So what we did about this, we created our own Firebase extension. It's called Firebase Transactions. You can find it open source on GitHub. How this works: you run the thing on your server, it starts monitoring the Firebase, and transactionally applies whatever is needed to be applied. From the client perspective, if John wants pay Emily $10, then instead of directly manipulating the database, he submits the action. Action is object, such as this one. So John submits the object saying, I want to pay from John to Emily $10. It's sort of Flux inspired. Yeah? Instead of doing the change directly, you just push some descriptor there and let someone else to do the job. So John submits such object to the Firebase. It gets spotted by Firebase transactions. The system applies the transaction in a transactional manner with all the acid goodness you might want, and the results are then broadcasted back to John. This is quite nice project in my opinion. I'm loving it. The one thing, however, with the old Firebase approach, that there was one good thing about it. Whatever you do, you got the response immediately. The Firebase client optimistically applies the change for you, and you are notified about it immediately in the same event loop as you did the change. With Firebase transactions, you have to wait a little bit until the transaction is spotted, executed, and you get the result back. So what we would need is somehow we would need optimistically update the client state based on the transactions he's trying to do. And there is the last thing, and the biggest one. I'm not sure if one big JSON document is really the cool thing we want to store our data into. There are several problems to it. The one was validations. Automatically, when you have to link different parts of the Firebase document with some string-generated ID, you are losing something. You can't do validations right. And since we have really, really simple data model and really, really simple and limited query language, we cannot even fetch all the data we need for a certain view in one query. We have to do multiple queries in multiple batches. So there are multiple round trips to server necessary just to get the data for one view. So those are the limitations of the system. And for what I really like is data model of Datomic. You may have heard about it before, even today. It's a database solution developed by Cognitect company. Sadly, it's closed source. And it has a really interesting data model and really simple. It just consists of entities. In this case, we have user entity and event entity. Each entity can have some primitive attributes, such as string name of user, and then there are references between those entities. So in this case, user attends multiple events. Those references are a building concept in Datomic. There is no explicit string key by which I would match user to event. And this is really cool. This is how you do queries in Datomic. All these keywords in the middle are names of a certain references I have in the system. So in this case, I'm querying, give me all names, name which belongs to a person who attends some event that serves certain food, which contains some ingredient with name chocolate. Yeah? So basically, give me all names of all chocolate eaters here. And that's a rather powerful query language Datomic has. So there is a lot of goodness in the system. Not only that, as you also heard today, that Datomic has also Datomic-like in-browser implementation. It's called DataScript. So yeah, so it's great. So why don't use Datomic plus DataScript right now for our web apps? And there is a problem. It's that the Datomic query language has poor reversibility. Now, what do I mean by that? Imagine what happens inside the head of production Firebase. There are 1,000 subscriptions from multiple clients. You have 1,000 subscriptions, and now a single change comes to the database. What Firebase must do is really quickly determine which subscriptions are affected by this change and how. And by really quickly, I mean really, really quickly. Firebase cannot afford even a linear scan through all these subscriptions. And luckily for Firebase guys, their query language is so simple that it is possible to achieve really, really quickly. I just have a quick quiz for you. Given this change in the blue rectangle, which of these 4 subscriptions we have here are affected by this change? Yeah, exactly. Second and 4. It's really no-brainer, yeah? The first and third subscription are subscribed to something completely different. The second and fourth probably will be affected by such a change. So this is a really easy thing to do. However, with this query, if I ask you what will happen to the result of this query if some new food is served somewhere, or some food gets some new ingredient, it's much more complicated to analyze. And this is just some subset of what the atomic query language can do. We are not using aggregation or negation and logical expressions here and so on. Yeah, so this is complicated. So yeah, this is rather inconclusive summary. I think that reactivity is a great feature, and I really love it, especially when we can do it cheap. And I believe we can do it cheap if we only have the right tools for it. However, developing these tools seems to be extremely hard job. And it's because there are several subproblems which must be solved at once. It's really hard to separate these things and solve this in isolation. All Firebase, GraphQL, Relay, Falcor, Datomic, Dato, all these solutions solve some part of this problem, but none of these solutions solves all at once, and we need all at once. So I think there is a great change, great opportunity in front of us, and let's get to work and let's do it. Thank you.
Awesome. Thank you, Tomasz. Let's have a look at Slido if we have some questions. Fantastic. Do we have some spare time yet so we can go through them?
Oh, so the cloud thing. I see. Do you worry? No, I don't actually. It's hosted in Google servers. I'm already quite dependent on Google. Probably I will die if Google just shut down. So yeah. But yeah, to be completely honest, Firebase is quite simple. I mean, if I get really pissed off by Google, I believe I could do my own version of Firebase doing some. I don't even need half of the features there are. We actually even had a project that was aiming for the same thing as Firebase. It was called Clean Sync. We just get tired of maintaining the thing, so we switched to something which is maintained for us. So no, I'm not afraid. Yeah, how is it different from using WebSockets with Redis pops up across however company? Okay, this is actually like one layer above this stuff. Firebase is also based on WebSockets. It's just you have like real database with more power about your resources. Or I don't know exactly what guarantees Redis gives you, but I think this has more power in it. There is, for example, quite nice offline support. I'm not sure about this solution. If you do some changes to your local Firebase client, even if no connectivity, when the connectivity is regained again, all those changes you did while in offline are propagated to the server, and yeah. So there is a lot of stuff which Firebase does for you, and yeah, I don't like reinventing the wheel. Whether we do store all our data on Firebase? Yes, we do for certain projects. Once you start using Firebase, for us there is no reason not to use it. It's quick, it's powerful, so why not? I can imagine that for certain project, it may have some benefit to split your data between some server part and then some part which you, like creating some client view that would be just for displaying the data to the client, and that could be Firebase. And apart from that, you can have some standard relational database, say. But we are not doing it right now. Meteor's React integration. No. I don't know how this works. I know Meteor a little. I know they are doing, they sync Mongo database to your client based on querying a block. But yeah, I think Meteor is doing quite similar thing than compared to what Firebase is doing. Also, the set of guarantees you get/don't get looks pretty much same to me. What I like about Firebase is that it's much more lightweight compared to Meteor. Firebase is just a database with a decent client library. It is not opinionated about how you should do other stuff. From my point of view, Meteor does too much thing at once. Yeah, so how does it work on poor connection or offline? As I said, usually you are not even aware that you are offline. You can click to the Firebase, the client behaves as if it was online. All the changes you do are properly, all the callbacks are there. If you subscribe to name of some event and then you change it while offline, you still get the callback. So everything works as it should, but there is no connectivity. You lose changes from other people from outside of the world. But it's really cool that someone wrote such a client. Yeah, you don't have to do it. When you are doing your app, you can just focus on your whatever brings value to your product. You don't have to redo the thinking part.
So let's do 2 more questions.
Yep. As a service owned by Google, is it open source or is there a way to run it locally? No, sadly no. I would really love to see a project that would allow this. So if anyone is in the mood for some hacking, I'm totally in. Let's create this. And let's create the open source. And yeah, I think we already compared it to, so what do we have here? How do we write our tests? Well, we have some tests which, sorry, what? We have some tests which can be run without Firebase. That's easy. That's the part when you just update the upstate with some data and see whether the action was really applied how you want it. And yeah, I have written some tests which can run only online. So I have this testing Firebase. I won't show it now. I'll show it to you if you are interested later. I simply have some production Firebase, and yeah, most of the time I have my internet connection, so it's not a problem. Even tools such as CircleCI, you can connect from CircleCI to Firebase, and the tests are running with existing Firebase instance, so it's not a problem. Everything is online today, so this works great. Okay, so I think that's it. Thank you very much for the attention. I will love to discuss these things with you, so.
Thank you so much. Thank you, appreciate it. So we saw a lot of questions here. Cool. So now all the long presentations are finished. What we have left is something that we call lightning talks. And we put out the official call in the beginning of October, or or mid-September actually, to submit proposals for presentations and for talks. And a lot of you, or a lot of the other people also applied to get in. And now you're going to see the top 10 most rated talks but you wanted to actually see here. So we're going to have 10, actually 10 plus 1, because we have one at the very end that we added just today. You're going to see later why, into the lightning talk sessions. So the rules are very simple. Aussie, please go and prepare yourself, as you're number 1 in my fantastic list. Rules are very simple. You're going to have 5 minutes to talk, and that's it, right? So it's very simple, as I mentioned. And like 1 or 2 minutes to switch between slides, and it's going to be a lovely 50-something minutes of this hour. So you're looking for a cable, yeah. It's a good start every 5 minutes, yeah. So please give a round of applause to Aussie and to his first presentation. Thank you.
Great. Hello, everyone. I'm Ossi Hanhinen. So 2 things about myself. I can do this. And I've been coding Elm for production for past half a year, and I've never actually used React. But thanks for voting for me for this React conference. So my talk is titled Joy of Composition, Why Stateless Rendering is Pure Bliss. Now, meet Joy. She's a front-end developer like you and me, and she has this great new idea. She's going to build GitHub and decides to use React for it. So she just starts hacking away, and in the beginning she's very content. The code is very elegant, very simple and readable. But as time goes on, she adds a little event handling logic there and a little lifecycle code over there, and she soon finds herself in this never-ending swamp of JSX. And she's struggling to know where the components start and where they end, and what they depend on. But what's worse, she doesn't know where the state lives anymore. So she takes a little breather, a moment of zen. She tries to figure out what went wrong from the very beginning. Now here's HTML for you. The structure here depicts a very simple menu, as you can see, but already we can see the problem. There's a very deep nesting, even in this very trivial example. So, well, deep nesting is bad because it obviously makes your code less readable. But there's other problems as well. We are used to binding the data and the structure of the page, which basically means the UI, together up to the point where we are actually repeating ourselves. Now, there's a lot of ways to solve some of these problems, like Angular repeats and mustache template repeats and stuff like that. But also there's the functional ways of doing that, like the array map function. So Joy decides to take a look at the UI from another point of view. She figures, if I only had this solid block of data that's read-only, I could just pass it down to a function that takes it and returns the corresponding HTML. And doing so, she could just delegate stuff from there. She could have a render header that takes stuff regarding the header, and maybe just render menu, menu item, or even just the item link. So since the data was read-only, none of the functions could actually alter that data state. So that means there's no weird state ever. Render is essentially a pure function from the state to HTML now. So this also brings composability. So Joy can start working on the prototype using just the render app function. But as time goes on, she can split it to rendering the main panel and the side panel. But she can also split those up any number of times. And it doesn't matter. It's just functions. She can also combine functional utilities like Lodash or whatever to do the rendering. And she doesn't have to worry about the whole UI at the same time. So she can focus on the component. Now here's a quote from a friend of mine who's sitting right there and going to present tomorrow. Most UI code should look small. It's actually a code smell if you have JSX with lots of nesting. So Joy comes to this conclusion. If you're working on a drop-down menu, you shouldn't actually be thinking about how to render a single item in that menu. So left with these pure thoughts, she's found Zen. And for her next project, she decides to go all functional and maybe go for CycleJS and HyperScript helpers instead. HyperScript helpers is actually a project of my own. It makes writing VDOM basically simple functions. And of course, you could go all the way and use Elm or ClojureScript instead. So that's it. I'm Ohanhi on Twitter and GitHub. Please feel free to poke me, real life or virtually, if you have any questions or comments. Thanks.
Fantastic. Thank you very much. Cool. Right on time. That's the way I love it. Next up, please, I would love Thomas Parslow to come up and to present. Oh yeah, Thomas is coming. Great. The name of his talk is called Pyramids Be Gone. And I'm interested in what he's going to talk about. So come on up. Time is ticking. Tick tock, tick tock. Just like Madonna, right? Yeah. The cable is on the floor. Here you go. And next up is going to be Yavi Velasco. I'm butchering the name. I'm sorry for that. Right here. Okay, cool. You're prepared. Is everything working, dear technician people? Yes, fantastic. Here is your microphone, and your 5 minutes start right now.
Hi, yeah, I'm Tom Parslow. I'll tell you about new syntax coming in JavaScript soonish, probably in ES7. Oh, up here. Okay, sorry. So first, a bit of JavaScript. We're loading something, probably from a file like through a web request or something. We're then taking the result of that, loading something else. We're then taking the result of that, loading something else. That's all nice and simple and straightforward. But the problem is we can't write that because those are asynchronous operations, and this would only work with synchronous stuff. So this is synchronous code. So what do? We transform it into a callback version. That's doing the same, logically that's the same thing, except now it's asynchronous, and it's just got a lot of extra noise. We have to pass errors back up manually, that kind of stuff. And we've got an inverted pyramid. Oh no, lots of indentation. So yeah, we might replace that with some promises-based code. And that, I think, is a little better. It's not always, it's got problems, but yeah, we get rid of some of that indentation. We don't need to manually handle the error at every single step. But there's still a fair amount of sort of extra stuff going on there. Yeah, when things are complicated, things break. And I just wanted to put that GIF in. I really like that GIF. So, coming back to the original codes, it's nice. I mean, wouldn't it be nicer if we could just write that? And with the new async await syntax coming, we pretty much can. So you can add a few extra keywords. The async keyword says that this is going to be an asynchronous function, so it's going to not return immediately. It's going to return but it's going to have sort of asynchronous stuff within it. And then inside of each of those, in front of each of those asynchronous calls, we put an await keyword. And this is all working with the same semantics as promises. In fact, it all is promises underneath, and it interrupts with promises. So these load JSON functions, they could be async functions written like this, but they could also just be promise functions. And likewise, this function here that we're creating, this first chapter title, this is now returning a promise. So we can use it from other code that doesn't need to be using that. The other code that can be just using regular promise stuff. We could also use it from another async function. And for error handling. So error handling is going to go into a promise fail state. But if we want to capture errors, we can do that just using the try-catch thing, just like we would with an exception in synchronous code. And likewise, if we want to return an error, so if we want to make the promise that this function returns be in the error state, then we can just throw an error, and that becomes the error, and that becomes an error stated promise. So browser support. There isn't any yet. But, you know, hopefully soon. It's in the ECMAScript spec, in the ECMAScript spec process. They're hoping it's going to get in there soon, and it will get into browsers at some point, maybe, hopefully. But until then, we have Babel. So I guess a lot of you have been doing that for lots of other ES6 features at the moment. It also supports async await. So you could, if you're using Babel, or if you are willing to use Babel right now, you can start using async await right away. So thanks for listening.
Great, nice, thank you. Thank you very much. So it's Javi or Javi or? Javi, I'm so sorry. It's Javi Velasco. Now I get it, okay, I was confused. Javi Velasco with the React Toolbox. So can we change the slides? Is it good? Okay, let's go for it. Yes, you can go for the preview thingy. Cargando. Nice slides, I like them. Yeah. Okay. Cool.
Right.
So your 5 minutes are up. Go for it.
Okay, thank you. So my name is Javi Velasco, and I work for a company called Cerebral. I'm Spanish. I'm from Córdoba, a little town in the south of Spain. And I've been building these days a little tool which I call React Toolbox. I'm making that with a friend. You can go to the projects page and check what we've done so far. And what is it? It's a library of components, React components, implementing material design guidelines. So you probably know there is already a project which is doing more or less the same, but they have some things that I don't especially like, and it's not quite compatible with what we wanted to do. So first of all, I don't like inline styling. By the way, I loved the talk by Mark. I don't know if you were there before, but we are facing more or less the same problems. So I wanted to create something different from that, and also create a proof of concept for CSS modules. So there's another things that I wanted to do, like generating more semantic markup for our components. And also, we are creating this because people love material design, and I wanted to open source components, because so far I never contribute too much. I never give too much to the community. We wanted to start with it. So the proposal includes CSS modules and an integration with Webpack, which is pretty well known, and I'm sure that all of you are using in your current workflows. So as we are using Webpack, we can also include Sass Loader, so we can have better style sheets. And we faced also the problem with the customization thing. We created something similar to what Mark referred this morning, which is customized, a little toolbox loader. It's just like 10 lines of JavaScript. that allows you to give to the library a little style sheet. Well, it's not quite a style sheet, but a file with SAS variables overriding the things that you want to change for the final build. So we have a component structure that is composed by a configuration file with SAS configuration variables, and a style sheet, the component JavaScript source, and also we have the README in the same file, assets, and maybe subcomponents in case the component is quite complicated. So for now, your feedback is quite important because the components are not being used yet in a big project. There are some things that I want to get the most possible feedback from it. For example, what happens if I don't want to use Webpack? Well, I don't know exactly how this can be integrated with another workflow, but I'm pretty sure that we can find a way. And also, I don't know if there is a better way to integrate dimmable components. And the stateless thing, everybody's going for stateless components nowadays, and we have some of them actually with a state and exposing some methods. I think that this is going to change soon, but it's important that you contribute and give your opinion on how can we build the best possible API for all of these components. And also the use case is so important because I don't know how can be actually integrated with Redux yet, but I am sure that it's going to move all these components to the stateless. For now, we released the first version just 24 hours ago, and we went from 34 stars to almost 500 just in 20 hours. I think it's a good number, so the community is embracing the library, I think, very happy. So this is the first version, and we want to build it with you. And we've created a little playground in the documentation side, so you can test the components and you can try how are they working. So I'm going to show you here a little bit of this playground. This is the home page. And here in the components page, we have a list of components over here. You have this installation page also, and you will have this little button here so you can try every component. For example, if you want to try the button, you can click here, you can see an example, click load in playground, and you can see here an editor which is dumping here the components so you can live reload them.
Beep,
So, finishing. So,
fantastic, thank you.
Just try that. Yeah, thank you.
Cool. So, next up, we have Ville Imonen. I'm probably not pronouncing this properly again, but rapid prototyping with Relay, so at least I can pronounce that correctly. So, do we have Richard Feldman in the house? Yes, we have him. Okay, you're going to be next step. So, mentally prepare and embrace yourself for the lightning talk. Yes, even lightning talk speakers need for the 5 minutes water. It is very important. Let me know when you're ready. Okay, Mr. Technician, let's go for it. Here's your mic. And your 5 minutes start in 3, 2, 1, jump.
Okay, so I'm Ville Imonen. I'm from Reindex, and I'm going to talk about rapid prototyping with Relay, or more generally, just building products quickly and iterating them on them fast. So I'm going to talk about the stack of tools that I ended up for this, but first I'm going to tell a bit how I ended there. So this is how a stack for an app that I was working on a year ago looked like. As you can see, we were using React on the front end, which turns out to be very awesome for rapid iteration. Most of the design even was done directly on React components. We were using Flux, and then the front end used REST to talk with the back end. That was like a really state-of-art, built with microservices and all that stuff by a separate team. So building React components was fast, but working on this backend was not. So every time we had to build a new feature, it took a lot of time. And it was, since the backend was built by a separate team with different tools, there was also like a lot of communication overhead to communicate the requirements for the backend. So we replaced the backend with the backend as a service, Firebase, as that Thomas talked about earlier. And we also used another service called Algolia, which is like a search as a service. And this was very, very nice because it allowed the product people, like the product developers, to build everything for a single feature. And it allowed us to move faster. But once this bottleneck was removed, we noticed that there was another one in the middle, because writing all the Flux stores for different kinds of data and using REST APIs to synchronize it was not ideal. And as Thomas mentioned in the Firebase talk, there were multiple round trips required, and we had the same problem. And so a solution to the problem in the middle came from developers at Facebook. When early this year they started talking about Relay and GraphQL. And GraphQL is a query language and a type system that lets the server expose its capabilities, and then the client can query the server the data that it needs. And then Relay is a library for React that lets you describe these data needs in React components, and it will handle fetching it for you. But then the question was, what shall we use as backend? Because Firebase doesn't support GraphQL. So that's when I said that if someone doesn't build this, we're going to need to build this ourselves. So me and my co-founder quit doing client projects and built a GraphQL backend as a service called Reindex. And the way that it works is that it allows you to build fast, because I wanted something that's as easy to set up as Firebase, but it also should allow you to change things without breaking things. So once you move past like the first prototype, it should be possible to evolve the application without breaking stuff. And GraphQL can help with this because it has a schema that tells you if you're trying to get the field that doesn't exist or trying to put something in the database that's invalid. And this is how you use it. You just install a command line tool. You write a schema in this kind of JSON format, and then you just push it to the server, and the GraphQL API gets created for you. And then you can start making queries. Like this is a tool called Graphical, which is very nice. Like this is for all the events in Reactive conference. And there was a contest to build an app for Reactive conference. And actually one developer used this stack that I just told about to build an app. And this is done with React Native. This is pretty awesome. You can find the code for this in GitHub. And thank you.
Cool. That's impressive. Thank you so much. Nice. Okay. So next one up is Richard Feldman, and we're gonna help you out.
Thanks.
Here we go. And the name of the presentation is Elm Style Sheets. And we're getting into halfway through the lightning talks. So this is going to be the 5th one. So you're going to be 6 more to go through.
And 2 out of 5 have been from people who use Elm in production. The times are changing. All right. Let me get a timer started here. OK.
Go for it.
So this is Elm Style Sheets. I'm Richard Feldman. So I had no idea that I was going to be this well set up, but as it turns out, Mark's awesome talk earlier about CSS modules, at the end of it, he talked about the idea of, what if you had a CSS preprocessor where the language was JavaScript? You could just write JavaScript code and then have it output a CSS file. That's what this is, except Elm code instead of JavaScript. And we'll see why that's awesome in a second. This is just a proof of concept. This is not production ready, but it totally works. So here we have the beautiful Reactive 2015 website, except that I rewrote the header styles in Elm style sheets. So that's what this looks like. This is all just pure vanilla Elm code. I made a little DSL using the fact that you can write custom operators in Elm. So we have got header, nav, nav link is a class. So we got a little dot to indicate that it's a class. Got a pound sign for reactive logo, so that's an ID, and another ID for buy tickets. So one of the first things that you want with any good CSS preprocessors, you want the ability to use variables for code reuse. So let's look at this background color attribute here. So that's for this buy tickets button. We got this nice green on the background. I'm going to go ahead and pull that out and rename that to reactive green. Okay, and then I'm going to pull that up here and say reactive green equals. Okay, cool. And I'm actually going to use that to give these links the same color. So I'm going to go down to my nav link class and replace its color with reactive green. Recompile it. Elm compiler is super fast. Boom, green links. Cool, okay. Oh, thanks. That's encouraging because I haven't gotten to the cool stuff yet. Okay, so we did the bare minimum, but we could have done that in JavaScript. That's something that any CSS preprocessor can do. How about this? Let's do something that we can't see in JavaScript as a preprocessor. Let's change background color to background color and rerun that again. Naming error. Cannot find variable background color. It actually gives us a little red underline under the thing that's broken, a line number. Maybe you want one of the following, background color. So I didn't write this. This is just Elm's compiler. Elm's compiler is just this awesome, and when you write stuff in Elm, your life is this awesome. Which is why when we switched from React to Elm at no red ink in production, we basically just stopped getting runtime exceptions from our Elm code because the compiler is just really good at catching this stuff. And it would be awesome if we could get that in our style sheets as well. Another cool thing, so let's say I change padding from 12 pixels to LOL pixels. What is that going to do? Type mismatch. Padding LOL pixels. Function padding is expecting the first argument to be number, but it is a string. So again, it's not just making typos, it's also type mismatches. Again, this is just a thing that happens with the Elm compiler, and it's just the fact that I wrote this in Elm means that I get this for free. It's pretty awesome. It's kind of weird to me that I've heard a number of times at the conference people talking about Elm and the Elm architecture and how it's inspiring lots of cool tools, but from my perspective, the coolest part about Elm is the stuff that you can't get in JavaScript, namely the compiler that's just got your back and just saves you from all of these errors reaching your end users. One more thing. So at the end of Mark's awesome talk, Andre asked a question, which was, what about constant sharing? Which is a great question. Let's look at how that works in this land. So we've got over here a view. This is what's actually rendering this using Elm's little DSL for virtual DOM stuff. So it's the same kind of idea as React, except instead of JSX, it's just more pure Elm. Okay, so let's say I want to change reactive logo to just logo. So I change it to logo. I compile it, and it says, cannot find variable logo. Okay, cool. So it knew that in the view, logo was no longer a thing. And that's because we've got this, this constants file here, and I didn't update it over here. So we have all of our CSS IDs, and I forgot to update it. Okay, now I updated it in the constants file, so we're good, right? No, we're not. Because the style sheet is using that same constants file, and the compiler will tell you if you mess it up, and you don't keep them in sync. So now that little pound reactive logo definition knows about the fact that we didn't have that. So if I update that, now it will compile. I refresh the page, and now I look at this guy. We can see that it is now ID logo. And the style here is coming not from inline styles, but from our actual style sheet using that pound logo that was automatically generated. So using this, and this goes the other way too, by the way. So if I update it over here, but if I make it so that the view is trying to reference something that no longer exists in the other two, same issue. So they have to all be in sync. So what this means is that you can now live in a world where when you want to go and delete a CSS class or a CSS ID that you don't think you're using anymore, the compiler will actually tell you if you're using it somewhere. It'll give you an error if you deleted that and it's still being referenced somewhere. Awesome. That's something I've wanted in CSS for years, and this is a proof of concept that it can actually be done. If you have any other questions, I'm RT Feldman on Twitter, and come see me. Thanks.
Great, thank you very much. So next one up is Daniel Hale, out of Product Board. And he's going to talk about the advanced React.js performance. So we're going to plug it in and it's going to work. Is it good? It's great. Cool. Your 5 minutes start now.
Hey guys, so I want to talk to you today about performance. Why React and performance? Well, React is generally very fast, but depending on what type of app you are building, you might still hit its performance limits, especially if your DOM is very complex. If you are trying to fit into one frame into 16 milliseconds, or if you are supporting mobile browsers. And the problem I see is that there are not really many advanced articles explaining how the internals of React really works and how you can optimize your apps above the basic stuff like should component update or using immutable, what we've heard about a lot today. There are some very smart people on the internet building different benchmarks, trying to understand in which scenarios React is really fast and in which it's not that fast. One of them is Paul Lewis from Google. He built this benchmark where he tried to see how is the app fast based on how many DOM elements you are rendering. But then you have some other very smart people from the React core team saying that, okay, but this is not the use case we are really optimizing for. This is not we really care. So I was thinking, okay, so what does this all mean? What is React really optimized for, and how do we solve the other use cases? One really insightful post was by Ben Alpert, explaining that React right now is really optimized for initial page rendering and for creating abstractions without too much overhead. What it's not optimized so far is for rendering long lists of items. And the reason for this is that if you have long list of items, you can do something like pagination or infinite scroll, and it's not your problem anymore. But so how does this look like in real life? We are building this app where we are having this problem. We have a lot of rows. These are like features, and you can have 200 of them or 400 of them, and you have different visualizations saying, okay, how much this feature impacts different business metrics. So it's like this big dashboard. But the problem we have is that we cannot really infinite scroll it because we are not able to render the lines fast enough so you could get smooth scrolling. So we had to try to optimize this in a different way, try to look into the React source code and try to understand what are the other dirty tricks we can do to optimize our app. We are obviously using should component updates and immutable where it's possible, but that was not enough for us. So today I want to share 3 tricks that helped us to make it faster, even though we are not using infinite scrolling. First of them is trying to limit reconciliation as much as possible. There is one example I want to pinpoint here is that this is how our components looked at the beginning. This is simple, for example, like table component that's rendering a list of rows. But the problem here is this part, which is like a static HTML that gets re-rendered every time some of the children gets re-rendered. So it will get reconciled, and that costs you precious time. So you need to avoid this as much as possible. And one trick is you can make small, more granular components and do should component update there, so it will get skipped. But the other trick, what you can do is use Babel optimization called constant elements, which comes with Babel 5.18, I think, and React 14, which in compile phase takes your static HTML and puts it somewhere else, so it's not being evaluated every time and actually skips the reconciliation phase for you. So this was very helpful. Another trick is that today you've seen probably several times that it's a good design decision to try to take all the data you have in your state and send it through the component hierarchy through props. And one of the tricks we used is that we skipped this, and we are doing it instead down in the latest component, down in the tree, which helped us around like 20% improve the performance. And there's explanation for this, and that is even though if you have implemented should component update, the component tree still needs to be created, and it takes a lot of time and memory. And last trick is using just pure JavaScript, avoid React completely for things like animations. That's it. Thank you very much.
Great. Thank you so much. Cool. So next up we have number 7, and Tero Parvianian. Great, cool.
Nailed it.
That's a compliment, thank you. Try to plug it in if it works out.
Yeah, it should.
And the name of the presentation is The Game of Life in ClojureScript. Are we good? Yeah, we're good. Okay. Ready when you are.
Yeah, just a few seconds.
No worries. Okay, cool.
So hi, I'm Tero, and I'm going to do some ClojureScript programming for your entertainment, which is Game of Life. So I'll begin by defining the state of the application, which is an atom which holds the set of cells that is currently alive. And here is one such set. And then I'll define a UI for this, which is a React component called grid. And that renders an SVG element that has some sort of size, width and height, and it has a coordinate origin in the middle. So the 0 is at the middle of this thing. And then I'll render this to the screen by calling the render for the grid and putting it in the body of the current document. And there we see that. And then I'll actually put this live form itself into this grid by taking all the X and Y of the cells that are currently in the state and create a SVG rectangle for each one of those. And they also have some sort of width and height, as well as an X and a Y based on their coordinates. X and Y. And there we see the live form. And now we can actually talk about how to make it come alive. So this will be all about defining the next generation of this life form based on the previous generation. So we'll make a pure function called nextPopulation that takes a population and returns the next generation of it. And that's going to be based on the looking at the neighbors of the cells that are currently alive. So we need a little helper function called neighbors that actually takes a cell and returns the set of coordinates all around that cell in all directions. So we'll look at the deltas of x to the left, to the center, and to the right of the original, and do the same for the y coordinates. And we want to skip the case where both of the deltas are actually 0, because that's going to be the original cell. But for everything else, we come up with these new coordinates based on the x and y and the deltas. So that's a collection of cells around a given cell. And this we'll now use to make our new population. So we actually get all the neighbors of all the cells that are currently alive by mapping this function over the population. And then we'll count how many times each neighbor is in there by using the frequencies function. And then this is what we base our next population on. So we'll look at the cells and the counts that are currently in that neighbor count value. And we are interested in the ones that either are there 3 times or are there twice if they were also in the previous population. And this will be our new population, and we'll put that in a set as well. So if I got this right, I can apply this to our state now and come up with the next population. There we go. And we can make this happen automatically if we start a process of evolution. So we start a loop, an asynchronous loop, which waits for, say, 100 milliseconds, swaps the state to the next one, and then recurs. So it's an infinite asynchronous loop, or a process of evolution, which we can start from the REPL. There we go. And if we make our primordial soup a little bit more interesting, we can see how that works. Whoops. Stare. There we go. That's life in ClojureScript. Thank you. And if I still have some seconds, I'll mention what I used. So this is ClojureScript, the reagent wrapper for React, the figwheel auto reloader tool, the core async library for the asynchronous stuff, and the algorithm itself for this live implementation is by Christoph Grand, which he has online. Thank you.
Cool, that was very impressive. Thank you very much. Thank you, Theodore. So we're doing very good on our time. Next one up is Christopher Drow. Do we have Christopher in the house? Yes, we do. Wonderful. So the name of the presentation is React Native and Raspberry/Arduino. Can I help you in anything? Okay. Do we have some tape? Ah! Oh, or you can just leave it hanging. The LED? It was visible like 20 seconds ago. Yes, I want to hang it. Everybody should see it right now. No. I will stand here with it. Yes. I will be the assistant.
Perfect. So let's just hope that internet works.
And you need this one here?
Yeah. It's going to send this around.
I'm useful, you know. This is called being useful, yeah. Anytime you're ready, I'm ready.
Yeah, 1 second. Can we see the screen on the... There we go. I don't know what's happening with that. Okay. So yeah, I'd like to show you guys all a quick demo on how we can use React to interact with hardware. Holding here is an Arduino Uno board, and connected to it is an LED bulb connected to pin 13. And to save me some time and to give you guys all a little demo of Joshua's talk tomorrow on the React Native Playground, I'm going to go ahead and load up the app on the Playground. Just hoping the internet works here. There we go. So instead of running this through the simulator, I'm actually going to use the option to run on my device. We have an app available for Android and iOS, so if you guys have a chance to download it before tomorrow and take a peek, it'd be great. So I'm going to go ahead here and load the Playground app. And I'm going to go ahead and try to scan this code. There we go. And this should just load us a really simple switch that, if connection works, there we go. And hopefully the magic works. And it does not.
It's because of me, of course, yeah.
1 second.
It worked? Yeah.
So let's just make sure the board's ready. Okay, give that one more try.
So that wasn't it, okay, yeah.
Give it one more try. There we go. There we go. So we got that to blink. So I also have a demo for Android. Unfortunately, I can't project it on the screen, but maybe if I hold it up here, you guys can kind of visually see me scan the same QR code with Android. There we go. So it's fetching the JS bundle. And this should load another switch. Just going to take a little bit. The connection's kind of tricky. And there's an on and off switch. I'm going to hit that on right now. And there we go. We got it blinking again. So that takes care of mobile, but now we want to talk about how we can interact this with web. So it's a little bit too much to ask for people every time when they approach a device like this to enter the URL. So how many people here are familiar with Google's new beacon protocol, Eddystone? Anybody? One? Okay. So with Eddystone, it's pretty similar to iBeacon, but with one significant difference is that we're able to actually broadcast URLs via Bluetooth Low Energy. So this thing is fairly new, but one interesting way to interact with it is using Chrome on iOS. So I'm going to go ahead and pull down my notification, and you say right there, it says scanning for physical web objects. And it's going to redirect me to a website that's going to have an on and off button. And let me hold this up again.
I'm here.
You are? Okay.
Yeah.
You got it?
Got it.
I'm going to turn it on. We got it blinking. Let's turn it off. Perfect. So real quick, let me jump and show you guys the code that's actually making this all work. Let's start from the server. So the server is all written in JavaScript. The main library being used is Johnny 5, which is basically a JS wrapper for the Fermata protocol used by Arduino. So here we're just creating an HTTP server. When the board is ready, we're going to go ahead and register an LED on pin 13. We're going to start the HTTP server on port 3000 and start advertising the URL. And how this works right now is we're using Socket.io with WebSockets, and here we're setting up the connection and a listener on when the LED is on. We're just going to go ahead and blink the LED, and when we send the LED off, we're going to go ahead and stop it. The cool thing here is on the code for Android and iOS is exactly the same. There's really no difference, just copy and paste it over. You can see we have the component life cycles here. On initial state, we're going in and creating a new I/O. Right now, it's pointing to ngrok that I'm running on my local host. Again, Android the same, and the web version is pretty much the same. The only difference here is instead of rendering a switch, I'm rendering a button. So I think the cool thing here to think about is that from the board all the way up to our clients, both web and mobile, we're programming this all with JavaScript, and that they're all sharing the main dependency. What we're using for this is Socket.io. So if you guys have any other questions, you can definitely reach out to me tomorrow. I'll be around. So hopefully that was pretty interesting. Thanks.
Cool. Very nice.
Cool.
See, it works.
It does.
Nice.
Thanks.
Thank you very much. So next one up is Alex Ferry with a talk called Moving from Angular to React. So right here?
Yeah. Wait for my laptop to wake up.
So we're doing exceptionally great with time, I have to say.
Can I take this?
Yes, yes, feel free to do so, but be advised, use force. It's the Russian style,
Hello?
add more force. And just, have it pretty close. Yes,
Hello?
That is exactly the distance. So 5 minutes.
Hi, everybody. Today I wanted to talk to you about moving from Angular to React. My name's Alex, but first of all, I know it's been, you've listened to a lot of talks today, and I want to grab your attention straight away. So today, I'm going to talk to you about what was good about moving from Angular and what was really difficult as well. So for me, leaving Angular was really, really emotional. I spent a year building an Angular app. Angular is this big library that you spend a lot of time investing about learning. And so leaving that is all kind of like, you don't want to start again, but you have to do these things sometimes. So I started learning React, did a couple of basic tutorials, and I'm like, I'm the master of React now, this is easy. And then you realize, yeah, I can't make an app just with this. I've got to learn all these other things. And I remember sort of looking at Flux, and someone showed me this diagram, and that didn't really help. And then I remember going to work one day, and I'd built this really basic React and Flux app using Facebook Flux. And the guys at work were like, what? No one uses Facebook's Flux. What the hell are you doing? And I was like, another one of those moments where definitely kind of confusing at the start. But I think the moment came for me when I realized that React is just a view layer, which is kind of confusing when you're first moving over, because people talk about, oh, you should use React over Angular, but really they mean you should use React, Flux, Redux, React Router over Angular. And maybe that would have made it a bit simpler, but I get there in the end. And the shift in thinking was a big change as well. But not that it took a long amount of time, it's just actually, it felt really good compared to this magical scope that you're updating, and definitely felt better. I don't know if this is because I came from Angular necessarily, but I was doing it really, really wrong for a long time. I had a lot of state in my Flux stores and a lot of state in my components. I remember reading an article about container components, and that definitely cleared things up for me. So in relation to things that I thought were the same from Angular, that sort of rang a bell for me, I thought that React components definitely reminded me of the Angular view layer and Angular controllers, in the sense of you've got a view layer that you're calling methods. In Angular, you'd call methods on your controller, and in React, you're calling methods from within your component. And React stores reminded me of Angular services or Angular factories, in a sense that it's the place where all your state is stored. But now, I thought it'd only be nice to leave on that slide after the first slide. I'm a big fan of React. Really enjoyed the talks today. Thank you very much for listening to me.
Cool. Thank you so much, Alex.
Thank you.
So we have number 10, Evan Schneider, to come aboard up on stage. Evan, somewhere? Yell yes if you're coming. That's a yes. Okay, cool. So the name of the presentation is Rewriting History with Predicates. That's the idea. Great, cool. So come on board, plug in your computer, pray to the computer that it's gonna work. Yep, that's it. Want to plug it in?
I do want to plug it in.
On the other side.
Thank you. All right.
How we're doing with the screen? We're not doing with the screen.
What's going on?
Nothing's there. Let's try with the lightning port. That sounds better. Is it better? Well, we have visual right now. Fantastic. So you have 5 minutes. Go for it.
All right. So I'm Evan, and about 2 weeks ago, I got the idea to, So 2 weeks ago, I got the idea that I wanted to give a lightning talk on something that I was playing around with. I saw Dan Abrams' talk on Redux. I thought it was very cool. And of course, I saw his dev tools, which I thought were really interesting, which led to this really interesting idea of maybe, you've heard about Redux today, maybe being able to capture all these actions and make use of them has some interesting possibilities that are like legitimate to use in application. So what I wanted to play around with was what happens when you basically always produce your state from your actions. And of course, I then had to do the obligatory to-do app. So that's what I did. So about, that was, I don't know, back in September. 2 weeks ago, I thought, hey, I have this to-do app. I should talk about it. So anyways.
It is your fence.
Closer? Yes. That's better.
That's fantastic.
Great. So I thought, cool, I'll travel to a different continent. I'll do a demo where I show how you can do this with drawing. And I definitely will not get distracted. So I got here about 4 days ago. Anyways, so what I thought was interesting was just the ability to go back and change something and then go forward. I'm not exactly sure where the code is here, but clearly you see it didn't actually stick. Anyways, so the other demo that I had is here, where what I wanted to do was take this idea to a more applicable place. So my entire idea is that you can be able to go back and insert something, and it'll either be able to affect the things in front of it or the things behind it. So the actual state that your application in, this actual state that your application is in is determined pretty much at any point in time, which allows for a few things. That if you saw the Circle C article about a year ago, global state local concerns, they demonstrated with ClojureScript and Elm how you could basically serialize an app state and bring it up somewhere else. That's really cool. There are lots of debugging abilities if you basically have your state be serializable. But if you have your action be serializable, then you have this opportunity to sort of replay history. So I really wanted to play around with what that allowed you to do. Oh, hold on 1 second. So, there we go, there's Canvas. So unfortunately, there were a lot of things that I tried to do here which I was not particularly capable of, such as a lot of time with Canvas. Anyways, so what I wanted to show was just the ability to do some arrays that was more interesting than just a to-do app. But what I'm hoping to ultimately show with this is, oh, no? Okay, well, what I was hoping to show with this is that there's a real opportunity to basically take this action pattern and take advantage of it to either send that information back to the server or simply allow you to enter into very different application states that would have been complicated before but are easy when you can simply change how you were routed there in the first place. So it's the ability, and it's ultimately fairly cheap. There's only one problem, which is basically when you have to do any async work, because that's naturally side effecting. So I have another version of this to-do app that has a login, which, anyways, I don't have a link for that. But there are ways around that, but there's just a lot of interesting opportunities that you have once you can move from one place to another and begin to, I guess, change what you have. Let's see. Does this code work? Is it working right now? Yeah, cool. It works. It says watch Evan. That's me. So it's not a practical, it's not like a very useful UI feature in a to-do app. Who the hell wants to go back and change something like that? But I think that there are a lot of opportunities where actually just the ability to change the course that you took to get there has opportunities. I think that's the intent.
Great, cool. Thank you very much. And since we ended earlier on 2 or 3 presentations, I discussed with Javi, pronounce it right now, to present the toolbox because we have enough time to do that. So please do a round of applause and let's give a couple of minutes to Javi for this. Cool, go for it.
So, this is display. Yeah, there. Well, just a minute because it should be turned there. That's way better. So, sorry for being here again, I guess. I wanted to show you the playground here because it's a way that you can use to check the components, the API, and try them live before if you decide to download the library, clone the repo, or whatever, start using it. So we built this playground using the same components we are providing as a dependency, fake dependency with Webpack inside the same repository. So here in the left side, you can see a list with all the components that we have so far. And right here, you have a little button so you can open this editor and start working with the components. And you can change the code right here and see the changes live. You can close the playground at any time and go to another component. And you will see here a little button to load the example in the playground and play with it. In the documentation, you will see date picker, properties, and methods for each component. So that's all I wanted to show, actually. You can see some components, like probably it's not what? Sorry. You can see the progress bar, for example, right here. You can see probably the time picker over here, which is quite nice. And you can, I don't know, it's just like the Android one. You can also check the menus, navigation components. We are basically giving all the components that we think you will need to create an app for now. So, well, I think that's pretty much all I wanted to say before that, just a couple of minutes. So,
great, cool.
Yeah.
Thank you, Javi.
Thank you.
Definitely worth it. Thank you.
Thank you.
So we have the last talk. So guys, stay here for the last talk. It's Patrick Neskudla, I'm sorry. Almost right. Connect your, there's the HDMI cable. And are we there? We're not there. No. That's a no. So let's use the lightning cable. It worked last time. Here it is. Da-da-da-da. We're better? Yes, we're there. Cool. So you have your 5 minutes. Go for it.
Okay, so thanks for having me. Like, I literally created this presentation in the past 60 minutes, and there was this question before, like using Meteor instead of this Firebase stuff. And we're talking about fast prototyping with Meteor, tight deadlines, people who never touched NPM but have some knowledge of JS. And that's basically what we see at our place every day. And so why should you use Meteor? Because of, well, fast prototyping, the awesome DDP stuff built right in, and this really cool real-time database sync. Why shouldn't you use Meteor? Because those build times are really horrible when you're working on stuff. Getting NPM packages in is really ugly, and the build times are really, like, they are horrible when your project size increases. And wrapper packages may not be up to date. So what we came up with was using Webpack, basically, and we are building our apps basically outside of Meteor, use Meteor stuff inside our apps, inject the code into the Meteor project, and we actually use Webpack to build our stuff. And there's a really nice like starter package which you can check out on GitHub. I'll tweet the link via my Twitter handle too. And yeah, it's somewhat ugly, you might think, but it really gives you benefits of being faster with this prototyping stuff and real-time data synchronization. And it's, well, for us it greatly outruled any other ideas and solutions. And it also outruled Firebase because we needed a solution that worked on-premise with all the data on the client's place. So yeah, we also implemented Redux in this, and we basically handle the handle only the interface state with Redux. And it does not represent data, which is available in Meteor's MongoDB. So we use React Meteor data mix in to subscribe to data from the database. So this is like 2 separate stores for 2 separate types of data. And like you might ask yourself, what is this really about? And depending on the time it took us to get to this slide, I'd like to show more demos, but we don't need to do this because Reactive 2015 was nice and bought me some time. And this is a story actually about how immutability can't be applied in real-life scenarios and also reacting to stuff because some things can't be tested, you know? So I would like to say hi to my girlfriend, Mona, who is standing right at the back. And like I just want to say, it all started with a hi 2 years ago. And tons of weird dialogues, which eventually led to us meeting up and you joining me when I went to Bratislava and I had a gig like nearly 2 years, more than 2 years ago. And I thought at that time, this is the girl I want to be with. And we eventually got together. And so, yeah, thanks. I started to learn more about you. I started to open myself up for you. We started to deeply care for each other. And yeah, in the end, we were not able to let each other go. I love you for tons of things, which I don't want to go into much detail now, but yeah, you ask me often why I love you, and I love you because you always try to cheer me up when I feel bad. You surprise me just because you want to see me smile, and you challenge me to be the very best. And eventually our lives suddenly changed last year when we got word that Emily was on her way. So now you're basically the best person I can imagine to be our daughter's mother. And yeah, I just wanted to say I love you. You're the most important person in my life, and I think it's about time that I ask you something, and I will just let the microphone here on this thing, and I'll just come to the back, if that's okay with all of you. No? Yeah.
Take the mic, take the mic, take the mic. Yeah, take the mic. Yeah.
There's the mic. So I literally prepped all of this in the past, I don't know, 37 hours or so. So I don't know which knee I need to get on now. I just, like, Mona, I'd like to ask you in front of those, I don't know how many people, would you, 500, I just heard? More than 500 people, so you, yeah. Would you want to be my wife?
Congratulations.
Test, test.
We hope for a yes, so we have something prepared for you guys. Come on stage. Oh, what?
I'd say everything went better than expected. No.
So this is a gift from the Reactive team, and congratulations, Mona. You have a developer, yeah? Watch your eyes. Whoops. Da, 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 da. Do we have some music for this?
Dum, 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 dum. I'm shivering like I'm gonna like let this fall down.
No, just, you know, cheers each other and kiss.
Cheers.
So it's on the camera. Oh, I'm sorry, no juice, yeah. It's one happy man.
Thank you.
You're welcome. And on this very positive note, I would love to end today's sessions of Reactive 2015 with an unexpected ending, but it's very nice. We're very happy about it. And guys, we wish you a long and lasting happy marriage. Cool. Thank you. So just a couple of organizational stuff before I let you go. Tomorrow morning we start 8:45 with the first presentation. So we're early birds, but it's going to be okay. That's the first thing. And the second thing is that for the guys and girls to have they're invited to the cocktail party. The shuttle transfer is going to be waiting downstairs. So between 7:30 and 8 p.m., be ready. You're going to find navigation and stuff. So if you've got an invitation, please go there, and we're going to transfer you to the cocktail party. Thank you. See you tomorrow. Thanks.